for everything that is happening to all other people. Everything that you do, think, act, etc., depends on your friends and the friends of your friends. So basically, like attracts like, and Christakis, when he used to be with Harvard, he became known for his works, where he actually proved the social impact that is so fundamental. Like, for example, different diseases that were thought to have nothing to do, like obesity, for instance, or heart disease or depression, etc. So, and he proved the point that these are directly linked to social impact and the quality of your social ties. So, transmission of information among living beings is so critical and so important, so essential for survival, that any interruption of the transmission causes a cascading negative reaction that causes pain, and this pain causes cortisol, and if chronic, this can cause multiple outages. And Matthew Lieberman, by the way, why our brains are wired to connect, actually talks about the exact same thing. So the physical and social pain actually come from the same centers and is processed by the same cortex in the brain. So in any transmission, such as human isolation, or when you become ostracized from society, this causes multiple negative physical representations, such as if, let's say, during evolution process, you keep contact with the society to survive, that's great. But if for whatever reason you become like a black sheep, so this causes multiple stressors. So that means that if I lose my social environment that has been supporting my survival, that means that the most important thing for me is to find something else, to rejoin social context, to rejoin networking. But if, let's say, I'm isolated for whatever reason, the stressors become higher and higher, they become chronic, and they cause multiple illnesses such as bad sleep, obesity, smoking, drug addiction, depression, manic depressions, immunity disorders, gene expression malfunctioning, cortisol going through the roof, blood vessels basically rupture, heart disease actually goes up exponentially, etc., etc., etc. You get these cascading factors that are all super negative, and that eventually lead to your death. So, by the way, for the first time ever, they actually discovered this in clinical practice. They actually showed it back in the 90s in the city of in the community of Rosetta. Rosetta actually in the state of Pennsylvania. So Professor John Stewart actually went there for the lecture. He was head of Oklahoma University at the time. So after his lecture, he basically was talking about the heart disease and all that. It was this epidemic of heart diseases and cardiovascular disease. It was almost like an epidemic. And so after the election, so the local doctor said, look, we don't really care about heart disease because, our mortality here is only half of what's the national average. So people don't die from heart disease here in our community. And to which he replied, like, that's BS, no way. So he didn't believe him. So he went to check. So he went on a field trip. He said, okay, I need to see it. Seeing is believing. So he had this whole troop, this he and his people, this whole team go to Rosetta and start the study, and they actually discovered that people, they drink wine, they eat fatty pizza, they smoke cigars. So it's not about diet, really. It's not that they're super healthy or something like that. So you don't see any bodybuilders in that Rosetta community. So I mean, they were puzzled, like, what is the reason? What is this mystery? Why they live so well, and why they don't die from heart disease and whatnot. It turns out to be that it's about the quality of social connections. And indeed, in Rosetta, the mortality is only half the national average. But there was this guy, John Brown, is a sociologist, and he said that in Rosetta, people had lower rate of heart attacks than the nearby town of Bangor. Cohesive family and community relationships played the main role in maintaining health, he says. So, so it's the social impact. See, very strong family ties, and so that was the first time it was officially mentioned and studied. So the impact of social well-being. And then in 1988, they did the meta-analysis in the Science magazine. So tens of thousands of people joined it. So there were 8 different research. So and it established a correlation of a poor quality of social relationships and higher mortality rates from heart attacks and other cardiovascular disease and other disease. Oh, and then there were multiple follow-ups. This Julian Hall Lundstedt, for instance, everybody knows her. He did the meta-analysis. in 2010, very powerful, said that the health physicians, the trainers, the mass media need to accept the fact that the social connections actually have a powerful impact on the health of adults and children, and is a powerful factor. And or the social status, for example, right? And cardiovascular diseases. Again, it's a marital status and risk of cardiac disease, a systematic review. So more than 2 million people participated, and again, the exact same result. The difference between people that live alone or divorced or have poor family relationship, or maybe you lost your wife, you lost your children, or you lost your husband, or you got divorced, or have unhappy marriage. So there's very strong correlation. Like we're talking about dozens of percentages. This is 2013. And again, the marital status and survival in patients with cancer. And again, strong correlation between the cancer and the aggressiveness of cancer versus your marital status. So, I mean, it's been run for 4 years, like 1.2 million people participated. It's a huge, huge study. And of course, adjusted for all the studies like demographics, like types of therapy, chemotherapy, whatever. So it turns out that when it comes to colon cancer or lung cancer or mammal cancer, so marital status is actually more important than any form of chemotherapy. Just think about it. And this one is the University of California in San Francisco. Again, the multivariate adjusted analysis. Women who were socially isolated before diagnosis had a subsequent 66% increase of all-cause mortality, mostly breast cancer. So it shows basically that if you're socially isolated, for instance, a woman in prison or a woman that is alone or divorced, so you have a 66% higher risk of contracting breast cancer. And this one, another one by the same Julian Horlusat. This is 2015, 3.5 million people participating in all continents. So the impact of social relationship on mortality, it actually is more important compared to bad diet or obesity or lack of activity, etc. And this one, it says that loneliness is a major health risk for older. And the COVID situation, by the way, age, I understand, but number 3, in terms of impact, is loneliness, social isolation. Interestingly enough, right? You can call it almost like a genocide. Anyways, so from the evolutionary standpoint, so this is so important. It is so important to keep the ties, to keep the connection with your society, that if you don't do it, it actually life loses meaning. So you become purposeless. And by the way, in 2019, the Michigan University in May came up with a strong correlation between the purpose in life and the longevity. So people that have no purpose in life, that lead life without purpose, actually die sooner. So, they say the people that are purposeless have 2.43 times higher risk of dying. So having a purpose in life actually leads to a happier, longer life. So it is more important than smoking, alcohol, drugs, or physical activity or diet. Okay, so we continue. What about the psychology, the psychic health, the mental health? So this one is from Harvard. It's a famous research. Over 75 years, by the way, it's been run continuously. George Valiant from 1972 to 2004. So. And he's basically says, and he was head of this research, George Valiant, he said that the people can have a successful career, lots of money, you can be a billionaire and have great body, but without supporting loving relationship, you will never be happy. See? And this one, brand new. So the relationship between dementia and loneliness, there's a 40% higher risk of becoming demented. So anyways, becomes that we are a derivative of social connections. So the better the social connections, the healthier we are. Okay, and by the way, the same goes for the teamwork, for the corporate environment, etc. So if in your company you have bad spirit, you have lots of internal disintegration, so you can have multiple side effects. Because, what is a company? A company is a multitude of people that are united by the common goal. If something bad is going on in the company, of course, this will cause a cascading negative impact. So the exact same thing, because you can see a company as a microcosmos of society. So you see exact same correlations here. And this can cause negative effect on the people employed in the company and the company itself, on the shareholders and owners of the company. And for the clients, of course, the clients suffer for sure, because unhappy unhappy employees means unhappy customers. And by the way, over 10,000 participants in Russia. So, and they say that many people have issues with organizational communication, and that goes to culture, values, and that causes negative impact on their lifestyle. And say 86% say that we need critical improvement in 70% say that managers are not being trusted. 88% say that they don't accept their to take responsibility for their mistakes. 54% say that they all fight for the interest. 48% say that they have no feedback. 53% say that they don't speak what they think, or they're not engaged, or they're not, or misunderstood, etc., etc. So it's a powerful factor. So, and for any organization, it is absolutely important to have this collective intelligence. There's the factor of collective intelligence. For the company to be successful, this has to be very strong. And the performance difference comes down to the ability and the capability of people to feel good, to have that collective connection. So, and the researchers are basically speaking about this ability of people to support collective intelligence. Yes, or like cognitive intelligence actually is a direct derivative of the quality of your relationship inside the team. And teams that have that connection, they excel. They become more competitive, and they ultimately win. So it's an interesting thing. And by the way, this study says that having more women inside those groups actually has a major positive correlation. So add more women. And speaking of communication, there's a foundation here. So the two types of communication, the so-called directive control and open dialogue. Directive control, and when this one imposes on the other, when there's manipulation, there's lies, there's violence, there's high internal costs, and the other one that is based on open dialogue. And this goes to company, family, etc. So there has to be a safe and organically evolving environment. So the system has to be organic to evolve and to be resilient. By the way, Roland Rust, distinguished professor of management from University of Maryland, actually speaks about the economy of senses, right? Basically, such as the inter-people relationship and the feelings economy. He speaks about the feelings economy. So managing in the next generation of artificial intelligence, etc. So, and I'm being very close to the timing because we started a bit late. So let me just say that, of course, look, the quality of communication, our communication, is absolutely critical for life, for our well-being, for our mental health, for cognitive health. And it, of course, also causing, if not available, of course, can cause dementia, can cause Alzheimer, can cause heart disease, etc., 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 etc. And let's not forget about the whole purpose of life, why we're here, because people sometimes either thinking about worrying about daily stuff. So here's a great quote, by the way, from Nyuta Federmeiser, the head of Moscow Hospice. She said that I have never seen people in a hospital that when dying would be worried about not doing something. So I myself speak about the performance, about the result, the time is of essence. But when people die, the only thing that they regret is that they haven't seen the wife, or they haven't seen the children enough, that they divorced, that they are lonely, and they have to say goodbye to this world being alone, or having not said, I'm sorry to somebody. So, and this one, Professor Zealand, so this is probably the longest and deepest study. So it says that basically the quality, the warmth in the relationship actually is the most powerful. So the most powerful thing, the happiness, is love. Full stop. That's what he says. So love, it's all about love. Love brings you eternal life. It's the fountain of youth. And hopefully this topic will be reiterated, of course, with multiple other speakers today. So I represent the School of Open Dialogue, by the way, myself. I'm very proud of it. So this is the source of my well-being, my power. This is how I'm happy, healthy, and high performance, because of my family. So thank you, Natalia. Carry on. Yes, thank you. Thank you, Dmitry. Appreciate it. And I think that's what it's all about. It just goes to show just how how deep this idea of health is and how many elements are there. It's pretty amazing. And their ability to, and our abilities and our success in life, of course, in many ways depends on and our awareness, of course. But so that's why the reason I'm speaking about awareness, being aware. Yeah, that's why there's so much discussion about aware, because the more aware you are, I guess, the better you understand the quality of relations. So with that, I would like to give floor to Mr. Anokhin. It's a Russian neurobiologist. Everybody understands him. Everybody knows him. He's the professor from the Academy of Sciences, so head of future brain studies and head of neuro studies lab and neurophysiology. So he's, by the way, the son of the famous Anokhin. He runs in the family. And he is the professor of the Moscow State University, also in charge of multiple experimental studies of cognition and brain. And Austin Konstantin is also a great scholar of memory mechanisms. Of course, he's a multidisciplinary research, the psychology, philosophy, linguistics, cognitive science, neural network, and brain modeling. Lots and lots and lots of other things. So, and Konstantin is one of the best when it comes to the studies in the world. He knows exactly what's happening in the world. He is very familiar with that. I guess, yes, he's doing very important work, essentially. So without further ado, I would like to give floor to Konstantin Anokhin. Please, sir, take away. Yes, thank you very much, Natalia. Thank you for having me. Appreciate it. And thank you for your introduction. Thank you. So no pressure, as they say, right? So, anyways, I try my best. Look, here's the point.
Видно, да?
So I hope you can see my slides. Yeah, absolutely. We can see your slides, for sure. So today, I would like to speak about something very, very important. The thing is that if you look at the past maybe 10 years, there's been so many organizational changes across the globe. And these changes have to do with brain studies, specifically in the brain studies. And Russia is also part of this movement, let's call it that way. So as president of Russia, specifically indicated, is the Russian Academy of Scientists, stepped in and prepared a dedicated and targeted brain study program. And as you know, it is officially supported by the government and is ready to be implemented. So, and I think it is very, very important in this regard to look at the global picture, at what's happening in the world, and in that regard, understand the role of Russia in this global dynamics. Because, of course, each prominent country will do its part. And I'm absolutely sure that each and every one will have to do something that others have not done. And it's very, very difficult. It's not easy. So let's have a look at this process. So, speaking of these global brain studies, so this is a United States professor. He said that 60 years ago, students that were trying to be at the forefront of science would become physicists. 30 years ago, they would go into molecular biology, and now they go into neuroscience. Especially guys that don't know what to do in life, they go, okay, neuroscience. They see it as the forefront. And by the way, many distinguished scientists said that the 21st century, that's what it's all about. So the brain is the same to the 21st century as the gene was to the 20th century. It's all about the brain studies. The brain studies is taking science to the next level and creates this quantum leap in competition. By the way, this is President Obama speaking to the Congress, by the way, when the U.S. brain study program, Brain Initiative, when it was launched originally. That's what he said, of course. And you see only some of the programs from China, European Union, Japan, Israel, Australia, South Korea, etc. Lots of also international studies, no problem there. And as you know, there's also a special United States session, the UN session that was also dedicated to this. So the multiple studies and also related to space studies and things like that. So why the brain? Let's talk about the brain. Why is it the brain? And, I would like to quote something that is very close to our debate. It's very close to what Natalia is going to have after this session. It's a very, very important thing. So what I'm saying is that, of course, we're talking about health because every third or every fourth person in this world has some sort of cognitive dissonance, some sort of cognitive issues. On the one hand, on the other hand, when it comes to our brain, on the one hand, we study the brain, the chemistry of the brain. We study certain elements, things that on their own don't have cognition, but at least for the past several centuries, we know that it's the brain and not the heart. It's where we have the cognition, that we have creativity, moral values, ethics, aesthetics, creativity, freedom of choice, etc. And whether it's banks, money, economy, presidents, etc., all that comes from cognition. So this gap between this gap is called explanatory gap, because there's the body and there's the mind, right? So from physics, biology, and chemistry to sociology, anthropology, and psychology, and we still have this gap. So basically, we live in one world. There's no two worlds. Essentially, it's the united one world. It's like if you stop a person on the street and ask, like, oh, "Do you have the brain? Do you have the mind, or just the body?" What do you think people will say? We'll say, probably both. Yes, and we'll say, well, I also have a soul. But there's nothing is separate. So we need to close this explanatory gap because it's all together. So Francis Crick, for the past 25 years, Francis Crick has been a great scholar of the brain. And he said multiple times that in terms of the humanity, it's not really about treating any particular disease, even though it's important, but it's about understanding the true nature of the soul. As Francis Crick said that. So it's a more holistic approach. So I believe that these kind of studies, understanding the connection between the mind and the brain, will have a far-reaching consequences. And look, once we fully understand what brain and mind is, the level of our cognitive capabilities will switch and just go to the next level. And a lot of the things in this world will also be different. So how come that so many countries are now jumping on this bandwagon and doing all these studies? The thing is that there's been a revolution, and this revolution actually happened in the brain studies, just from a technology standpoint. So here at the bottom, you see different methods. This is a time continuum, and this is what we had back in the 80s. So, and you see different technologies that's being used. And every method, of course, has its power over time and space. And you have 30 years ago and you have today. So these are the same authors. It's the same article, but you see 2000. So 80s versus 2014. You see, look at how many different technologies had been born over these 30 years. And this just opens the door. It's an unprecedented capability that we've never had in the past. So, and this opens up, of course, tremendous opportunities. So no wonder that so many countries are now competing in this kind of studies and trying to be at the forefront of this brain studies, be it the United States or European Union or China or Korea. And there's, of course, the Human Brain Project. Everybody knows this Human Brain Project. And also in the United States, the U.S. Brain Initiative was also announced in 2014. So a Japanese brain study joined it. Israel Brain Technologies also joined in. And in 2016, Korea joined in. So, and received government funding, the Korean Brain Initiative, and then Australian Brain Alliance, and then the China Brain Project that is currently being funded. And of course, a whole a litany of other international programs. So you have this International Brain Laboratory, you have International Brain Initiatives, Canada Brain Research. So the brain race is on, it says. It is true because it is indeed a brain race. And it's a very, very powerful brain. And the original ideologist from the European part, as you know, just shows just how much is being done and how much is being invested. So HBP is a flagship program, almost like 1.2 billion euros. This is a multi-year program. It's neuroinformatics, medical information, so brain simulation, so high-performance computing, neuromorphic computing, neurobiotics, and whatnot, etc. So it's a powerful, powerful program that's going to run for 10 years. Like I said, it's a very, very powerful initiative. So many things to be done. Just look at this. So you have neuromorphing, neurorobotics, ethics in society, etc. So many different things, so many different areas. So speaking about the brain initiatives in the United States, that's 2014. So it came a year later, after 2013 in Europe, and it has a totally different approach. So it was designed during a small conference in the UK that was done by the Royal Society and Recovery Foundation. So, and it features mostly different professionals in nanotechnologies. It was originally a genetic engineering nanotechnology conference. Well, it was just a little bit of neurobiology. So during this boutique conference, they thought that now it is the time to make that quantum leap. So they went to the U.S. President, which was Obama at the time. So they came up with this paper. And the president office started discussion. So they launched this discussion, and I think it took about a year to get the things done. And then at the end of the year, they announced this initiative. And that was also followed by workshops and conferences. So throughout the year, some of the leading neuroscientists of the United States participated in this program. So the priority of this program is technology. So this is primarily a technology conference, a technology initiative, but technology not in a traditional sense, not in the way we tend to use in Russia. So what they mean by technology is technology that enables you to better understand how the brain works. These are new disruptive breakthrough technologies that allow you to have a totally different understanding of how the neuro element of the brain actually works. So the first one. The second one is about the cellular level of brain study. So basically studying the brain across the board, not just the cells, and not just the cells and their comparison. So what we know as the brain, of course, the cells, and just like the genes, for instance, that together have the genome. So unless you go to the level of genes, there's nothing you can do with the genome. Unless you go to the brain cells, there's nothing you can do about the brain. So you need to go at the deepest possible level. And need to study the minimum building element of the brain to understand the true functioning of the brain. So according to this initiative, as it says, it's all about cellular studies, brain cellular studies, and through that fundamental level, elevate it and understand the highest cognitive function. So understanding how these patterns turn into emotions, perceptions, sensory, and sensory perception of the world become what we call psyche, right? So there are seven big areas. So this is a 2025 brain initiative. So 15 leading brain scientists participated in this. So 7 top priorities. One is discovering diversity, so to identify and provide an experimental access to the different brain cell types to determine their roles in health and disease. So then second is mapping at multiple scales. Then the brain in action, so producing dynamic picture of the functioning brain. Fourth is demonstrating causality, so linking brain activity to behavior, such as the changing neural circuits dynamics that, when changed, produce a different result. Number 5 is identifying fundamental principles, such as producing conceptual foundations to understand the biological basis of mental health. This is what we lack, by the way, to fully comprehend the highest function, the supreme function of the brain. 6 is the advancing human neuroscience, such as developing innovative technologies to understand the human brain and treatment of its disorders. And the 7th, of course, from Brain Initiative to the brain itself, which is a fully integrated new technological and conceptual approach to the actual brain. Okay, that's the Brain Initiative. So it's very, very important to underline the fact that it's a fundamental study in the first place. So, and it's a fully published document. You can find it online. It's the official paper. And says that one of the reasons why we don't understand how the brain actually works, and the reason we don't have efficient therapies for brain disease, is the fact that we lack just precise knowledge about how the brain actually works. So this program is meant to tap into this mystery, uncovering mechanisms that bind together different processes in the world. So from just creating pills and treating specific elements. Oh, by the way, Chinese program, speaking of that, the Chinese, they specifically distant themselves from this topic. They say, no. Let's study the disease. Chinese want to study the disease. So not everybody in the same boat. So it's just a different ideology. United States versus China. Oh, there's another brain initiative called DARPA. So it's also huge and it has big government funding, but it's a lot of that has to do with the military, such as the DARPA and so ARPA. So, and one of the key focuses of DARPA is the neuroengineering system design. It's very, very important to understand where we're going with that, and they basically focusing on invasive approach and technology, such as stimulating brain through, which is direct invasive application to brain. And one of such programs is called NESD, the Neuroengineering System Design. Basically aims to win approval from the U.S. Food and Drug Administration, and within 4 years, they would like to have a wireless human brain device that can monitor brain activity using 1 million electrodes simultaneously and selectively, stimulating up to 100,000 neurons. So basically, going to implant a chip, right? And this chip is wireless, so and it can actually monitor brain activities up to 1,000 neurons. That's the whole point. So anyways, oh, by the way, let's not forget Elon Musk here. So, okay, the Neuralink. This is privately funded, of course. Creating a neural lace is the thing that really matters for humanity to achieve symbiosis with machines, right? Yes, Elon Musk, of course, they also government funding, private funding, etc. But of course, Neuralink is a very cool technology. I already have it. They've already done it. So essentially, they have this sewing machine, right, for a minimally invasive neural recording. It's similar to DARPA, but it's a very gentle DARPA. You can call it DARPA Lite. So it's an invasive technology, but it's almost like a brain sewing machine. As you can see here, so it's a tiny window that they cut in the brain and inject this neural link. Pretty cool. Yes. What else? The China Brain Project. Let's talk about the China Brain Project. Actually, China went a different way. China says, look, our program is all about, it's like an airplane. An airplane has a body, it has wings, It has engines. I would like to understand the the functions of the brain. So, and China, as you know, has more of this than any other country. Monkeys, yes, they have monkeys, more monkeys than anybody. So you know that the population of monkeys that will be primarily subjects of the studies is similar to the population of the Chinese themselves. There's over more than 1 billion monkeys in China. Think about it. So that means that China can actually use primates, monkeys, to study their brains. And there are as many monkeys as there are Chineses. So, anyways, the point is to treat different neurological disease. And China says, look, we have the most neurological and other related diseases in the world. China says that we have the biggest database and the most data because therefore we have the most material than any other country in the world. I would like to tap into this. Brain-inspired technologies and artificial intelligence are also part of this. Okay, so it's one body and two wings. So building the core and developing the applications. And there's also Australian program, the great mission of our time, Australian Brain Alliance. And there's also the Korean one. And they all sort of go along the same lines. Yes, all studying the higher brain functions and things like that. Some private initiatives, like big companies like Google, Facebook, IBM, Neuralink, of course, cognitive computing, Google with the Google Brain, Facebook with the Neuralink, etc. So lots of initiatives, and these are big money. So you can look at the numbers here. So why am I saying that? So the reason I'm saying is that these programs are coordinated because there's the so-called Global Brain Initiatives, there's the International Brain Initiative, or Global Brain Initiatives, the multiple countries part of it. So in 2016, it was launched officially in New York during the United States General Assembly. By the way, President of the Russian Academy of Sciences during the Supervisory Council and actually talked to the President of Russia and on behalf of the Academy of Sciences and the Moscow State University. So the idea was to create the same program in Russia. And the President of Russia supported it. And within literally days, you can see it here. It's a snapshot from the timeline of the Human Brain Process Russian initiative. Russian President Vladimir Putin said that the Human Brain Research Project will be supported by the state. Voila. And basically since April of 2019 and all the way to April 2020, we've been working very specifically at the Academy of Sciences as a big team. A team from different walks of life. So we've been together working on this big federal project. So the program is ready, and in April we submitted it to the government. So as we speak, they are discussing its future development. And look, Russia is a huge legacy here. So Russia used to have, by the way, the best and probably the most extensive brain studies program. By the way, Russia, if you go back in time, I mean, throughout the mankind, Russia has always been probably on the forefront of brain studies. It actually started with Mikhail Sechin. As you know, the Sechin, the founding father of neurostudies, and he was the first one to study it, and he did a lot. You can see the snapshot from this old paper. That's 1863, of course. Then, of course, the Pavlov school. Everybody knows Pavlov. This is Pavlov, by the way, is a famous physiologist, speaking during the World Congress of Physiologists in 1935 in Moscow. So, and that was, see the stats, by the way. In 2015, we only had 24 physiological laboratories, but in only 40 citations per year. But in 1935, we had 388 laboratories and 700 citations. So think about it. Almost a century ago, Russia was like a powerhouse. Pretty incredible. So the International Brain Research Organization, IBRA, was initiated in 1958 in the United States. In the Soviet Union. In Soviet Union, basically. Right, and at the same time, in 1960, another organization, is also an international program called Interbrain, that for the 30 years, all the way to the breakdown of the Soviet Union in 1990, actually was collaborating with multiple other countries. So there's 24 countries that's been involved in this initiative called Interbrain. It's a huge, huge program that's been studying everything from brain evolution to studies ontogenesis and different species, all the way to higher brain activities, such as language, speech, psychological pathologies and things like that. So it's a big, big initiative. So that's what I'm saying. This Russia had tremendous legacy. But at this day and age, we, of course, has been talking to the government many, many times about the representatives of the Academy of Science, because Russia has a tremendous legacy. It would be a shame to lose it. And this is the future. This is the future. This is what we need. So no other country, and it's a crime to actually miss out on this opportunity. This is the first letter that we wrote. So this is myself and Sergeyev as well. This is a joint letter. But unfortunately, only 13 years later, so we now finally have this initiative. 13 years to persuade the government. So it's the finance, it's the publications, it's the instruments, and it's the people. We are lagging behind across the board. Yes, we have a tremendous legacy, but in terms of the state of things, unfortunately, Russia is far behind. So the United States, China, so these guys actually started. And ironically, when the Soviet Union was breaking down, it was the 90s where the breakthrough started to happen. So we missed out naturally on a lot of these things. We missed out on the funding, we missed out on the technology, we missed out on a lot of these things. Just look at the society. The United States, over 50,000 scientists. China, over 5,000 scientists. Russia, only 500 scientists. Just think about it. In the United States, they have dozens of universities, dozens of think tanks, and hundreds of graduates on the neuroscience. In Russia, basically a couple of dozens, maybe 10, 12 people per year. That's the most that we give a year. So, of course, we have the high school economy, some other things, but it's nothing. It's a drop in the sea. And Russia needs to do a lot more. We have some initiatives in Kazan, for instance, and in Moscow, but it's nothing. It's just not even in the same league. And if you look at neuroscience alone, for instance, like every single year, 8,000 students graduate. 8,000 students graduate in the United States. If you look at the number of scientists, it's even more staggering. So the Neuro Society is over 50,000 members in the United States. In Russia, only 500. So that's the people. Now, the technology depends on the funding, of course. So 40 units versus 1 unit in Russia. Think about it. So X-ray, functional, so like specialty MRI machines. They're not clinical, but research. In the United States, they have over 124 of them are state-of-the-art. In Russia, none. So, and only 2 regular ones. Or multiphotonic microscopy. So, in the United States, they have 63. In Russia, they have 3. So, funding. What about funding? This tremendous amounts. Look at the U.S. Brain Initiative. Look at how much they invest versus how much we invest. Now, what about publications, scientific papers? This is
всем этим багажом. По данным SGR в области...
So according to SGR, as far as the neuroscience, Russia is currently on the 26th place. After Turkey. Even Turkey is ahead of us. Okay, what to do? So, look, when it comes to my own opinion, despite the fact that there's so many studies and publications, we still don't understand the most important thing. So the main breakthrough is still out there. So we still haven't tapped into the main mystery. This is what was ahead on the second slide. So what is this brain? How do we think? What is this cognition thing? We don't have the fundamental understanding from the neurological stand of things is how the cognitive function different from everything else. What is the essence of cognition? How is it happening? So where does it come from? Your subjective feelings, sensations, memories, where do they come from? And the reason for John Eccles in this interview, science interview, 1968, over 50 years ago, actually, he's a future Nobel Prize winner, and over 40 years of research, he basically said that you need to be at the ground zero to understand that over 95% of all research have nothing to do with the theory. It's all rubbish. So it's quantity over quality. And unfortunately, there's actually even higher percentage of trash studies, so let's call it that way. There's so many different opinions, so many different conclusions being made, but look, eventually it's all limited. And I think that we're sort of missing the trees. In many ways, we're missing the trees behind the woods. And another Nobel Prize winner in 2019 said that we don't have the logics to convert a neural activity into a thought. So we still don't know how it's done. And this is the fundamental issue. And this is our chance. This is where we can excel. This is where the breakthrough can happen. So Jim Watson, by the way, a couple of years ago when he was speaking in China, he said that it's an interesting time for neuroscience because the main discovery is still to be done. He said the main discovery is still to be done. So it's an interesting time because it hasn't been made yet. So the key discovery, the main door is still closed. So how do you actually store information in the brain? So that's the holy grail. Right? Not just biological information, cognitive information. How is it stored in the brain? And he says that this is the same as the way we store information in DNA molecules. That's incredible. And then he says something that I would like to join. So we don't really know where this discovery will happen, whether it's going to be China or somewhere in the West. But I like the idea, the fact that one or maybe two independent researchers that are not connected to tradition can just come up with it. And this answer will come from cognition, not from trials and errors. Of course, trial and error is important. It's an experimental study, but we need the big idea. We need this big bang. And unless we have the big idea, we don't really know what to do. So, and as he says, I think it's a good time for China or for the rest of the non-Western world. But then he says this big idea can come from anywhere, even from Russia. So just to recap, this is the final slide. So this is what we need to do, as we believe. This is what we need to do in Russia. So we need to reinforce Russian neurological capacity, especially just to revitalize all this tradition that we've had. Honestly, of course, we need different instruments. We need technology for sure, because we are drastically out of date. In terms of fundamental studies, we, of course, can also link our studies to physics and mathematics, because Russia has always been strong in mathematics and physics. That's where we are tour de force. So we need to collaborate. The neuroscience it's not competing, it's sort of isolating. We need to collaborate with the physicists and mathematicians that are world famous from Russia. And it's ideally, of course, we need to also change life sciences. So also the social and humanitarian sciences, just such as, in healthcare, for instance, when they tapped into the genome, a lot has changed. So we need to collaborate, of course. So STEM sciences and life sciences should definitely collaborate. And of course, we need to prepare people, and we need a fundamental brain studies program similar to the US Brain Initiative. And this Russian Brain Studies program is what we and I myself came up with. That's all from me. Thank you. Thank you very much, Konstantin. Thank you for this overview. So, by the way, guys, if you have any questions, we have this Q&A button. So press the Q&A and post your questions. Of course, we're going to have a panel discussion, so don't worry about it. So we're going to join us for this Q&A. And just considering the timing, I will pass it on to the next speaker. So Natalia Semyonova, and she is also a scientist, and of course she comes from the Psychiatry and Neurological Center of Bekhterev. You can call it the Prime Institute in Russia.
Который курирует и отвечает за организацию психиатрической неврологической помощи в стране.
So they're mostly doing the neurological studies. They treat neurological disorders, so they know exactly what's happening in Russia as far as the cognitive health. So they don't just deal with the psychic level, but also it's just pure neurological diseases that we fight on a daily basis. Okay, so please, Natalia, floor is yours.
Добрый день, уважаемые коллеги. Хочу поблагодарить организаторов конференции за возможность.
Thank you, everyone. Thank you for joining us today. So I would like to speak about the epidemiological situation around the neural health in Russia and the world. So as a scientist, as a representative of the National Research Institute for Neurological Health, and let me just right off the bat say that we are mostly into applied science, of course, not the fundamental science. So I'll speak about the actual situation on the ground, in the applied areas, i.e. in a daily life. So I hope you can see my slides. Let's begin.
Хорошо, тогда пойдем таким образом. Коллеги, давайте сначала остановимся на понятии определения психического здоровья.
So first of all, let's define mental health to begin with. Let me spend just a couple of moments of my time just to give you definition, okay? And to define cognitive health versus mental health. According to WHO, is a well-being and a well-being where a human being can actually exercise his capabilities, can resist stress, can be productive, high performance, and can be a productive member of society. So in this particular regard, I believe that cognitive health is a lot to do with personal well-being, personal health, personal happiness. A lot of that, surprisingly, is to do with just how happy you are. So this is a mental health. So this is the composition of the mental health. This is what, I mean, the psychology, the psychic level of the human being is. There are three big parts. Of course, there are like a certain, like more of a stable structure, such as psychic properties, psychic processes, and these mental processes that are mostly related to cognition, emotions, willpower, things like that. So when it comes to cognition, which is here circled in red, that is only a part. This is not everything. This is only it's a big part, but it's only a part of our mental health care. So speaking of cognitive health versus mental health, I think that we're sort of narrowing down the mental health because it's a bigger thing. So cognition, yes, but it's only a part. It's a sub-element of the mental health. And I think they're, of course, trying to reduce discrimination and stigma. But per se, mental health is not the same as cognitive health. So mental is bigger than cognitive. Cognitive is only about thinking, learning, and memory. let's say a person with good cognitive health is a person who can think, learn, and remember, okay? So therefore, cognition is an important element of the brain health, but it's only a part of the brain. So this is very, very important to understand the difference. So, and to have good cognition, to have good cognitive health means that the brain is fit and ready to carry out life and work demands. This is, by the way, straight from the US literature. This is just a copy-paste from the US. And they give the definition and the difference between the cognitive and the mental. So that's the big difference. So if you can think, if you can learn, if you can remember, in that particular sense, I think that you can throw baby with the water by missing out on the multitude of other areas where it's also very, very important. So I'm just warning you to not turn into this Oscar situation where you know that unfortunately the Oscar ceremony has been blamed for stigma and discrimination, and they missed out on a lot of important elements by trying to be too politically correct. So when it comes to cognitive function, so it should be just mechanistic. So of course, cognitive disorders have very clear clinical disorders, but we try to elevate ourselves to a high level. So mental health is, of course, an integral part of overall health. And if you look at the WHO 1948, it says that the mental health is a full physical, spiritual, and social well-being. So even if you have social mental issues, you can still be mentally healthy in certain moments of your time. So it's not a permanent thing, it's not a constant. Very, very important to understand that. So, and the level of mental health, or the mental health of society or the country, of course, has to do with social, psychological, biological, and lots of other factors. We all know that certain difficulties in life, certain problems at work, maybe violence, maybe sexual harassment, social stigma, unhealthy lifestyle, or just the physical health issues or violation of human rights. All these factors can cause negative impact and can cause mental disorders. Of course, there are also personal factors that make people particularly vulnerable and susceptible to mental health issues. And of course, there's also biological factors and things like that. So anyways, and it's a global problem, by the way. This is the plague of the modern day society. Over 100 million are suffering from anxiety and depression. Over 21 million people suffer from alcohol-related disorders. This is Europe alone. Europe alone, think about it. Out of 170 million people living in Europe, over 100 have anxiety and depression, 21 million suffer from alcohol-related disorders, over 7 million people suffer from Alzheimer's and other types of dementia. So over 4 million are schizophrenic, so 4 million bipolar, right, and bipolar-related diseases, and another 4 million suffering from panic attacks. So there you go, you do the math. So basically every fourth person in that moment in your life sort of is facing some sort of a cognitive and mental issue. And according to WGA, so this has to do with urbanization, poor environment, so information pressing, technogenic related things are also brain damage and preborn conditions. Also, damage to physical and reproductive health, migration, lots of things. So social, economic, and all the things in our life, essentially, all of them are causing this kind of effect. Oh, by the way, and if you're not, unless you're a professional, of course, let me give you a context. This is a classification. An international as a classification of different disorders, okay? This is a well-known international classification, so this is what we're currently using at the moment. So this has everything from schizophrenia to... And this is also for adults and for juveniles as well. So you see all sorts of emotional disorders, behavior disorders, psychic disorders, schizophrenia, and dementia, etc., etc. So lots and lots. This is a very, very well studied area. That's what I'm saying. So the question is, why would you even study mental health of the population? Why is it so important? So the thing is that so when you study a particular person, an archetype, you can infer, you can connect the dots. And therefore you can actually look at patterns, and therefore you can then launch particular counteractive measures to combat these kind of elements in the society. So, of course, we've been running the statistics for years, such as, total number of neurological diseases versus total number of populations. So we have a certain formula. It's usually per 1,000 people. And the spread, of course, the spread, such as the prevalence. The prevalence meaning the total number of cases per 100,000 people on a 12-month basis. This can be primary and this can be secondary. So this is what we've been tracking for years now. And this can be any particular disease. So, okay.
Социальные изменения, которые проходят в обществе, происходят, то показатель распространенности, он является более устойчивым.
And if we see that a particular disease is more prevalent, then we focus our efforts on that. But the fact that there's more prevalence doesn't necessarily mean that it's aggravating. It means that there's a certain concentration of people that have similar disorders. And sometimes it has to do with testing. The fact that you are providing more visibility gives you more prevalence. And of course, latest technology has been very, very helpful here. So let's just look at the statistics, 2016, 2019. This is for Russia. Just to give you a glimpse of the trends. This is what's been happening here. These are mental disorders all across Russia, across the board, okay? And this is number of patients, of course, with psychological disorders. And the total number of people has been around 4 million people, generally, by and large. We see a very slight reduction of the total number of headcounts. But when it comes to heavy disorders, such as psychotic, manic, psychotic, schizophrenia, etc., you see that's about a quarter. And of that, about less than 500,000 that are people that are schizophrenic. And maybe about 50% in total overall occurrence, in total overall prevalence, are the so-called non-psychotic or like a borderline disorders, as we call it. And these are mild symptoms, these are mild light effects that are not necessarily related to, taking pills and things like that. So you can actually stay at home and you can get treatment on a basis through pills and not necessarily being taken care in a hospital. So you can also see that the non-psychotic component is actually more, about 70% on a total basis. Now, and by the way, if you look at the past 20 years, this is for 2 decades. This is 100,000 people. So from the year 2000 all the way to 2019, you see that this is a distribution here. All neurological diseases versus non-psychotic versus psychotic and mental dementia. So you see these bars, and I see close to 2008 it was going up, up, up. Then you see a very, very slight reduction, very gradual reduction. Then a bit of an elevation close to 2013. But other than that, by and large, you don't see any sharp spikes here. So more or less it's quite level. So it's been quite steady here. And this trend is quite benign, generally speaking. So, and like I said, about 50% would be so with the so-called borderline cases, and some of the primary mental disease. And this a lot has to do with all the turbulence that's been happening in Russia since the 90s. You see the elevations, sharp spikes, of course, 2004. Clearly, the banking crisis. Then, of course, we see a reduction, then a slight bump in 2008. And then you see, again, going up a little bit. This is a primary cases. Not surprisingly, of course, a lot of that has to do with the social tension and all the struggles that are people going through. So, I mean, there's a strong correlation here. And for us as clinical researchers, of course, By and large, as far as primary dementia, you see by and large the trend is quite casey, of course, and as far as psychotics and mental dementia is flat. So, and this gives us patterns. You can actually rank order all parts of Russia according to cases. So, and you see different colors here because we are studying it all across Russia, 40 different areas of Russia. So these big maps, heat maps, that tell us what's really happening. So I'm not saying this is cast in stone. No, of course not. But this is a good indication of what's really happening to people that live in these parts of Russia. So, such as when it's too elevated, such as the Republic of Bashkortostan or the Nenetsk, which is the far extreme north, or the Perm region. So you see that it's quite a spread, and this is what we see in primary and secondary cases for 2019. You see very low levels in the south, right? Northwest, also very low. It's not because the overall situation is better. I guess it has to do with also testing and narcology related. Of course, you also see the spread here. This is mostly alcohol and other psychoactive drugs. By the way, very similar in terms of oral cases and primary cases as well. This is narcology related to drugs and substances of abuse. Now, I have to mention one thing. In terms of identification and testing. A lot of that has to do with technology, of course. The question is, do you have the right technology? Do you have the right tests? So we compared the northwest part and the North Caucasus, different parts of Russia, the north versus the south, and you see a level of technology. So, of course, in the northwest, they have 4.5 times better technology compared to the south, because the south is usually southern republics. They've always been notoriously known for poor technology. So you can definitely tell that the ability to test and therefore identify these cases is directly linked with the availability of tools. Now, let's look at the global situation. Okay, this is a share of population with mental health and substance use disorder. Okay, so different methodology has been used. Of course, there's no one single methodology, and there are very, very few research that can give you sort of apples to apples a situation, but there have been multiple attempts like that. So on this slide, you can see that the darker the color, of course, the more pronounced it is. So I can say Russia is somewhere in the middle. So we can almost, like I said, Russia is more of a favorable jurisdiction here compared to the United States or Australia or some European countries. Now, this is a share of population with mental health and substance use disorder. And here you see the trend from 1990 to 2017. And this is over a span of 30 years. And a lot of people say that lately it's been all about psychotic disorders and things like that the mental health has been worse and worse. But it's not true. It's not true. It's actually been quite flat. It's quite flat. And at the same time, the WHO, that this is 17 different countries, so it gives you 12-month basis. In April 2009, you see quite a big distribution from the United States to Nigeria. Okay, there's what we'll call mental health differences, and of course, the United States, number one, running it with big lead, and Nigeria is the last. Well, there's nothing to get disordered about, I guess, in Nigeria. So, anyways, similar. This is still WHO. This is from the United States to Nigeria. It's the same slide, but in numbers. Number of cases, of course, heavy cases versus light cases, and the number of psychiatrists, by the way. And despite the fact that some of these disorders are like psychotic, mental dementia, and things like that, I mean, they're actually quite low percentages. So the bulk of these disorders I will call light cases or borderline cases, such as the person walking down the street, you wouldn't even know it. Okay, and this is brand new. This is from the European part of WHO. Again, this is a spread. You see the colors. The darker the color, the less. and the lighter the color, the more. Okay, so Russia, again, a favorable jurisdiction in this regard.
В последние годы уделяется
Oh,
проблеме
by the way, quite lately, it's been a lot of studies of depression, anxiety. As you know, a lot of people, they say, are depressed. All sorts of psychosomatic disorders related to anxiety, depression, things like that. So this is the DALY index. The United States is number one. Then comes European Union, then Southeast Asia, then South Pacific, the southern part of it, then the Middle East, and then Africa. And this has to do with loss of life or loss of longevity related to, so it used to be less than 20%, but now it's quite elevated. Also, according to WHO 2005, the share of neurological disease, about 20%, 28% of the total index. That's a depression, they say depression or unipolar depression is actually ahead of cardiovascular disorders and other types of disorders in terms of its contribution to the index. So it's a massive, massive problem. So 25%, that's what they say in terms of the frequency of depression. So it's a very widespread, and it's widespread across different demographics. There's been so many different studies from young to old here in Russia and abroad. They say that the women are twice as high actually susceptible to depression compared to men. You see, 2025 versus 7 to 12%. Interestingly enough. Yeah, so there's a general trend to people getting younger or want to live forever, trying to improve their lifestyle, and the more they try to do it, the more depressive they get. So and a lot of that is chronic. Over 60% cases of depression are chronic, reoccurring, and also a high level of correlation to other types of diseases, neurologic and other non-neurologic phobias, etc. And a lot of suicides, 15% more suicides caused by depression. And it's actually, the suicides actually is a more prevalent disease than cardiovascular. Actually, more people die from suicide than from cardiovascular disease, which is interesting, never been done before. Also, by the way, something that took place in St. Petersburg. This is a Healthy City Initiative. So St. Petersburg joined the WHO Healthy City Initiative. Interestingly enough, so there've been so different programs, and they did this massive study, and well, we were part of it, and so, like I said, we faced some difficulties. It has been a very wide-ranging study. So from global, social to humanitarian, but by and large, you see that the overall situation is getting aggravated because there's so many different turbulences in human life. So naturally, people get more depressed, they become less sure, and they want to live better, they want to have certainty in their life. But it's a big problem. It's such a multifaceted area. There's so much in between the lines, on the cusps between different sciences. It's a very difficult thing to unravel. So we don't have any coordination project office, you can call, that would bring together multidisciplinary professionals to develop a particular program to eliminate it. It's almost impossible. So all we can do is highlight it and show what's going on. But of course, mental health is systemic. It's ultimately to glue the whole society together, and it's something that will be the key study for different types of sciences. And we need, of course, to bring together different professionals. These are social professionals, IT professionals, data scientists, etc. So the whole point is to create a favorable living environment to preserve mental health of our society. And that's what it's all about, keeping our people healthy. So, and multiple factors have been identified that primarily affect the situation and Clearly, of course, social factors are among the most prevalent. Well, simply, it's just a lifestyle. The lifestyle, what you see and what you face on a daily basis. Here's only some of them, such as low social status, work stress, poor work-life balance, anxiety, depression, hostility, and things like that.
Очень интересных наших исследований, они показали тесную взаимосвязь.
And our study shows a very strong correlation between these neurological disorders and cardiovascular disorders. There's a very strong correlation between anxiety and cardiovascular stress and disorders. Unfortunately, there's a very direct link between that. So it's what leading, by the way. So a lot of the cardiovascular diseases are caused by neurological diseases and poor mental health, unfortunately. So we have we have tried to develop at least several big programs to combat it. So several platforms, the three of them, such as the healthy population and people in the risk group, the most vulnerable populations. These are mostly targeting different healthcare professionals coming together, also mental literacy, things like that. So the different programs, some target the society, some target healthcare professionals, and the long-term goal of this program, of course, is to make sure that we can combat all the negative trends and improve overall level of availability of mental treatment and generally improve the quality of mental health care. Unfortunately, COVID-19 is definitely not helping here, and a lot of that, of course, puts this on hold. You see there's a very sharp spike in psychological and mental deviations, up to 42.5%. Just a couple of words about the pandemic. Again, this is the challenge of our time. And every time you look at SARS, you look at any other epidemic, there's always a strong correlation because people are uncertain and it's always spiking every single time. And COVID is not an exception. Has been unprecedented. So when people are so stressed, have to sit at home, they're isolated, they lose social connection. And the fact that you really don't know what to expect, that the government comes up with different information all the time, and you have to wear masks and all that. So it causes massive stress. And not everyone can take it. People get, rolled over. And this, of course, is a huge factor for this kind of spike. There's been multiple studies, short-term and relatively long-term. So we have enough statistics because it's been running for months. More or less, you can see what's been happening here. You can see correlation, of course. People are stressed, and for sure, some of them turn to drugs, to alcohol, to other substances of abuse. Of course, we need to come together. We need to combat this because this is long-term damage to the mental health of society. So, by the way, we had our own study. These are the scientists, so we published it later this spring. We also did social demographic studies. So about 2,000 people participated, so average age from 31 plus minus 12. And men versus women, you see 84% were women, 16% were men. So, and mostly women, of course, participated. Women that have, in 50% of all cases, some somatic deviation, about 30% of all cases, some affective psychology-related disease. You can also see, of course, we try to balance this respondents by age, right, and marital status, but by and large, the overall level of stress is elevated, and no wonder, because women are more susceptible to this kind of stress than men. And these are mostly people that mostly have some sort of affective memory-related disorders. Also, young people, unemployed, single, unmarried, without higher education, and women. So women are more susceptible to this stuff. And the overall the by and large, the overall majority had, of course, coeluting factors. So it's not like only one thing. They had several elements going at the same time. And mostly anxiety and disorder, of course, such as lack of drugs, availability and the risk of isolation, lack of job, and things like that. Mostly, of course, about the uncertainty of this life. And Dmitry already mentioned the impact of social isolation on mental health, the fact that we are hardwired to be social creatures, and our results actually mimic it. So you see Moscow, St. Petersburg, etc. You see how many cases we have and the level of diseases per 100,000 people. So there's a direct correlation between people sitting at home and being isolated to being anxiety prone and overall level of stress. So overall, like I said, each and every single time we have some sort of an epidemic, like in case of SARS, for instance, there's always spiking. So pandemic and psychic health are always related, mostly causing depression, anxiety, because people are unsure what to do. And I might say that, so of course, I mean, we still haven't yet received the full impact of COVID-19, but for sure, it's a new thing and in many ways an unprecedented way, but certain things are universal and the effect will be, of course, significant. And like I said, we shouldn't just think about direct help to society in terms of money, but also in terms of their mental health. We need to support people, help them survive, help them maintain their mental health in this very, very unfavorable environment. And this particularly goes to physicians and people related to healthcare that are contacting these people in the first place. And there has to be a multidisciplinary study because COVID-19 has touched so many lives in so many different sectors. So we're not just looking at cognitive health, right? But we're also looking at holistically the whole body. So there's been works and studies that the coronavirus also impacts the actual brain function, direct brain function. Somehow they link coronavirus to brain function, brain malfunction. So pretty much across the globe, you see that the overall number of cases is spiking. The mental health is deteriorating across the globe. A lot of that has to do with depression and anxiety. And as a result of that, the impact is economic and social primarily. So the fact that we all live in a stressed environment, that is not a good environment, of course, to stabilize mental health for sure. And of course, there's a direct correlation between level of income to level of mental health. So the lower the income, the lower the mental health. So, and that means that fighting poverty and the overall welfare is a major factor in maintaining overall mental health of people around the world. So that's all for me. Thank you very much. Thank you, Natalia. Indeed, yet another case and another example, a great example of what's really happening in the world at the moment and just how bad the situation is around the world. And the COVID-19 is only aggravating the situation, unfortunately. The fact that life is becoming more aggressive. The lifestyle is getting more aggressive. So, despite all the discoveries, despite all the technology, we see that maybe the quality of life going up, but at the same time, the quality of your well-being goes down. So, by the way, people post questions, use our chat, use our Q&A room. And by the way, we're supposed to have a plenary session. It's a panel discussion. So all the speakers that we had today, so some will be joining us at 12. So without further ado, let's start a panel discussion. So 2 more people are going to join us. Okay, we try to take several questions to try to discuss it before 12, because both Natalia and Dmitry will have to then, they have a different event, a different session. So joining us today is Philippe Philip Haitovich, so our colleague from Moscow Tech, he's a neurobiologist
Изучает
and
мозг на молекулярном и клеточном
prominent
уровне.
scientist studying mostly pathologies and molecular level
Методов
component of the brain. So Vasily Hai
прикладном
and Philip also Hai.
методов
Again, purely applied areas, so diagnostics and studies of molecular, so the brain evolution,
на
and
стыке
so
нескольких
again on the cusps of several studies, there's biology, genetics, and things like that.
для того,
So
чтобы
super
обрабатывать
important, okay?
предиктивные модели. И к нам присоединится Василий Андреевич Ключерев, еще один
And Vasily Kucherev also joining us,
биолог и большой
another prominent Russian neurobiologist, the specialist in neuroeconomics.
наук Высшей школы
So
экономики.
he comes from the High School of Economics and the head of Cognitive Neuroscience Institute.
Высшей школы экономики научные сотрудники занимаются изучением восприятия, коммуникации, внимания, когнитивного контроля, памяти.
They mostly study cognitive control, memory processes, behavioral genetics, cognitive processes, and things like that. A lot of that has to do with the computational elements, including So anyways, so we're also expecting Marat. Of course, he's deputy head of first psychiatrical hospital, yes, and the memory hospital. The memory hospital is a new project that he's in charge of. He's basically is a network of clinics that study mostly mental health and especially memory, especially for senior citizens. So, and these are the questions. So the questions, so many of these questions have been highlighted already, but maybe you'll be excited to learn from other speakers. So why not? Okay, I hope you can see the questions here. So originally we were supposed to actually speak about cognitively healthy person. What is cognitive health? How can you define cognitive health? A person that is cognitively healthy. Just let me paraphrase. How can you diagnose? How do you understand it? I mean, of course, this psychiatry has been doing this for years, but what other ways? And is it all based on proof, or is it based on something else? So can you indeed diagnose somebody, and especially on a preemptive, on proactive basis, because you don't want to say that, oh, you're crazy. Ideally, you want to do it beforehand. So it's much more difficult to treat it once it happened. Ideally, you should treat it before it happened. So let's talk about it. So what are the issues here? So and what are we good at? What are we not good at in terms of proactive diagnosis? And how can we know beforehand that somebody's approaching this red zone, so to say? And what kind of recommendations can you provide? And can you what can be done with regards to such person?
Факторы, которые влияют на когнитивное здоровье, и наша городская среда, особенно это ярко проявилось сейчас действительно на фоне пандемии.
And particularly about the pandemic, of course, I would like to talk about the pandemic as well, and how that affected people living in the cities. And probably the most important element that I would like to talk about is, look, of course, we can look back at the track record of 10 to 15 years ago. But what about the changes? What's happening in the future? What's going to happen in the next 10 to 15 years? What kind of breakthroughs should we expect? So what should we expect? What are the expectations? And based on the science, the state of science today, so what kind of breakthrough should we expect? Okay, so without further ado, I would like to probably start with Konstantin Anokhin, right? And also to Natalia as well. Yeah, let's start with Natalia because she has to run. So I guess the first thing that you mentioned, for sure, that's just her core competence, and that will then join in, okay? Natalia, if you're here, if you're with us, I hope you're with us. So I think she has left the building. So I don't think she's with us anymore. Maybe she's left, or maybe she'll come back. I actually see her now. Yes, but yes, Natalia, if you're here, your mic is muted. Some say that she's left. Okay, anyways, let's continue. Maybe she'll rejoin us later. Okay, in that case, let me start and let me start with the first question that I mostly specialize in. Okay, so here's the point. So your question specifically was, especially in the emails before the conference. So your question was, what kind of discoveries, like the latest discoveries that so enable us to sort of in a dramatically new way to look at the brain and the cognitive health. So, and then you went with yet another question. So what should happen in the future, right? So I can, of course, give you my viewpoint on what's happening in the world, and what can be done. So I believe that in the past maybe 10 years or so nothing has happened. Nothing in the past 10 years, nothing has happened that could help us to look at the brain in a tremendously different way. So, I mean, we still look at the brain the same. We see 200 years ago, 100 years ago, 50 years ago, nothing has happened. No breakthroughs whatsoever. So, we has not yet scratched the surface. So, and that means that in terms of scientific revolution, there's no scientific revolution in terms of what happened to the brain. Yes, we've been trying to scratch the surface here and there, but by and large, nothing. So it's still a mystery. We have not yet approached it. Yes, we've advanced in terms of technologies, in terms of we've developed, of course, visualization, so we can, slice the brain and visualize it. We can. So if you look at the past 10 to 15 years, we do some of the octogenetics, the causal effect. So you can stimulate different brain areas, different ensembles, different groups of cells inside the living brain. That we have learned to do. But it's not a scientific revolution, so nothing dramatically has changed compared to 200 or 400 years ago. We still see it as a piece of meat, and we don't really know how the hell it's doing all that. It's like whether it's now versus 19th, 18th century, whatever. It's just a big neural network that has something tremendous happening inside. And Nchhl, by the way, was talking about the exact same thing. So, and he used to live in the 19th century. So, nothing. So, what can we do? How can we improve the situation in a dramatic way? So, I think that. So the big next step that could lead to this revolution could be technologies that done by Elon Musk. So not him alone, but Elon Musk has this tremendous, because he's a great practitioner, he's a businessman, he tapped into this thing in the right time, in the right place. His timing is just absolutely incredible. So, and he has this gut feeling. So he came up with the right technology. It's like, the big stone that you need to, that a little bit of leverage. So he decided to use the leverage to create an avalanche. And because everything that we've done, the nanotechnologies, the electrodes, etc., so he brought together all these things to enable the breakthrough. So I believe that Neuralink is the number one area. So this is how we can indeed approach the situation, whether you're alive or in coma, whether you're during the day or when sleeping, etc. So this is the best way. So, and now that you can actually do invasive treatment and you can insert this this chip and you can study the brain from inside out. And the fact that there's so much materially available to us, it's incredible. And the very, very few, like I said, laboratories, neurological laboratories that are capable of doing that. Other than that, again, we're talking about the direct Neuralink interface. I mean, it's unprecedented. It's unprecedented. And Neuralink and other technologies that will follow up in the same pattern can cause a tremendous revolution in our perception of what the human brain is actually made of and how it functions. Well, great. So anybody else? So yeah, maybe I can speak on the same front here. So because that's what I do, I mostly do cognitive studies, and maybe I can share an idea or two. And I'm a neurobiologist by background, and I agree with Konstantin here, but at the same time I disagree. I think that a cognitive dissonance and the cognitive health actually has layers to it. So what Konstantin and Philippe are doing, I think it's a dramatic, very dramatic area. The genetics, the biochemistry, the cellular processes, such a lot of revolutionary things are happening out there. But at the same time, I have to agree with Konstantin with the fact that the cognitive function is not about cellular, right? You can see the brain, you can dissect it, you can look at the cells, but how does the cognition happening? Yes, the neurobiology, and there's the cognition, which is the higher function of the brain, and that's the strength and the weakness. And that's what Konstantin is talking about, the fact that we've done so much in the past. That's our weakness. We don't really have no clue how the cognition works. And I don't know what cognitive means. And I'm a professional, so we're trying to just combine this jigsaw puzzle using linguistics, mathematics, biology, psychology, and lots of other areas. I mean, biology has been around. Like that's why all these jokes about the genetics, they don't really know how this works. So we study bits and pieces. We're trying to, as through the keyhole, look into this dark room. And like, it's been happening for dozens and dozens and dozens, despite the fact that we've been messing with the brain for dozens of years. So if you go back to some of the medical treatment, sure, we have drugs that help, but how do they help? What exactly are we treating? We don't really know what we treat. So yes, you can use antidepressants. You can, help one part of the brain, but damage the other part of the brain. It's just how effective and efficient. So we need a holistic study because a lot of these drugs, yes, I mean like the Alzheimer's disease, yes, they boost, they crank up like a certain part, but it's so minuscule. Just how efficient are we? Are we even there? Are we even going in the right direction? And are these Alzheimer drugs actually helping? We know that the effects are so temporary and they vary. And the same drug can cause a good effect or bad effect. And different drugs can be synergistics or anti-synergistics. So, and again, this is another big area. So we understand that we're sort of hitting the brick wall. So, and again, this brick wall called cognition. How does it work? We don't understand how cognition works. And I do believe that there will be breakthroughs. So how the neural network then builds into cognition. So, and I really enjoyed some of the quotes from Konstantin. Maybe there will be this revolutionary idea that will indeed highlight this dark room called cognition. But the big advantage of the past years is understanding just how complex this is. Now we fully grasp how deep the rabbit hole is, just how complete, just how immensely complex this area is. Much more complex than we ever thought. And we haven't yet scratched the surface seriously when it comes to cognition. So every single day we understand that it has to be cross-functional. And actually, I was hugely impressed where people actually discuss what we eat, so how we act in life, what do we do on a regular basis, because the brain is everywhere. It touches all areas of life. So cognitive health is everything that you do in life. So the revolution of the past years comes from understanding the complexity of the task at hand.
Да, давайте, конечно.
So I would like to continue just a little bit. Yeah, sure. And also touch upon this one more area. So we had this question from the audience. And about the young scientists. Tell us about the young scientists. How many young scientists come to you to study? Just how popular this area is? How do you engage young scientists? How do you actually, because you said that we have a huge lack of people in this area in Russia. Yes, I will do that for sure. I will do that.
Очень важно, что сказал Василий. Первое, я целиком согласен с ним. Я думаю, что фокус должен быть на понимании когнитивного. Хочу обратить внимание, что если мы не перейдем на принципиальный уровень, слово «когнитивное» является
So the word cognitive, by the way, this can be yet another sticker. It's the same bottle, different sticker. We used to have like mental health, cognitive health, spiritual health. So it's just you're just juggling the balls, and it's going to be another fad, and in 10 years we're going to come up with something else, but it's the exact same thing. The same lady in a different dress. That's not what it's about. The point is that it's a very, very complex system, and whatever you want to call it, it's not just biological. It's not just biology. So as long as you stick to just biology, so you're never going to advance 1 inch. So cognition is the holy grail, and that's what we need to analyze. Now, of course, there are higher levels and lower levels, and certain levels that we can tap into, but certain things like the cellular, biochemistry level, the molecular level, that we can study, but it's irrelevant. It has nothing to do with what we're trying to tap into. So understanding cognition is not an add-on to cellular. That's the thing, that it's a transformation of the network capacity, so that it's like almost like liquid turning into gas. It's that kind of quantum leap. It's just completely different. So, for instance, so we didn't just study molecules when we studied genomes, but the molecules that actually coding certain properties. So, and there's a lot of parallels between the studies of genome and the brain. So it's like DNA, 20th century, brain, the 21st century. I see a lot of parallels. And the point is that we need to reconstruct and, well, how do you say it? So when it comes to molecular biology, we're dealing with chemistry, but this chemistry is a precursor. So, and because we understand that it's a precursor, that's how we transition from genetics and yada, yada, yada. We moved into just understanding how the genome works, and that produced the revolution. So, and the exact same thing has to happen with the cognition. So we need to go all the way down to neural level, but at the same time, always keep focus on cognition. The same token here, so the neurons are coding cognitive information the exact same way DNA cells, pre-program the functions of the genome. So I see the very strong parallel here. So I had several questions about the treatment here, by the way, and different people come to me about the questions of how to treat youngsters, and the only hope today is the young generation. I see no other ways as to how to make this quantum leap, how to treat young population, but it's very, very difficult to do because we're creating a judge. It's a high toll. It's a big thing to ask for from young scientists. So what are the options available to them? I'm talking about my team, my students. So what are the options? What are we offering? So you can, of course, be a master of the global literature, Western literature. You can even study abroad. You can become. So it's not going to give you any good. Yes, you got to be catching up, but the West is always going to be ahead because they have so much more investments, so many more people doing this. So catching up, it's impossible. Chinese have tried to catch up, but they failed. I saw these amazing Chinese science and students. They come back from the United States and they build laboratories in China. They try to do the exact same thing, but they have a 5-year lag. And we're actually far, far, far more behind. We don't have the power of China. So the only chance we have is to leap forward. And that means a strong and independent mind. Not following and not copy-pasting the West and China, but actually going a different way and leaping forward. That's the only chance we have, to jump like several steps ahead. Okay? So forget about the Soviet legacy. It's a bad idea. The fact that we had so much legacy, etc. But that's not what it's all about. So the brain is so much more deep. than what we've been doing in the Soviet legacy. And for instance, the role of Mikhail Livanov. When it comes to brain studies, and so it happens in life that people that understand how the brain works, they were mavericks and they were ahead of times, like 10, 20 years. Some of these geniuses from the Soviet Union, the brain surgeons, they were 10, 20 years ahead of their time. And this one is being lost. We are rediscovering the wheel. Yes, we're now using the technology, etc. We're basically coming back to square one, but the certain things are still there. So the brain is so deep, it's such a such an advanced neural hyper network. And to dive into it, and sorry for repeating myself, but I'll come back to what Vasily was talking about. We need to, first of all, elevate us. The depth is in the higher levels. So by diving deep, we need to rise high above. Okay, so you shouldn't just capture the low-hanging fruit. You need to climb all the way up to the highest branch, and it only can be done by the young people, the young scientists. As the Nobel Prize winner said that, look, when you're young, you have fresh blood, you're not yet accomplished, and you have the freedom of mind that a Nobel Prize winner doesn't have. So that's why my only hope is the young scientists. And just a couple of words about the young scientists. The whole purpose when I came to Russia was about training the young scientists. I mean, not doing a very good job at this, but when I came in 2013, I remember this girl said, look, you're from Switzerland, right? I said, yes, I'm from Switzerland. Why the hell are you here? Why did you stay in Switzerland? I said, look, because I want to help Russia. I want young scientists from Russia to excel and to be great here, because it's all brain drain. People all fleeing from Russia, go to the United States, Switzerland, etc. So my whole point of coming to Russia is to do something about it. Now, how to make it more attractive? There are different ways about it. Like, for instance, Konstantin is more of an academic view. My view is more of a practical. It's such a cool area. For people are so excited about it. We had this girl, and she came from the High School of Economics. And she was jointly with London School of Economics. She is like a brilliant student and spent so much time on getting double diplomas from the London School of Economics and the High School of Economics in Russia. So she comes to me and says, look, what are you doing? Like, we have this student that graduated from the High School of Economics, and now she wants to be a brain neural interface scientist. We were planning to make her the CEO of a company, and you're basically taking our students. What the hell are you doing? And she's currently in Chicago, by the way. She's one of the best scientists in neural brain studies. So, see, if you're doing something cool, something exciting, something with a challenge, so this will inevitably attract the best people. So it's a big problem. A lot of that is PR, branding, identity, things like that. So you need to make it public. You need to make it available to the young scientists, to the young generation. That's the only way.
Я хочу, чтобы к нам еще подключились Дмитрий и Филипп. Филипп, у Филиппа работает очень многонациональные команды, и, возможно, он сейчас добавит, раз уж мы обсуждаем молодежь, а потом я задам вопрос Дмитрию.
Ну, во-первых, я хочу абсолютно согласиться с тем, что говорил Константин и Василий. Нужно создавать.
So I agree, by the way, with Konstantin and Vasily. So we indeed need to have a center of excellence, but instead of catching up, we need to make sure that it's all based on the brain perception, but in a totally different way. But here's the point. As a molecular biologist, looking at the brain, there's so many things that are unknown about the brain. But the problem that we have is that, look, well, I'm not saying it's excessive, but unfortunately, the high levels of brain function, such as cognition, are just unfortunately out of reach. So you can't, that's why the Neuralink is so popular, is that we need a different approach. You can't apply the exact same approach that you use to study other parts of the human body. So the brain is something special. And using state-of-the-art technology. What is Neuralink? What exactly is Neuralink? It's the available technology. Yes, it's a cool technology, but it's technology that is already available today. That's what they've done, essentially. So, yes, it needs to be applied, sure. And even if it's monkey, but the monkey cannot tell you, right? It's a monkey. Monkeys don't speak, right? So you can torture monkey all you want, but it's not going to speak. So you need a radical change. So we need to work with the human brain, not the monkey brain. So, and maybe post-mortem, right? But unfortunately, a dead body cannot speak. So we need a live human on the one hand. On the other hand, let's not forget that a lot of the things in biology, I mean, remember the microscope. The microscope was such a tremendous invention. It allows us to see this invisible world. Maybe Neuralink will be like a microscope for the brain. And maybe because of the Neuralink of Elon Musk, we can actually look now with a higher resolution into the actual brain and how it works. So I put a lot of hopes in that. And if it's going to happen, great. And this is such a cool idea. And young people will be naturally attracted to it because it's such a tremendous challenge and love challenge. So great ideas inevitably attract smartest people. It just happens naturally.
Дмитрий, у меня к вам вопрос, поскольку вот последнее выступление Натальи Владимировны и ваше вступительное, они в значительной степени пересекаются, но в то же время мы видим, я бы сказала, немножко разный даже, не немножко, но по моим оценкам, вот прям разный взгляд на современное состояние.
I agree with many things that you just said. But when it comes to the psychic health, the cognitive health, the mental health, I see a bit of a controversy. So Natalia said that cognitive is only part of the mental, that mental health is bigger than cognitive, and all other speakers are saying that cognitive is actually more complex. We don't really know what cognition is. So I see that there's a bit of a contradiction. So, and I know that you started several, at least, the open dialogue school, a lot of awareness things. So what about your view of cognition and your approach to it?
Кажется, что медики склонны очень медикализировать вообще все, что им под руку попадается. То есть они хватают.
Healthcare professionals, they jump on any bandwagon and they love structures and they love studies. So we should be. I mean, the scientists, they're notoriously known for their reductionist approach. So that's why there's so many citations, so many works. They're all trying to expand. There's psychiatry. They try to medicalize all these studies. So, and that's why I mostly, of course, agree with the panelists here. So we need a different and a lot of terminology, a lot of playing with words. But as Konstantin said, that look, okay, so whatever you want to call it, right? You don't like a cognitive, okay, you forget about the word cognitive, okay, choose something else. But whatever you're going to choose, it's just, yes, we call it cognitive health, but then in 10 years, it's just playing with words. It's not going to give us any, I don't really like it. Because instead of focusing on the impact, we're focusing on fads, on cool words, on great terminology that sounds great. So this kind of it should be avoided. This thing should be avoided. And by the way, everything that you've been talking about, I absolutely share the same viewpoint. So we are currently focusing on what's in between, on the cusp. There's the hard and the software, right? There's the hardware and the software. So we are basically, ideally would like to understand the software, but what's happening in the interface, like the language, right, between the hardware and the software. That's like the emotional. What is emotional intelligence actually? How do you even approach emotional intelligence? How is it related to health? How does it impact health? So, of course, we have this collective intelligence and we have this collective emotional intelligence. So it's a tremendously exciting study. And honestly, I have the sense that by studying the collective, you can actually, from collective, go into a personal level. I think that it's a better idea to actually study the collective rather than studying the molecular levels. So, and that's my idea, that we need to study that.
Константина, да, о том, что вот это движение вглубь, оно же движение получается в высоту, и поэтому здесь вот хочется обнаружить связь между социальными и гуманитарными явлениями, как в том числе презентация говорилась, и тем, что происходит, допустим, и на уровне физического здоровья, и безусловно молекулярно-биологических процессов, и генетических, в том числе, каких-то аспектов этого всего. Вот. Поэтому, ну вот, то есть, условно говоря, параллель между сетями, которые есть в человеческом...
So, anyways, like I said, and you think when you draw parallels between this, because you can see the society as a brain. In a sense, I say that human relationship, the society relationships and the group relationships, you can almost see it as a manifestation of external manifestation of the brain. So, and that's why I'm so excited about studying the collective. There's so many like native language. There's great artificial intelligence that can actually analyze a patient's speech. And there's a tremendous study in the Nature magazine. It's tremendous algorithms that by tapping into speech can actually infer the deeper levels. So I would actually reverse it 180 degrees and would instead look at society and collective studies of intelligence, and from that in theory into the deeper level.
Такую мысль, что действительно медицина, она как бы консервативно должна действовать в определенных устоявшихся там рамках и так далее, а мы, посмотрев на эту проблематику и с точки зрения науки, понимая, что она гораздо шире, вот изучение этих разных аспектов может быть...
So speaking about those different aspects, we do realize that by deepening our research, we can achieve additional flexibility. I'd like to throw a few words about the young scientist. You know, I think of myself as of a young scientist, even though that I spent quite a long time in Asia. Well, I have to say that science does not have any geographic bias. When you try to localize scientific research, there must be a very strong motivation for the scientist to go there. So with you can't solve the problem with sporadic interventions. Many of my students stay in Russia because they are integrated into this whole fabric of relations. If you know the language, you can travel, you can communicate with other people, and I don't feel any disconnection from the world, even though that I'm located far away in the Russian mountains now, in the Altai region, and I can strongly relate to the words of Nchhl, who says that, well, some of his students are located now in Chicago, and with this whole international exchange, the students and scientists, young researchers can really move between the regions, between the countries. So this is all I wanted to say about the localization of science. But, you know, besides the geographic location, there's also a very strong connection to your school. Do you think that such a concept exists in the Russian science? Are there any schools of this kind in Russia? Well, I could continue on that, but I would have to say goodbye because I have to put a hard stop on my part in this panel. Thank you. Good luck. Vasily, what do you think? Well, I'd invite Philip to comment on that because I know that Caltech is now building a strong school. Well, you know, I'm very optimistic about that. Because what we see now in the global science development, and I have spent 20 years abroad myself, this is a trend towards very narrow specialization in research, in brain research as well. And you know, when it comes to brain, you can't really understand how it works by being just a narrow specialist, by analyzing only the molecular part of that. Some people are involved in molecular research, some people are involved in the DNA research, but you know, this is far too narrow. So if there are any young scientists listening to us now, I would like to tell you that, you know, there is a myth that science knows everything about the brain. Absolutely not. Even the concept of neural networks influencing the conscience, well, it's not absolutely right. There is a certain foundation, but you need to put the modern knowledge and latest research on top of that foundation, and this can only be done by young researchers, but they do need to have a very strong background and knowledge. You need to be very well prepared for that. That's what I think about this thing. I want to second what Philip has said, and Philip is absolutely right. You know, narrow focus is a dominating trend among researchers, but however, there are new schools emerging all over the place. And I think that this is one of the most interesting trends that we observe now. Perhaps visiting other galaxies would be something which is more interesting than that. My question is about this year, about this coronavirus and pandemic situation. Has it affected you a lot? Well, the first conclusion is very obvious that the new technologies are now being implemented across all the fields. Do you think it will give another boost to science development? Do you have any observations from what you see in the latest research? Any other trends that you could highlight? Well, you know, as many areas in neurobiology, as many views. You know, we were studying people, humans, and once the labs are closed, well, we found ourselves in a very difficult situation. We tried to move our research and collaboration online, but it was very difficult. It was a huge challenge for us. And you know, now today it's easier to collaborate on research with the UK researchers rather than Russian, and we know that it's much easier to join the brain research being done in the Great Britain than in Russia, because there are lots of administrative barriers to that in Russia. But this is a very interesting time because, you know, there's a lot of attention being paid to cognitive researchers. And a company recently invited me to a dinner in a very expensive restaurant, and that company is involved in luxury goods. And they were interested in learning how does the stress work in this whole situation of pandemic. And well, I had to do my homework for that conversation because indeed a lot of it is related to anxiety, but you know, there's also the biological response, which Philip is now studying. And the natural response is to get isolated, to become xenophobic for the society, to push out the aliens. And you know, the Great Plague ended up with termination, with the mass murder of all the Romas in Europe. And you know, it's a very interesting topic for cognitive scientists. But in cognitive research, the publication cycle is about 1 year. I'm not sure about what Philip has to deal with, but in our case, it's 1 year. So all the latest research is about to be published, well, in the nearest few months. So if any research was done in March, then we will be able to see some verified data and learnings only in March next year. But I'm really looking forward to that. It would be very interesting to hear how has the pandemic affected us. Well, the only thing I can add is that, well, evolution shows that the brain is very good in adapting to routine, to some stable conditions. Well, we had some sort of stagnation before that, and perhaps this pandemic is the shock that we had needed for such a long time. It will make us revisit our view of the world. And as you mentioned, there's a lot more attention being paid to brain research now. And, you know, if the brain is well adapted to what's going on, well, brain is a very conservative concept. It doesn't want to change because any change may be both positive, but it may as well be a negative thing. And if the external conditions are changing fast, then the brain is forced to adapt, and this is the reason for the growing interest to our research. Philip, you are still in my show. I just wanted to say a few words about the evolution, because we are in a very unique situation, because we have all those online collaboration tools. During the Great Plague, they didn't have any internet. And that was one of the worst things there. And now I just look around the people I see here in the mountains, and I see how fast their mentality has changed. So previously, people would see only the people who are physically surrounding them. Whereas now, you are exposed to the huge world. You see that you can sell from the Altai region to Moscow, whatever you are selling there. And people are more exposed, people are becoming more global. And I think that this will be reflected in the cognitive functions, and even in the metropolitan region, people are now more open, they are more connected. All those meetings, they are more optimal now, because you don't have to travel anywhere. You can just call the person on Zoom and there you are. So I think that this is a very interesting development, and it gives me a lot of inspiration about the future. Yes, indeed, it's a very interesting situation, because on the one hand, all the borders are locked, but on the other hand, we get more connected at a higher level, at the informational level. We are more connected now, even though that we can't travel between the countries. And, you know, it made us leap forward. And I do expect that it will influence certain attitudes in our brain. Maybe some processes will change. So my question is, how would you describe a person with strong cognitive health in a few years? Philip, Vasily, Dmitry. I'm not trying to make any global conclusions. It's very difficult for me to arrive to general conclusions, so I will be rather focused in my intervention. I don't have any expectations that we will see a human with a strong cognitive health anytime soon. Maybe we will become better in diagnosing the cognitive problems, but I don't expect either way. I don't expect the end of time to happen soon. You know, the historical dynamic always goes down, then it goes up, and so on. So I would call myself a realist. It could be that some more sophisticated markers will appear. and Philip is more advanced in researching that, maybe some changes will happen at the genetic, at the biochemical level. It may not mean that this person will have some cognitive disorders, but we will have a much better understanding of the mechanics. Today, we know that all the cognitive functions involve different relations between very complex systems in the brain. And our main focus is to use this understanding that we have already to arrive some reliable markers so that we could better diagnose and treat cognitive disorders. But it's difficult to predict when it will happen. But I am confident that our attitude to cognitive health will change. That's for sure. I was very much surprised with the growing interest to the topic of cognitive health that we see in the past 18 months, for example. When you read the research showing that your cognitive health is connected with the part of the city you live, and academic success of the students depends a lot on how many trees they see around them when they go to the university or school, and this was quite a surprising research. And I never expected that, and it shows that there are no simple solutions to the cognitive problems anymore. I have heard of very interesting research on how environment affects the psychological and cognitive health and the overall satisfaction and well-being of people. Yeah, that's an interesting topic. Philip, any breakthroughs in the biology that you expect soon? Well, okay, it all depends on what do you expect to get from that research. From the global perspective, all the research is following the economic development. How should we treat the disorder when there is one in the brain instead of preventing the disorder? How can we better manipulate the brain rather than optimizing the brain development in a way that protects it from external manipulation? When I say manipulation, I mean molecular and non-molecular ways of manipulating the brain. This is indeed a very important aspect of the state policy, of the national health policy. Because, well, you know, when it comes to treatment, there's lots of research available. And a lot of research is now being done by pharmaceutical companies, and if you find a methodology to completely prevent a depression disorder, well, the pharmaceutical companies will lose a huge market. So instead of studying the symptoms, we need to start focusing our research on all the functions of the brain, including the mechanisms behind brain development. Because, you know, when a person is born, the brain is not fully developed yet. The neural links, the neural connections, they are being developed in the first 10 to 15 years of a man's life. The mechanism behind that, well, that's a separate topic, because there's a lot of discussion of how brain influences the body development and how the body influences the brain development, and this is a very important factor. So you see, we have so many things on the table, and I think that it's very easy. It's very easy to achieve a meaningful breakthrough now. But the breakthrough is not there yet, just because little attention is given to it. Just imagine if they would spend comparable money on brain research as they're spending on the Alzheimer's disease, and maybe we would be able to prevent the Alzheimer's disease altogether, but no money is spent on that. I would like to add, I'd like to add that it's very interesting to see how all those areas are interconnecting. As Vasily said, well, I don't think that we will be able, that we will see any person with perfect cognitive health, but I would like to quote a very famous scholar who said that strong health is an optimum functioning condition in which you can function at an optimum level. So I think that we should drop this idea of expecting something perfect at all. And when you realize that the perfect state is not achievable, it changes your mindset and attitude to the context, to your relations with other people. And is the cognitive health is ever achievable as a concept at all? And I think that this is where our understanding of ourselves will grow, and this will be the key to cognitive health. The better we understand how complex, how contradictory we are, the faster we will find the key to this challenge. But we need to drop this idea of trying to achieve the perfect cognitive health altogether. Thank you. Well, I'd like to thank you all for participation. Now I would like to invite all our panelists to the speakers lounge to continue this discussion on the margins, because in some 20 plus minutes we will continue our sessions. Meanwhile, our moderators will have some interaction with the audience.
Но это в личное потом. Вот. Глин мне не хватило, например. Но неважно. Спасибо большое за очень интересные доклады. И они были очень разные, там, совершенно с разных плоскостей. Потом еще...
I want to thank all the speakers for their contributions, because this was a very interesting discussion. So, and now we would like to break until 1 p.m. Moscow time. So now we will just put the screensaver here. After that, after the break, we will have a short interview with Vasily Klucherev, and we would also like to visit PCI conference booth and to share some very interesting booths and rooms that the organizers of that conference have prepared. Stay tuned. We will give you more information later. Okay, this will happen during the break, and the formal plenary session will resume at 1 p.m. Thank you.
Дорогие друзья,
Сейчас мы вторую часть.
постепенно подключайтесь, и сейчас через 2 минуты начнется вторая часть нашего.
My dear friends, I see that you are now connecting. In a few minutes, we will resume the second part of our conference. We have several very interesting and very diverse presentations in store for you.
И практически врач в области когнитивного здоровья.
Еще мы хотели проанонсировать немножко завтрашний день, потому что это вот сегодня у нас идет конференция, посвященная когнитивному здоровью, но у нас идет нейронеделя до воскресенья, и завтра у нас последний, третий день конференции BCI, и мы бы рекомендовали обратить внимание на такую интересную вещь.
Just a short housekeeping announcement. Today is the last third day of the BCI conference, and tomorrow in Zoom, on YouTube, on Facebook, and all the platforms where we stream, we will have a panel discussion with a very funny name, Monsters Talking About Mosque. We have invited 3 scientists from the US who are going to share their feedback on Neuralink. I'm really looking forward to that discussion, and I would like to invite you all to participate there and ask your questions. And now let me pass the floor to Natalia. Natalia, are you with us? I'm here. Okay, the floor is yours.
Еще раз всем привет. Если кто-то к нам присоединился, мы продолжаем начатую утром дискуссию с разных сторон.
Let us continue the discussion that was started in the morning. Just to remind you that this discussion was focused on cognitive health and cognitive longevity, what has been done by the scientists and what will be done by researchers and scientists to ensure the longevity of our cognitive functions. We know that cognitive function is still a matter of numerous discussions and disputes among scientists. So we have 3 speakers who will talk now. First of all, Vasily Klucherov, who is involved in researching the cognitive scientists, Philip Haitovich, and we are also happy to welcome Mr. Marat Kurmashev, Deputy Director on Medicine at Alexeyevskaya Clinic, the memory clinic. This is the project which is supported by the Department of Healthcare in the office of the Moscow mayor, and they are now being involved in huge research on recovering the brain cognitive functions. This is a very important project for the Muscovites, and I do hope that the project will later reach out to other cities, because indeed, as we have already learned, the environment does define our cognitive state, our cognitive condition and cognitive health status. And now, let me invite Vasily Klucharev to be the first speaker.
Okay, thank you. So I'll be sharing my slides. I hope you can see them well. I have quite a provocative title for my presentation. I'm now opening my chat to also follow the questions that we are receiving. So, as I said, it's a little bit provocative. How to study cognitive disorders? Well, we'll probably mostly be talking about the way we are studying the cognitive disorders. And we'll be talking about new opportunities that have emerged recently in Russia. Maybe not everybody is aware of these new opportunities. If we talk about cognitive disorders, we can be quite different here. So Philip Haitovich will be talking about molecular and biochemical level, but I'll be talking about neuroimage. So this is the level at which we use different methods, fMRI and various ones, and it allows us to study different processes in our brain. Those are not invasive methods. So I'll be describing different approaches towards our cognitive health. I'll be explaining our logic, and I'll also be talking about what's new is there in the Russian Federation, and it will allow you maybe to use some new opportunities while studying cognitive functions and cognitive health. So, proceeding from our previous discussion, I have changed my presentation a little bit. The cognitive level, as has already been said, is quite a mysterious one. We do not know exactly what is a cognitive, how actually the brain activities are translated into cognitive processes. We are not fully aware of these biochemical processes and how they're transferred into decision-making. And this is quite well demonstrated while we perform some classical interventions, when we help people with different cognitive disorders. So I took a couple of questions from an overview on the classical methods of aid and help, and they're connected to the administration of different medications. So here we describe different processes. For example, we give a medication, it helps, but what has been enhanced by drugs? Which process has been enhanced? Which process has been suppressed? And without understanding cognitive processes, it will be quite difficult to understand and to expect some particular results of the intervention. So you can enhance one function and then offset the other one. What is the efficiency of what is going on? It should be assessed on a cognitive level. And as I've already said during our discussion, one of the leading medications that helps with the Alzheimer's disease, well, they have the 2 points on the whole scale. So my idea here is that it helps, but we should understand the consequences of an intervention. Are there any consequences? Well, usually there are some. And who from your participants of the experiment reacted to this intervention and who didn't? And here we face the individual consequences for a particular person from a medication. They could be different consequences, not only proceeding from the pharmacological interventions, but also proceeding from the behavioral ones. And so this is the focus of a study of intervention when we help people with cognitive disorders. Well, neurocognitive disorders can be determined quite differently. We have a lot of schools here, according to the number of the disorders. But here we see that those are connected to all basic cognitive functions that can be found in any course book. Those are disorders of motor functions, attention, cognitive control, memory, training, language, and social cognition. And here we will go back to our panel discussion again. Those are very different levels when it comes to their complexity. Some levels can be attributed to some local processes that are occurring in some brain areas, but some of them are more social. So here we should study not only one brain, but we should be examining the interaction between different brain systems. So the approaches towards the study of cognitive disorders can be quite different, and we have chosen one for ourselves. I'll be referring to that today, and I'll be talking about our Institute of Cognitive Neurosciences and about our partners at HSC. So definitely we understand that there are different trends in the research of cognitive disorders, and Konstantin Anorkin was also mentioning some very important and interesting neuroprocessing and interaction between different neurons at the same time. So here I probably agree with the opinion of the doctors that say that one of the main areas of this research are the biomarkers to diagnose, then the early prevention of neurodegeneration, and the next one is about the monitoring of the treatment and monitoring of the efficiency of the methods available. That's the way we also try to proceed with. And this is an overview of the neuroimaging-based markers in psychiatry. Here we can see MRI, which is dominating the CAT studies as well, but a lot of biomarkers are also connected to the structural changes in our brain. Well, this is a very good and understandable classics, so to say. If we see some structural changes happening, then we can also forecast some disorders. In our labs, we took a little bit different approach. If I could use the graph of my colleagues, then I need to say that our understanding of a disorder is more dynamic. So we see the brain work as not a work of one area, but as a very comprehensive and complex network of different areas. And this is the dominant approach in the cognitive biology today. So we should not be talking about just one neuro area. If we want to understand the symptom, but not only the symptom, but also the reason, the cause of the disease, then we should understand what was the root cause of that and what results in particular symptoms. So that's why we focus on the work of the distributed neural networks. And proceeding from that rules and laws, we try to identify the persistent markers in our brain that actually determine our behavior and our cognitive functions across our whole life. Those are some dynamic processes that can be changing. They can be quite fast in changing because of an intervention or because of a disease. And this altogether allows us to develop our methods and approaches and to create some new methods of neuromodeling of the brain activities, and they are quite adaptive to the states of your brain. This could be adapted to some individual peculiarities or some dynamic peculiarities as well. And here we take a look at multimodal approaches. As the practice shows, we cannot create markers efficiently when we take only one approach. And here I need to mention Vadim Nikulin. He's already been speaking in here, and we have some joint research in that respect. And he's been developing the idea of some dynamic characteristics of neural nets. If you missed his presentation, I strongly advise to follow his presentation. It's very interesting. So he develops the idea of some mathematical laws. And this is about the idea that there is a balanced state of a brain. This is optimal for receiving information, for our behavior, for providing for the cognitive functions. So you can have some subcritical state. If you have this pile of sand, then you can have a critical slope. This is a high hill, and this is very sensitive to each of its elements. So if some small elements will be added, then you'll be facing an avalanche. So this is a very sensitive system, and it can be sliding into some unstable state at all. And so this analogy is very interesting one. It's done by Vadim, as I said. And so he focuses on this balanced state of a brain and of the brain functions. And here we see also very interesting research. We've been doing it together with our German partners. And here we show the state of our brain, and it can also be a marker of some particular interventions. So here we can see the long-standing correlations that Vadim has been mentioning, and this is about the criticality of the balanced state of the brain. So we can see these markers before an intervention and after that. And here we can see the changes. And on the right, you can see quite clear correlation of these markers with the changing symptoms. So the characteristic of these local processes can also be a very efficient marker of what is going on. What is the most efficient medication? We got this question. Well, I'm not a doctor, so I think that we should refer these questions to doctors or to Philip, who has been dealing with this kind of issues. So I'm a neurobiologist, and I'm focusing on cognitive activities. Another work, which is about to be published in Stroke journal. This is by Marina Nazarova, and she's a doctor and she's a scientist at our center as well. And she tried to combine parameters that will forecast the restoration after a stroke. And she focused on two modalities here. First, on the connections in our brain. And she got it with the DTI and MRI. And also she studied the reaction of a patient's brain to some kind of activities. And so this shows that those methods can forecast quite clearly for different groups of patients. But if you really want to divide patients across 3 groups, for example, then you would require a combination of these methods that would result in 100% of the clearness and precision of the results of the restoration after a stroke. And this kind of analysis of a complex and comprehensive neural dynamics in online MRI also have been used by us. I'll not go into the details here. I just would like to remind you that we are focusing on the 2-directional interface here. So here we have neuronal recordings. We've been reading the information from a monkey's brain, and then we also translated it into the avatar work, and then we got it back to the brain. And so this is a multimodular project. Here we're reading the activities of the brain, and we also stimulate the brain. And this multimodal system is also quite fitting for Michael's projects, and I believe that he'll be developing in the same direction at Skoltech. So our approach boils down to the fact that the cognitive health is connected to the distributed systems in our brain activities. And if we can assess it, and if we can assess the dynamics of this system's work, then we have some persistent characteristics of these dynamics, and we have also fast-changing characteristics. And by this, we can create the methods of marking the cognitive state of a person. And those markers would be individualized. They would allow to apply brain stimulation methods and adapt them to some particular brain condition and state. So that's how and why we use multimodal approach. And these interventions can be not only performed in the form of an intervention or medication, we can also go to some other interventions. And here I'd like to touch upon the topic that has already been mentioned. I would like to talk about the changes that will occur to us in any ways with the age. So after 45 years, our cognitive functions start to deteriorate. And the majority of us, if we live up to 100 years, will face this or that cognitive problem in any case. And so the problem which we've been developing in the cognitive neurobiology is that across our life, these are our cognitive resources of our brain. They are developing, but then starting from some particular age point, they start to deteriorate. And the worst piece of news here is not that they're just deteriorating, but that they're deteriorating at a very risky state. And here we start to talk about the intervention. We can enhance our cognitive resources at some point of time. And it goes quite well with the idea of Philip that has already been mentioned. So we can forecast for the future to accumulate some additional cognitive reserves for our aging future. So here we can enhance these resources to such a level that when we go down afterwards, indeed we will face some problems, but they will not be critical. So we will not reach the level when we will be feeling impaired or we will experience some cognitive disorder. And so here we work across different approaches. Here you can see Matteo Fiura, a significant scientist. On the one hand, he develops the individualized approaches to the brain stimulation. So he uses these or those biomarkers and he tries to choose the individualized protocols of the cognitive functions influence. And we have another approach here, neuroenhancement. This is about the idea that some cognitive functions can be accelerated a little bit more, even much more. And here we also talk about alternative current neurostimulation. When we use some particular length of the current and we apply to a particular area of our brain, then you can really enhance some functions of our brain. And this approach should be very much individualized. Another interesting area of development here is about using the markers, multimodal markers of a cognitive state. And this is done in our group that is studying speech. And this is the result. Here you can see across the vertical axis, you can see the results while people are performing some difficult tasks, and the x-axis is about the volume of the gray matter. And here we have different colors, and they indicate the level of the second language fluency. And so here we can see the proportion. Depending on the level of your knowledge of the second language, you can also track the neuroactivity in your brain. So it's very interesting because without any invasion, you can actually model some functions. With the study of the second language and the level of this language fluency at a person, you can also monitor the cognitive resources and you can enhance them. This is the line that we have been using in our studies. Take it comprehensively. We believe that we can study dynamic and polystatic markers of these neural networks. And we can come up with methods that are adaptive to our brain and to our particular states. We do use different approaches. And here, Konstantin Anokhin has already shown this classical scheme from the course books on neurobiology. Here you can see different methods. Across the vertical axis, we have the spatial dimension, and across the x-axis, we have the time dimension. So here we can see different methods. Sometimes some of them are quite well localized in the brain area. Some of them are quite well localized across the space, but I should indicate that there is no ideal method. Which methods should we use during our cognitive research and interventions? This is a very good question. If we pick out a method, then what methods are available in Moscow? EEG, MRI, MEG. So they are quite similar when it comes to the spatial dimension. Some of them do have some advantages, but they're different when it comes to the timeline. So MEG and EEG can study neurobiological correlations quite well, but when we talk about MRI, then it'll be quite slowly done. But if we take a look at the price, the selection, and in the invasive factor, here we can see the difference. So there is no ideal methods, and that's why I say that we should have them in complex, in combination. So we do have very good centers of expertise in neurobiology and cognitive neurobiology in Russia. Those are located in St. Petersburg, in Moscow, in Kazan, in Novosibirsk. Lately, we've come up with some new participants in place that we should be aware of. So that was done due to the system of mega grants. We have two prominent labs in St. Petersburg by Yuri Shturov. They're studying speech processes, and also the lab by Yelena Grigorenko, and they are studying aging processes and their connection to cognitive functions. There are some new projects also due to the mega grant. For example, in HSC, we also have such a project. In our lab, we also have a very interesting lab of psychogenetics and its connection to the age. In Skoltech, we also observe the development of cognitive developments and researches quite a lot. So this is the answer to the young scientists who ask, where could they apply their knowledge? And we also we received these questions during our discussion. How can we make the centers attractive for our youngsters? Well, they have been developing very fast, and we have to monitor these processes. And in our center, in our lab, we took a decision to equip our lab with some baseline methods. I believe that we have the leading system on the brain stimulation, from transcranial to the stimulation with the alternative or other type of current. We have EEG, etc. We also have a joint laboratory together with one of the institutes. This is on the MEG. We also established relations with the clinical basis due to our partners and our project on invasive interfaces. We also have good relations with the MRI centers as well. But as Konstantin Anokhin has properly said, we have 2 or 3 MRI scanners in this country that actually can be focusing on research. So as of today, we have been quite well equipped. And here I'd like to mention another aspect of cognitive sciences and cognitive disorders, and it is connected to the cross-functional study. So, for example, here we can see the classical course book, and if we take a look at the chapters, we see everything here, from the cognition to emotions to language to the cognitive control, social cognition, and evolutionary perspectives. So we do understand that cognitive problems are quite interconnected. We can visualize it in this kind of a platform and pyramid. So we understand that we're proceeding from some kind of a molecular and biological level, then to a more complex one, to neurons, to the brain, to the cognition, to the social aspects, and to the environmental aspects. That's what we have been discussing today. So the genes, the biochemistry, the society, the evolution, everything influences us. It's understandable that historically we've been studying these areas across different neuro and cognitive sciences. What we have tried to do, we try to synthesize all these levels at HSC. Well, evidently, this is based on the mathematical modeling. I just wanted to demonstrate it with a couple of slides, the interaction between different levels. So the social level can be interacting with the biological one quite well. We have a lot of examples related to that. Those systems can be quite different. For example, the multiple determinism of different functions. So we have, for example, biological and social factors coming all together. For example, drug abuse and addiction on the biological level has been also determined by some genes, some specific receptors. But when it comes to the social level, drug abuse and drug addiction is also highly determined by the social environment where we live. And this influences our behavior and cognitive functions. For example, another sample, testosterone and the sexual behavior of primates. This could also be studied from different aspects. So we have biological aspects and the social aspect here. And another example, the third one here, it's very interesting for us as well, non-additive determinism. So the specifics of a whole, of the social whole, cannot be boiled down to some biological ones. So here we studied the monkeys, and we understood that the social level could be also be influencing the social structures and the behavior of the monkeys. So the cognitive processes are very interdisciplinary here. Here we can see the neurobiology, humanitarian sciences, computer sciences, etc. So our tradition has this flaw, which is characterized by the weak social and other aspects. And we believe, we hope that we will open our cognitive center in the almost very center on Moscow. This is the building that is planned. So we will have the transcranial magnetic stimulation, also near infrared spectrography. Then we will have the transcranial magnetic stimulation MagVenture. We will have a couple of stimulators, and they'll stimulate a couple of brain areas. We will also have robotized systems that will allow you to, or us to conduct some very comprehensive and difficult trials. Then we will also have the cognitive floor. There we'll be studying cognitive functions development, the eye tracking, the 3D vision, and 2D vision as well. And on the next floor, we'll have the brain-computer interfaces lab and also the neuropsychology lab. This is a mega grant received by Olga Dragoy. They're studying speech disorders. And on the fourth floor, we'll have the social neuroscience and neuroeconomics groups working. So we try to synthesize all the levels of cognitive processes, from the perceptive ones to the social ones. Going back to the question whether our research can be made attractive to the youngsters, well, we started our project at the eve of 2014, and it took us 5 years to reach quite a good level, to become visible, and to become quite attractive for our young scientists. And for those who are hearing about our Institute of Cognitive Sciences for the first time, I'd like to present our opportunities and capacities. 2 research labs. Also, we are specializing in neurodynamics, the neuropsychology of the speech, neuroenhancement, cognitive enhancement, the modeling of addictions, and also the impairments of decision-making. And by this slide, I'd like to finish my presentation. So we perceive cognitive processes as a comprehensive, difficult, spatial and time-split processes. And we use different methods of biomarkers and individualized methods of interventions. With this, I'd like to thank you for your attention, and you can always reach our website of our Institute of Cognitive Neurosciences, and thank you very much for this opportunity to be presenting at this conference. Colleagues, Vasily, thank you very much. Indeed, this was another overview with some kind of focus on what is going on in the High School of Economy. Thank you very much for this informative presentation. We did receive some questions. I believe that you can be answering this on an individual basis because we are quite time limited. And now we'll give the floor to our next speaker. And while Philip is connecting, I'd like to add something from our panel discussion. And I'd like also to give you the idea of this conference, why we organized it and gathered it. So this is not a purely scientific conference, as everybody has understood. This is the concept of the Samara Neuro Week, Neuroscience Week. And yesterday we had this VCI Samara conference. This is for the multidisciplinary teams for young scientists from different areas of the science. And this is for those who are just interested in some new research, in some new developments, in the application into the practice when it comes to the practice in business. Why do we do that? We do that to highlight the developments that we see today in the science, how they can be applied to our health. And also we'd like to mention the challenges that are currently faced by our science. And by this, we hope that we will, on the one hand, involve some young scientists that will raise awareness, raise interest, will give an overview of a very complex brain system organization, will introduce the idea that a lot of different specialists should be involved in these processes. But on the other hand, we'd also like to motivate the entrepreneurial community. I believe that the discussion that was devoted to the medicine, to the approach of the medicine, and to the problem that actually exists in the society and how it is viewed in the society by a lot of non-medical specialists, so to say. And I believe that Dmitry was quite right focusing on that, because he focused on the sociology and on psychology. So this was another uptake. And I do hope that due to this conference, we will highlight this issue and problem, and that will also be able to involve the entrepreneurial community. So we'll have another motivation to develop and stimulus to develop these technologies, to involve more and more young scientists, because labs can be located not only under universities. So we've heard this example with Elon Musk today, and this is a private company. In this country, in Russia, I mean, we have a lot of companies, private companies, businesses that have been developing different technologies. One of the examples is Sberbank Lab, neuroscience lab, and they study their clients, they study their employees. Those are also neurosciences. This is another stimulus and jolt to develop this area. And now I want to give the floor to Philip. And he'll be talking about a little bit different aspect of this neuroscience at the level of the cell level, the biochemical processes, etc. So this is the evolution that have been mentioned today, how we study it and how it's been developing over age, and will give us the opportunity to create this cognitive reserve.
I'll be making my presentation in Russian with the slides in English. As Natalia has mentioned, I'll be talking about the molecular organization of the human brain. There are various approaches to studying the brain. You can study the behavior. On a deeper level, you can study the electrophysiology and connectivity, neuron activity, and the way the neurons connect with each other in the human brain, the way they are arranged in neural networks. And the most profound level, the deepest level, is the molecular biology, the area we are involved in here in Skoltech. And I would like to share a few examples of the research being done in Skoltech and the outlook for human brain research at the molecular level. The human brain is a very complex structure with a very complex anatomy and very complex structure. And when we analyze various cell types arranged in various anatomical structures, we observe different molecular components. First of all, it's water, but we don't research water in Caltech now. RNA, those molecules which transfer information from DNA to proteins, and polar metabolites, which are the basic molecules which store energy, and lipids, which are also energy molecules, neurotransmitters, and are involved in transferring other types of signals. When we analyze this data, we try to reconstruct brain structure following those changes that we observe at the molecular level. As Natalia has mentioned, we observed that over time, because when a person is born, brain is developed only by 25%, and you have seen the way it develops over time. But the most important thing about the human brain, about the cortex, is that the neural networks for the newborn, they're not there yet. And if we look at the way neurons connect, and the neurons, they're responsible for controlling our behavior, you see that those connections, they are just emerging in newborns, in children. And when we look at neurons and synapses, so here you see a picture of a neuron with lots of dots. Those dots are synapses, synaptic contacts that neurons use to communicate with each other. But this is a neuron of an adult. If you look at a neuron of a newborn, of a child, it will be just a neuron without any synaptic contacts that an adult has. Well, the thing is that the human brain develops under the influence of the environment. And we don't know how we will respond to the environment in the future, and how we will structure our communication with other people, about how we will respond to dangerous factors, for example. So these all influences the human brain development, all the processes behind the human brain development, and synapses are just one part of this overall development picture. Let us see whether we will be able to reconstruct the brain structure by analyzing the RNA activity and proteins. So in this picture, you see that DNA is present in all the cells. And DNA is basically an archive, a library of all the genes which govern the way our body develops, not only the brain as such, but other organs as well. The DNA is pretty much the same across all the body organs, with some minor differences, but they're not significant for the purpose of this talk. It's just that in liver, for example, one group of genes is triggered in another organ, a different group of genes is triggered, and those gene combinations, they change across the body. If I look at the amount of RNA, which is being read from the genome, we can deduce the kind of genome which was active at this or that period of time. If we look at the evolution of the cognitive function, we may assume that there must be some special molecular substrates in the brain. And we could compare our brain with the brain of a chimpanzee. This is what we did in our lab. We have a huge collection of brains. This is the frontal lobe, the frontal cortex, which is responsible for our behavior and interaction with the environment. There's a similar set of samples taken from chimpanzees. and macaques, we have identified a group of genes responsible for the peculiar development of the human brain, different from other. Species. But what are those genes? Let us try and reconstruct what they are responsible for. It turns out that the genes are responsible for building the synaptic contacts, those knots responsible for transmitting signals between the neurons. Because neurons, well, they can't really talk to each other. They only have an electrochemical communication with each other. So one neuron triggers another neuron, or one group of neurons triggers another group of neurons, which in the end ultimately govern our behavior. This is what we can see through an electron microscopy. You know, in biology, we have to believe only what we can see with our own eyes. Because if in mathematics everything is based on abstract concepts, in biology you only believe in what you see with your own eyes. Otherwise, no one would believe you. So here, the electron microscopy helps us to detect those electrical synaptical contacts, and we have been able to count the number of synaptical contacts in the frontal cortex of a human and of a macaque. They're shown here in this diagram. So when a human baby or a macaque is born, there are no synapses whatsoever. Because, well, you know, the frontal cortex is responsible for interacting with the environment, and the newborn, it doesn't have any interaction with the environment yet. Of course, some basic instincts, they are there, but some complex social behavior, some complex social interaction with the environment, it develops over time only. That is why it is so important to pay attention to the proper social development of a child. The number of synapses peaks by the 5th year of life, and after that the number goes down. Why? Well, because our behavior patterns become a routine for us. So by the age of 5, a kid knows how to interact with the environment, and he needs less new synaptic contacts, less synapses. Because when you go shopping, for example, you usually shop for the same things. It's a routine, it's a pattern. Otherwise, we would spend a whole day shopping, not knowing what to buy. In case of macaques, the number of synapses, the number of new synapses peaks by the age of a few months. So by that age, a baby macaque knows how to interact with the environment, and after that, it all becomes a routine. And the number of new synapses goes down. So we have a very different dynamics here, a very different trend. Chimpanzees, they're much closer to humans than macaques. We were the same species just some, I don't know, 7 million years ago. But the qualitative shift that we have observed during the gene expression stage, we see that the number of new synapses obeys the same dynamic across humans as across chimpanzees. So we have identified certain changes at the gene level, and then we reconstructed the brain structure, one of the processes in one of the brain regions. Again, I have to remind you that the human brain is a very complex structure. Before we have analyzed only one process, only in the frontal cortex. So some people think that human brain is just really enlarged ape brain or a bat brain, but it's not true. So we have to analyze the human brain at a deeper level in order to be able to identify the unique features of the human brain, which differ from other species. Another part of our lab's research is dedicated to studying lipids, fat cells. Well, some people may say that there's nothing unique about the brain fat composition, but you know, the fat cells, they're used in cell membranes, and this is where all the interaction happens between all the receptors, between all the cells, and the properties of a membrane do affect the property of this communication between the cells. Well, we know that, and we know that if you try to dry out the brain, dehydrate it, you will be left with the fat cells. But how does that affect the brain functions? It's all about the emergent field. Well, the scientists started the research of lipids some 60 years ago, but there have been significant breakthroughs and advances over the past decades. And lipids do represent the physiological condition of the brain over time. We have all the technologies for studying that, like mass spectrometry, which enable us to collect data on hundreds and thousands of lipid compounds in the brain. Then we decided to take it further, to analyze what happens in a healthy brain compared with the processes we observe in a damaged brain of a person diagnosed with schizophrenia. I know that the brain has a very complex anatomical structure with different responses in different regions. So we took various regions for our analysis, like primary cortex, secondary cortex, and you name it. We compared lots of different groups, and here we analyzed the several brains of schizophrenics and 4 brains of healthy brains. Well, the bad thing about this experiment is that we were studying the brain of a dead person, of dead people, but you know, the lipids are still there. When they discovered the city of Pompeii, which was buried under volcano ash, all the things remained intact. And by analyzing the remnants of that city of Pompeii, the scientists were able to reconstruct the life of the citizens before the tragedy. We're doing quite the same thing. So we take a dead brain, but in terms of lipids, all the lipids are there, intact, all the buildings are there, all the plates and cups are there, and we can reconstruct what was going on there. This project is still ongoing, so I cannot share the final conclusions with you yet. But those blue dots, These are samples of 75 regions of the brain with 4 control regions, which don't have any cognitive pathologies, and the orange dots. These are the samples taken from the brain of a schizophrenic. And we see that there's quite a lot of difference in one case and less difference in another case. And this is the coloring of those samples by anatomy. We will see it now in more details. And we see that there are lipids which are typical for the myelin, lipids typical for the gray matter, for neurons. They are shown in yellow. There are lipids responsible for the emotional roots, those greenish. And if we look at all the 175 regions, well, you won't see the names of those regions because they're in a very tiny font here, but the size of the bar shows the amount of change in lipid composition, the size of variation in lipid composition between the brain of a healthy human and the brain of a schizophrenic. If the bar goes down, the number of lipids goes up, and if the bar goes down, then the number of lipids goes down. So we have a number of clearly defined aspects here. There are certain regions where there is no difference whatsoever between a healthy human and a schizophrenic. The second aspect is that usually the changes go either up or down, so the number of lipids either increases or decreases. And we see that the green color is dominating here. The green color shows the myelin. So the number of lipids in the myelin either increases or decreases. And so the connections between lipids represented by myelinized axons it either increases or decreases. If we look at the regions where the number of lipids goes up or down, we see that the main decrease in the number of lipids is observed in the white matter and the midbrain. The white matter is where we have the so-called power grid in our brain, and schizophrenics lose this connectivity between neurons. So there's much less connectivity between the neurons and less connectivity in the cortex. There's more white matter, there's more lipids in the associative cortex, in the basal ganglia, and in limbic cortex. So this is a pathological growth of such connections in different regions of the human brain diagnosed with schizophrenia. So we see how it works here on the brain map. The white matter grows in some areas and it shrinks in other areas. But what about the practical meaning of that? Because you can't really take a live human and start cutting into the brain. Well, we tried to identify those differences in blood plasma. So for that, we carried out quite a large-scale research in cooperation with the clinical institutions of 3 countries. We collected the blood plasma of people diagnosed with schizophrenia in Germany, Russia, and China. We analyzed that on using mass spectrometry, and here we show different lipid classes by different colors. And here we show the same colors in the form of bars. So we see how the number of lipids in different classes either goes up or down. And we see that in all the three cohorts, German, Chinese, and Russian, we have uniform changes in different classes. So here we observe very strong correlation. So in this slide, we show the data set for carnitine with a lipid tail, 18 carbon atoms and 2 double links. And here we see that the concentration of carnitine in the blood plasma of the control group and of the people diagnosed with schizophrenia, well, of course, there are some outliers, but if we were to draw a border here between the two, by the amount of carnitine in the blood plasma, well, here we would see that the concentration of carnitine goes below 20. Of course, this is not a direct indicator of schizophrenia, but this is quite a good proxy marker. Some of the changes that we detect in blood plasma, they have inverse correlation with blood plasma. So if something shrinks in the brain, it increases in the blood plasma. At this point, I would like to finish my presentation and let me say a few acknowledgements to all my colleagues who participated in this research, and thank you for your attention. Well, thank you so much, Philip. Thank you so much for sharing what is being done in terms of scientific research of the human brain at the molecular level, because just a decade ago, those results were not there. But the main reason was that the research was not being done. That's very simple, and I know that your group has been involved in that research for a decade, and I know that it takes time to collect some representative data to share. Well, I have to say that there's nothing special in what we said. We use quite generic technology used by other labs as well. The only difference of our group is that we are studying the human brain, because 99.9% of all the labs involved in fundamental research of the human brain molecular aspects, they deal with models, and we work with humans, with primates, and people diagnosed with various brain disorders. So we, on the one hand, we are not doing anything special, but on the other hand, we have some unique research results. I assume that at the next stage, you will be working on identifying the correlation between your results and the results of research done in the High School of Economics, for example, and in other research groups. Yeah, absolutely. In the schizophrenia project, we have already identified a strong correlation between the molecular changes and the results of the MRI. Well, ideally, of course, we would love to analyze the live brain dynamics with the molecular changes. Well, of course, we will have to work with mathematical models and simulations, which are as close to the human brain as possible. You know that the human brain is still understudied at the molecular level. even though that the lipids have been known for many decades, but the science knows that lipids control the connection between the neurons, but the number of labs and research groups involved in that is still very low. The trend is there, but I would say that this trend is somewhat strange, because we need to have focus, need to have focus on fundamental mechanisms of human brain operations so that we will be able to prevent brain disorders, to intervene before it breaks. Well, if we draw an analogy with the selection of therapy for neurodegenerative disorders like the Alzheimer's disease, I suspect that since there's no drug, they have to work with metabolites to maintain the healthy brain condition before it tips over and starts degenerating fast. And I think that this confirms the fact that many disorders can be prevented before they cause the irreversible brain damage. My dear friends, if you have questions, please submit them using the Q&A function of Zoom. We're not going to have another panel here. And now let me pass the floor to our next speaker. Well, Philip, thank you so much. Let me pass the floor to Marat Kurmashev, the Deputy Director on Medicine at Alexeyevskaya Clinic. And he is also involved in the Memory Clinic project. Part of the research presented by Philip was done in close cooperation with the Alexeyevskaya Clinic as well. So I'm really looking forward to hearing how the results of the research are used at the medical level. So Marat, the floor is yours.
Good afternoon, Natalia. Thank you for this invitation to participate in the conference. So I believe that I have a very practical presentation. I'd like to share the experience, our experience, we believe it to be a unique one, how we help elderly people who have the initial cognitive disorders and impairments. So cognitive impairments are highly associated with an age, but one needs to understand that this is not a normal aging process. This is a condition, a disease, in particular dementia, and one would learn to prevent it and to treat it. So what is dementia? This is a syndrome of an acquired progressing decrease in the higher mental functions, and it leads to the impairment of professional, social, and daily functioning of a patient, and it can lead to the identity disorder. Unfortunately, our patients come to us, psychiatrists, I'm a psychiatrist as well, in such a state when, in fact, we do see the disintegration of the identity. And not the people around them, not even the relatives, can spot the changes that are taking place in their dear ones. Or they can also just think that, well, this is due to the age and one can do nothing about it. So a couple of facts on dementia. Each 3 seconds, a new case of dementia is diagnosed. Currently, there are 50 million of people suffering from dementia, and by 2050, this figure will triple. And in 60% of the cases, the dementia has been provoked by the Alzheimer's disease. And the WHO confirms that the dementia is the priority of the public health. And in 2017, the global plan of actions to react to dementia up to 2025 was approved. And the main goals of the WHO is to provide for the investment in the healthcare and to improve the prevention activities, the diagnostic activities, as well as the methods of treatment as to the dementia, as well as they're aiming at enhancing the innovations treating the dementia. So dementia is among disease that has the very high burden, and totally it accounts for the cost that we incur because of the oncology and cardiovascular diseases altogether. So here in yellow you can see the dementia costs, and the blue and red ones are the costs of treating oncology and cardiovascular diseases. And based on the WHO data, indirect and direct financial burden of dementia accounts for 1% of GDP per year. So for Russia, this is a huge number. What are indirect costs? This is because of the decreasing the level of life, the quality of life of a person, decrease in social functioning, and also the attracting expenses or attracting additional financing to take care of a patient, and this is quite a heavy financial burden for the relatives. The number of elderly people has been increasing significantly. Russia is not an exception here. So now we can see that 32 million people in Russia over 60 years old are there, and in a couple of years this number will grow, and by 2035 this number will account for 43 million. So this is quite a challenge for the whole healthcare system. In this country, we haven't conducted population studies for quite a long time when it comes to the cognitive disorders. Proceeding from the international data, people over 60 years old, 25% of them are registered with some cognitive disorders, such as, for example, the mild cognitive impairment. And if one does not do anything, then in 30% of the cases, these patients could be diagnosed with dementia. What does this mean for Russia? As I said, there are 32 million of citizens of Russia that are over 60 years old. So 8 million of these people have already been diagnosed with some cognitive impairments. And 2 million have been diagnosed with dementia in Russia. This is as of today. The mild cognitive impairment. This is a syndrome that occupies the interim position between normal aging and dementia. When patients can cope up with it themselves, just perform some daily tasks, but their cognitive level is decreasing. And we noticed that those patients have not been covered when it comes to the attention to the medical community. And here I'm talking about the stage when we still have the window of opportunity and when we still can help these people. And we decided to develop a comprehensive program of neurocognitive rehabilitation for patients with some dementia impairments. And we developed this program, and we opened the first memory clinic in Russia. And this was for people with mild cognitive impairment. What is a memory clinic? This is a rehabilitation department for a daily care of people, of elderly people who are suffering from some cognitive impairments. And they are trained in groups, and simultaneously 50 patients can come to the memory clinic. And so the rehabilitation timeline is 6 weeks. And over a year, one memory clinic receives 8 cycles like this. So memory clinics did exist and do exist now in the West, but their main difference is that they sustain patients with already developed dementia. However, we are focusing on the prevention of cognitive impairments among elderly people. Here on the slide, you can see the main stages of the clinic work. So attraction of patients, the selection procedure, diagnostics, then rehabilitation, and then the finalization of the procedure. And I'll elaborate on each of these stages. Pre-hospital stage. To identify cognitive impairments, a psychiatrist assesses, examines, based on MMSE tests and CDT tests. And if a patient is diagnosed with any cognitive impairment, then the patient is included into the rehabilitation group. After this, there is the first diagnostics week. And then there is a medical psychologist. And we have some additional scales introduced here and tests. And after that, the patients are divided into 6 groups according to the level of their cognitive impairments. And on the first week, we start our trainings to motivate the patients and to explain the goals and tasks of this rehabilitation process. And starting from the second week and ending by the 6th week, we have this rehabilitation stage. We have cognitive trainings, the therapeutic exercises, also some medication treatment if necessary, and also mental treatment. The trainings last for 5 hours every day, 5 days per week. So here you can see the main trainings, the cognitive one, the memory, the resource-oriented training, the cognitive warm-up, etc. And by the end of the 6th week, the doctors and the psychologists once again examine our patients across the same scales that we had before the start of the program to assess the dynamics of the condition. And here you can see the scales themselves. The main ones, I've already named them, MoCA, MMSE, the scales of depression, etc. And here you can see the results that we get based on our rehabilitation program. We get this according to the MoCA scale and MMSE scale. And you see that about 80% of the patients deliver visible results. And these results have been occurring for quite a while in our program. And to confirm the efficiency of our program, we conducted a couple of comparative studies. And one of them was the following. We compared 2 groups of patients. So this is a placebo-controlled research. And we had 2 groups. One of them underwent the rehabilitation program, but the second group was in the same conditions but did not undergo the treatment. And what did we identify? We also used the computer tests for this research to avoid any mistakes when it comes to the data interpretation. And here you can see the results according to the MMSE scale. And here we can see that at the very beginning of the testing, both groups are at the same level. And here you can see the red line. And it shows the results of the experimental group. And the blue line is the control group. And here you can see the statistically confirmed result, because the group that was receiving this rehabilitation treatment and that participate in the program delivered some good improvements. When it comes to the test of watch picturing and drawing, this is even more interesting. We have the better results in the control group in comparison to the experimental group in the very beginning, but after the program, the experimental group improved its indicators, and the control group stayed intact. And here you can see the results of a computer-based testing. This is the test against the geometrical figures and the operative memory. At the very beginning, patients are given a couple of geometrical figures, and they need to choose them among the larger quantity of figures. They need to choose those that they had seen before. And after 6 weeks, the results here are even more interesting. So the experimental group delivered very good improvements, but the control group actually was recorded with some kind of a reduction in its indicators. So this is also a statistically significant difference. Another examination of ours was conducted when one of the groups was receiving some medication, and the second group did not get any medication. But both groups underwent the rehabilitation program. So here you can see the groups before the start of the program and then after the start of the program. And here we see that in both cases, both groups improved their results. So we can see some positive dynamics over here. Indeed, with the medication help, the results were better and higher, so to say, but when it comes to the statistics, there wasn't quite any difference. So that's how we confirmed the efficiency of our method. We also organize the post-rehabilitation monitoring among our patients, and we do see that the effect of our program persists over a year and even longer. And then, after that period of time, we recommend, if our patients have this opportunity, to repeat the program and to undergo this program again. The main goals of this project is to decrease the share of elderly people in our society with cognitive impairments. Then we want to create conditions for active longevity, to extend the life expectancy, to decrease the necessity to send elderly people to some social and mental facilities. And of course, we want to increase the life standards of our elderly people, as well as of their relatives and their dear ones, and those people that are around them. And we do hope that it will add 10 years of cognitive health to them. Currently, 65 years is the point when the dementia rate is increasing quite actively. But if we start to organize some prevention activities, then the prospect for us seems to be quite favorable and promising. Over the course of our work, of our clinics, more than 4,000 patients underwent these programs or participated in these programs. And so we continue operating, and we have 8 memory clinics right now. And quite often we receive the question whether it's for free or it's organized on a paid basis. For the patients, I need to say that this is absolutely free. And currently, we also consider the issue of including our program into the federal project, the elderly generation, and together with the service of the chief geriatrician, we plan to open such memory clinics in each of the regions of the Russian Federation. Of course, now, against the pandemic, this timeline has been shifted and moved, but we do hope that we can manage to do that in the future. So far, we go to the regions ourselves, and together with our colleagues, we open the memory clinics in other cities. And by the way, the first city where we opened such clinic was Samara. Last year, our method was integrated into the work of our colleagues, and the chief psychiatrist of the Samara region, Mikhail Solomonovich Schaefer. Mikhail Solomonovich, if you can hear me, if you can see me, I send you my regards. And in the nearest future, the colleagues from Nizhny Novgorod will come to allow us to share our experience, and we also will include Sevastopol into that list. So the basis, how we scale this method, this is due to the guidelines that include all the methods, all the processes of the rehabilitation, the algorithm of our work. And as we also call it, we included business processes connected to the launch of the memory clinic. I do understand that we cannot cover everybody, even with these capacities, everybody who needs our help. And taking into account the pandemic situation, we also developed a remote course for our patients. And the patients can subscribe to the program on our website. And then they'll receive the link to the video course. And so this is kind of a network that we envision. I believe that the current situation also helped us to proceed with that. So you can study in a remote format, being at home or at some social caring center or at an outpatient clinic. Or we can also be in some specialized and equipped classes. I believe that this is it from my side, but I still have some time left, and I'd like to show you a video, and it is called One Day in a Memory Clinic, and it demonstrates how our patients come to us and also which result they see, they assess, they get. I'd like to mention and underline that those are not professional performers or actors, those are our patients. I hope you like it. So dementia, the elderly people are susceptible to dementia the most. There are 50 million people with dementia, and annually 10 million of cases are added. The Alzheimer's disease is the widespread form of dementia. Dementia is one of the reasons of incapacitation depending on and the dependence of the elderly people across the whole world. Dementia influences, physically speaking, psychologically, socially, and economically on the people. Not only on those people who suffer from that, but also on the people around the patients. So the memory clinic, the medical rehabilitation center, How are you feeling? Oh, much better. And how is your appetite? Well, it's actually better than it should be. Do you like the food? Yes, indeed. I have great cereal in the mornings. Look at this. Hold your hands like this. Spread your fingers. Bit a little bit. Okay, that's it. You can continue.
Вы знаете, я очень много уделяю внимания мышцам.
You know, I pay a lot of attention to the muscles, to my spine, to the backbone, and the memory loss that has been increasing for me. It made me think about my brain, about my head. So I came here to meet new people, first and foremost, to meet some psychiatrists, to learn about the skills, about the exercises and methods that can be used to prevent this memory loss and to prevent it from being so difficult for me. My sister suffered from Parkinson's disease, and I saw that she couldn't manage herself at all. I would like to be independent to the last very day. I'd like to live a full life. First, I started to understand what I actually do. That's very nice. My relationships with my relatives have improved. I have grandchildren as well. And I've come to a better understanding how to cope, to interact with them. Here I participate in some trainings and I also do some exercise at home. I believe them to be very important, and they also raise the cultural level. In the past, I mixed a lot of things. I could go in the wrong wagon, in the wrong car, but then it stopped. In the past, I used to be rude with people, and then I received some criticism in public transport. But now my reaction has become completely different. Either I don't pay attention to that at all, or I just smile. While in the past, I could be quite rude to people. So I feel that I've changed, and I'm very thankful to everybody, to the psychologists and psychiatrists and everybody. I'm about to finish the program in this clinic, and actually now I'm walking outside, I'm smiling, and I feel quite happy. Thank you very much.
Этот фильм меня всегда впечатляет. Я смотрю
This
его.
video always amazes me. I've seen it for multiple times, but it motivates us to continue our work for our patients. So this is our story. Mara, thank you very much. And for the video as well, because today we are talking about cognitive health. And our audience is quite young today, and I don't think that everybody is thinking today, except for the situations when they have some elderly relatives. Not everybody is thinking about problems and the degenerative processes. And nobody thinks, when will we face this aging processes and what we would do with that? So I believe that this movie actually motivates to continue studying brain while we are still young and capable. Maybe we can also offer some solutions how to prevent or even stop this process. Yes, indeed. Because we've been dealing with this problem quite a lot. And we do believe that one should start not when one is 60 years old. Well, actually, one can start at any age, but it's better to start when we are 40 or 50 years old, or maybe even earlier. And in connection to that, I actually have a question to a lot of people. What is the right age? Actually, you mentioned that we didn't organize any population studies in this country. And so at what age should we include the examination of degenerative processes of our population? Whether there are any preconditions for that? What do you think? Actually, as I've already said, I believe that after 50 years, one could include this study into the medical checkup. And this has been also discussed within the project with the geriatricians. We discussed these issues indeed, and we do believe that one would need to include it into the medical standard, regular medical checkup for people. And the technologies that are available today that are connected to the diagnostics, do they allow to do it today? So we just need to organize it. Or do we need any other technologies added to examine this state? Actually, you know, for screening matters, you don't need to apply a lot of efforts. If it's needed, and if it's integrated. Indeed, there is always a room for development, but at the same time, it takes from 5 to 10 minutes to understand whether a person has cognitive impairments or not. And then we can route this person and send the patient to a neurologist or to some other specialist. Thank you very much. Once again, I'd like to ask you also to answer to the questions that have been sent to our chat and to our Q&A section. We have a special button at our panel. And for all the rest, for our viewers, I'd like to conclude this session. And my colleague, Mr. Kotelevtsev, will be moderating the upcoming sessions. We will be having 2 wonderful sessions. The 3rd plenary session will be devoted to some focus areas. Irina Popova from Institute of Theoretical and Experimental Biophysics will be talking about oxidative stress associated with glucose hypometabolism as the primary triggers of sporadic neurodegeneration. This could be also an early stage of diagnostics. Then Lyudmila Yamukova from Avineri project within the CAMRAR group of companies will be talking about pharmacological treatment to prevent anxiety disorders in Alzheimer's dementia. They are one of the few people who are developing treatments and focus on that particular disease. And we do hope that they'll succeed at that. And our 2nd panel will be concluded by another overview from Bekhterev Psychoneurological Research Institute. And it'll touch upon the problems of translational research in neurosciences. And the ethical issues will also be touched upon in that presentation. This is another aspect of neurodiseases, the brain disorders, and search for some medical solutions. And the 4th session today will be organized with our foreign colleagues, international ones. It'll be no less awesome. So please stay tuned with us. Yuri Vasilievich, maybe you could introduce yourself, and then we'll have a break, and then you'll start the next session at 3 p.m. Yes, sure. I have my mic on, my camera on, right? Yes, sure. Thank you very much, Natalia. You've already introduced the next speakers. We could also be moderating all together, both of us. I believe that you'll manage. That's okay. So we don't receive any questions from our audience, right? Voiced ones. No, we don't. We just have questions in our chat. We can discuss some voiced questions if we still have time, because we have a time limit of 30 minutes for each of the presentations. Actually, now I also took a little time from our break. I wanted to discuss some organizational aspects. Okay, if I see that there are some very interesting questions in our chat and we still have time within our presentations, then I will also be able to voice them, right? Right, indeed. So we'll meet over here in 25 minutes. That's right. So see you. So once again, we are back here and we'd like to talk to Vasily Kucherov. Vasily, could you?
Очень интересно было сегодня нам интересен ваш доклад. С удовольствием.
Could you come over here?
Расширяется и так далее. А расскажите нам, пожалуйста, еще о каких-то...
Thank you so much for showing your new center.
Какие-то исследования по синхронизации мозговой активности людей, которые взаимодействуют. Это, кстати, к теме...
That was really informative, but do you perhaps have any other research results that you could share with our audience?
Меньше года назад в лабораторию социальной нейробиологии.
Okay, in December last year, we commissioned our social neurobiology lab together with Ira Janskelage, researcher. The main idea was to try and find new methods for analyzing the way we conduct experiments. I have to explain what it means because usually the way it works, the people who participate in the experiments, they sit in front of a computer and they're shown various pictures, dots, flashing colors and things like that, which is indeed a very artificial situation, far from being a realistic one. But as in reality, in everyday life, we do not perceive flashing colors or isolated words. For example, when we read the whole book, but you can't really read a book in an MRI machine. And it's far from being a trivial endeavor to see how the brain responds to books, to films, to other impressions. And we tried to implement that so that we could analyze the brain behavior when people read, when people talk to each other, when people watch films. So we take a group of 30 people watching the same film, and we try to identify the commonalities in their brain response during that film. So we are not studying them individually, we try to find correlations, and the main focus is to study the group perception of information and to go beyond the walls of our lab in this research. So we are now focusing on two things. First of all, the way the human brain responds to narratives, to long text. And the second one is the way the brain responds to films. And how can a narrative push the human brain into a risky behavior? This brings us closer to a more realistic research of the human behavior. You know, many researchers now call the Homo sapiens Homo narrators because it's all about the narrative now with the humans. So hyperscanning is one of the methods we use, but indeed we are now shifting towards studying the behavior of a group. But how do you do that in practice? You don't go to a cinema theater, right? How do you arrange that physically? Well, you know, I think that we would get more valid results if we could show a film to one group simultaneously, but for that we would need to have 30 sets of equipment. So what we do now is that we show the test video individually to a subject, we analyze what happens to the brain, and then we synchronize the results collected from 30 people. Well, people may be seated in isolated booths or in different rooms, and then we try to analyze the commonalities which we can observe in the human brain when a person is given a narrative or shown a film. There are research results from group experiments, but they require too much resources, too many resources. So we have to deal with what we have now. I want to commend you on the center that you have established with so many laboratories. I remember how it all started with a tiny lab. Then you set up this bioelectrical interface laboratory after that, and this quite an unexpected spin-off. So my question is, what do you think are the most promising areas for research? What are the labs you could establish? Maybe some of the areas require some additional attention and focus. Do you have any ambition to go into hardcore wet neurosciences, like this bioelectrical interface lab? Because this is quite a strange combination that you have. Answer. Well, there is a certain background to that. The cognitive research done abroad usually is carried out by schools, by departments, and European universities, and it's quite different from what we do in Russia. So in a European university, it will be a psychologist, most likely, who will be doing this cognitive research. So in the Western tradition, the cognitive research is under the umbrella of the psychological science, whereas in the Russian tradition, it's closer to the biological science. And there are certain pluses and minuses behind that. On the one hand, we have a huge tradition originating from Pavlov's research in the wet neurosciences, but at the same time now we have come to realize that there's more to that than biology. I remember meeting some European postgrads, and I was listening to a talk on the red color perception, and it seemed very off to me, because I didn't realize what the problem is with the red color. But now I know that this is a huge problem for the scientists. So now we're trying to add more cognitive focus to wet experiments. The minus is that we don't have any animal tests yet. When I only came to the High School of Economics, they warned me against experimenting with the children. Now it's changing over time. Now they have this new department at the HSC, and the head of our bioelectrical interface laboratory told me that, well, Vasily, I can do more than that. And that's true. That's true. His second core focus is studying brain activity. He is able to analyze neuroimaging data and analyzing this information in different contexts. And one of the applications for that research is the brain-to-computer interfaces. We met on a number of occasions. After that, we decided to collaborate in this research, which resulted in this lab. But, you know, it's involved in applied research rather than fundamental. But you know, brain activity analysis results can be used anywhere in fundamental research, in applied research as well. As to the outlook, well, you know, as many researchers, as many minds. We're still lacking the genetical capability in our research. We would like to add more biology to our markers.
Сейчас у нас готов 3-й этаж, у нас тут 4 этажа.
I think that we will be able to ramp up our center to its full capacity by December. I guess we're still working on the equipment and of the floors. Well, that's very interesting. That's very interesting. I think that you could really use a lab with apes. Well, now I understand why it's true. As Konstantin Anakhin says that, well, in China, the ape population exceeds, is much bigger than the human population. And Russia is very different. We only have a few chimpanzees out there in the south, sitting in a cage, and that's it. Well, I'm joking, of course, and there are very interesting projects, like, for example, one of our students is now traveling across Russia and is trying to identify how speech develops in humans. Vasily, thank you so much. Thank you so much for the interview, and now let us go to the exhibition. This is the neurotechnology exhibition that we have. This is, if you want to go there, just go to bcisamara.com, enter. And there you are. You're welcome to our virtual reality. First, let us go to the poster session. Let's see what's happening there. Here are the posters. You can click any of those. We have many posters published by various researchers, like, for example, this one, a wonderful post by Vladimir Nikulin from the Nikulin group on motor cortex, interhemispheric interactions somatotopy. They're sharing some preliminary results of their research. And I think that you can even talk to the researcher. Let's try and do that. Just type in your name. Alex.
Добрый день. Добрый день. Есть ли здесь кто?
Anybody here?
Видимо, здесь никого. Автор постера не сидит у нас сейчас.
Okay, it seems that the author of that poster is not present here, so we can go to another booth. But basically, this way you can study the posters and talk to your colleagues.
Вот. Постеров, как видите, у нас достаточно много. Вот. Но кроме постеров есть, естественно,
Our
еще и...
researchers have published quite many posters. Besides posters, there's also the exhibition proper.
Участники.
You can go and see the participants and maybe talk to them.
Вот, как вы помните, да, у нас есть, например, такая вещь, которая называется... Здесь можно попробовать посмотреть, то есть мы можем посмотреть видеопрезентацию выставки.
Okay, now it's started.
You can watch the video presentation in the booth. You can drop a message.
Можно открыть сайт компании.
You can visit their website.
Некоторых наших экспонентов можно посмотреть еще и презентации их.
Some of the participants have prepared their presentations. I'll try to show you how it works. Let's go here, for example.
Компания Brain, здесь есть презентация еще, да? Вот. Можно их полностью посмотреть.
Да.
И закрыть.
Что там, все нормально?
Да, все нормально, все в
Кровью как?
Да, все нормально, все в доре.
Вот у нас тут со звуком.
One of the speakers is live now. Marat Kurmyshev. Would you kindly switch off your mic, please?
Коллеги, вы здесь есть?
Maybe we can try and talk to the booth people if they are here. Are you here? Yes, we are. Okay.
Вы можете рассказать о том, что здесь происходит. Покажите нам. Расскажите.
Да, смотрите. Вы, получается...
Can you tell us about your booth? What are you showing here? Are we live on Zoom? Yes, we're live. Okay.
Это проект нейротренажер, как мы его называем, другими словами, Vibrant Rehab. Он позволяет
The
восстанавливать...
name of this project is Vibrant Rehab.
Соответственно, как вы видите на экране, мы используем виртуальную реальность, мы используем экзоскелет верхней конечности, который...
Used for restoring the mobility of the upper limbs after a stroke.
Если человек достаточно хорошо думает, рука движется в физической реальности, а в виртуальной реальности она тоже перемещается, и тем самым восстанавливаются нейронные связи, поскольку мозг обладает нейропластичностью.
The brain is a neuroplastic thing, you know, and we can use this computer simulator for triggering the proper connections between neurons in the brain, which helps to recover the mobility of the upper limbs. Yuri, can you take up from here, please?
Мне просто очень интересно, тебя так не видно здесь. Собственно, я закончил предварительную часть рассказывать о том, что мозг обладает нейропластичностью, как
I've just finished the introductory part. I told the people that the brain has such a feature as neuroplasticity. What are those balloons? So this is the virtual shooting range, and a patient is shown this simulator. The simulator is built in such a way that the direction of the virtual hand repeats the direction of the actual hand of the patient. So with this simulator, we can build new neural connections in the brain which are damaged by the stroke. This simulator was designed mainly for rehabilitation of patients who suffered stroke. So the way it is set up is that a patient goes to the virtual reality simulator. His actual hand is tied to the simulator arm, and then we analyze the signals coming from the simulator, and if a person focuses hard enough for the virtual hand will move, and the actual arm tied to a machine will move too. So this is how we trigger this neuroplasticity process. We completed the preliminary research phase, which we had to suspend, unfortunately, well, due to the same reasons why we are talking now online. But now we have a very good understanding. We have shared our results with the medical specialists, and we are now looking forward for this whole COVID thing to be over so that we could resume our research. Well, thank you so much. Now we need to go back to our plenary session. Thanks so much for sharing. Good luck with your research. So that's the way our virtual exhibition is organized. And now, in about 2 minutes, we will continue with the next plenary session, and we have prepared lots of interesting things for you. Tomorrow, we will have a workshop on neural feedback. Plus, there will be a workshop on transcranial magnet stimulation, a workshop on transcranial stimulation by direct current, a very interesting panel discussion of Elon Musk's Neuralink, plus there will be the Neurobar. And I know that yesterday they had lots of fun at the Neurobar. Jonathan was there, and he was hanging out for a few hours there. Plus, the day after tomorrow, there will be a workshop on soft skills, workshop on communications for young scientists. I will host a workshop for young medical specialists. I will share with them what they need to know about the neural scientists. Plus, there will be several open lectures by the leading world's experts. Plus a festival. Lots and lots of interesting things are in store for you in our agenda. So we have 1 minute left from the break. I think it's time to invite Yulia. Are you with us? Yuri, are you with us?
Симпозиум по PCI, по BCI Самара. Он сейчас там будет, сейчас завершилась вторая часть, но в 17:30 по Самаре. Ой, вру, не в 17:30.
Yes, I wanted to remind you about this.
Да, в 17:30 по Самаре, я не был. Начнется
BCI workshop symposium that we have in Samara. It's dedicated to brain-to-computer interface and the transmission of signals from human brain to computer. The third part of this symposium, which will start at 5:30 Samara time, will be dedicated to exoskeletons, neural implants, and the new topic for our conference as fuel cells for PCI. So it will start, the third part of that symposium, which is organized on the margins of this conference, will start at 5:30 p.m. Samara time, and it will run until 8 p.m. Samara time. At this plenary session, you will hear lots of very interesting things. Our speakers will share their insights, and we try to invite the speakers of world-class speakers to this session, like Irina Popova and Konstantin Martinyuk, plus there will be Piotr Brzezinski from France, Surya Sokada, who spoke at last year's conference, Mel Slater will talk about the analysis of brain functions with light, Sandy Chapman from the Center for Brain Health, the University of Texas. And I would strongly recommend to listen to Piotr Brzezinski's presentation, because he is going to share the approach which is a new one for Russia. We know that science is now very close to finally developing this brain-to-computer interface, and all these functions are now slowly coming to the clinical practitioners. In April this year, we had an absolutely amazing conference on optogenetics, on how retina can be restored and how the hearing can be restored using the optogenetics. So this is a tough choice for us all. Yuri, thank you so much for coming back. The floor is yours.
Третьей сессии, облегчив мне работу.
So you've already introduced all the speakers of the third session, so you simplified my work. And now we are to hear for the presentation from Irina Popova, Institute of Theoretical and Experimental Biophysics of the Russian Academy of Sciences. And she'll be talking about oxidative stress associated with glucose hypermetabolism as the primary triggers of sporadic neurodegeneration. Irina, as we said here, you are a doctor, a professor, a PhD. Yes, I'm a PhD and I'm a leading scientist. Okay, nice to meet you. So, Irina, the floor is yours. We have a large audience today, and it's a very interested one, so we are looking forward to your presentation. Thank you very much. So today, I'll be talking about oxidative stress. You've already mentioned that, so I'll just start from scratch. So neurodegenerative disorders is the group of slowly progressing, inherited or acquired sporadic nerve disorders. And they are characterized by progressive death of nerve cells, and neurological symptoms are dependent on the particular area where this neurodegeneration is taking place. Spreading forms account for 95% of the whole number of neurodegenerative pathologies, and they are the widespread causes of disability and death in the world. By different judgments, the number of people with neurodegenerative disorders will be increasing and will be doubling every 20 years. And despite the decades of fundamental and clinical trials, most, if not all, the neurodegenerative diseases are poorly studied and are not efficiently cured. In our work, we focused on studying the acquired epilepsy and Alzheimer's disease. And we are proceeding from the fact, presuming that these progressing disorders have the same paths at the initial stage of these pathologies. And in addition to that, convulsions is the widespread comorbidity of the Alzheimer's disease. And almost all the neurodegenerative diseases have common risk factors. So some of them you can see on this slide. Those are cardiovascular diseases, traumatic brain injuries, metabolic syndrome, stroke. And all these pathologies are connected to an expressive oxidative stress and hypermetabolism of glucose in the brain. And in addition to that, multiple researchers have shown that oxidative stress and hypermetabolism not only connected to neurodegeneration, but also are early biomarkers of both acquired epilepsy and of the Alzheimer's disease. So they determine the development of these diseases. And with this positron emission tomography method, we showed the disorders in the utilization of glucose. And the cause of this hypermetabolism is unknown. However, it's interesting that hypermetabolism of the glucose of the brain among the patients with mild cognitive impairments without Alzheimer's disease definitely can forecast whether these cognitive disorders will progress and reach the Alzheimer's level or not. And in addition to that, multiple research on the epilepsy models among animals also show that the decreased glucose metabolism is something that can forecast and indicate the other severe stages. So the question is brain glucose hypermetabolism a consequence or a cause of disturbances leading to the progression of neuropathology? However, to answer this question, we've developed the model of chronic inhibition of glucoses. And we inhibit glycolysis to deoxyglucose. And according to our estimations, this suppressed the glycolysis by not more than 14%. So here you can see the physical activity of hippocampus in this animal, the course over 1 month. So daily, this glycolysis blockade was inhibited, and then the rate was indicated in red. You can see it on the slide. And the whole range of parameters that were characteristics of the epileptogenesis of hippocampus were also identified. And in addition to that, some animals were diagnosed with some spontaneous convulsions at the electrophysiological level. You can see it in the black here, and also at the behavioral level. So the histological analysis also identified the epilepsy-specific changes in the brain. So we observed the death of neurons in the field CA1 of hippocampus, and also the sprouting of the mossy fibers over the dental gyrus. So this could be the trigger of epileptogenesis. Why glucose hypermetabolism initiates pathological process? Here, I believe that we need to say a couple of words about the importance of glucose metabolism in cells. It's wide known that as a result of glucose, of glycolysis, we have this fast ATP in mitochondria. The adenosine triphosphate, and this cannot be replaced by other metabolic matters. This is an exclusive one. And so here we can see the fast adenosine triphosphate evolvement during an active brain activity. Also, the glycogen is there, and this is the only source of energy in the brain. And also the efficient antioxidant defense, which should prevent the oxidative stress. Oxidative stress is a very powerful regulator when it comes to the aging and different neurological disorders. And normally, the active forms of kislorod, ROS, you can see it here on the slide in the violet. And usually we get it from a couple of sources in our brain. Most of them are subproducts of metabolic reactions, and they are offset by antioxidant systems in the cells. Normally, the cells sustain the balance between the product of ROS and their neutralizers. However, if there is any pathology, the ROS products can prevail over its neutralizers, and as a result, this could incur some stress and multiple damage of the cells. And so we expected, obviously, that antioxidants could be efficient in fighting the oxidative stress in our brain. And as a result, they could also be active while treating different neurological pathologies. However, multiple clinical trials with the use of antioxidants did not confirm their efficiency. And so we've come up with the question, why? It's logical. And when we started to see what's going on there, we've seen that there is no data in the medical works connected to the antioxidants and the oxidative stress. And to fill this gap, we used these methods to register extracell peroxide in slices of hippocampus. And this allowed us to observe dynamically the release of active oxygen forms from the inactive cells. And we've shown that antioxidant temple, you can see it over here at the bottom, in the up of the slide. And if it's concentrated highly, it reduces the release of the peroxide during the synaptic stimulation only by 20%. So these gray columns over here, this is about the time of the electrical stimulation on the referent fibers. The black line here is the control release of the peroxide, and the green line here is at the backdrop of this antioxidant. So we checked another antioxidant, apocynin, and it decreased the release of the peroxide by 50%, approximately. But what's most importantly here, when we provoked convulsions in slices, this antioxidant did not influence the release of the ROS at all. As you can see over here on this graph, the spontaneous convulsions started from a very powerful, fast release of a peroxide. And this result explains the inefficient treatment by antioxidants during clinical trials. Apparently, the therapy should be focusing not at the deleting the ROSs, but at the cause and the source of their production. So, as I've already said, most of the ROS are the byproducts of different biochemical reactions. However, there is one molecule which is known, this one, and its main function is the direct production of the ROS. This is the NADF oxidase, or we also call it NOx. And the most active one is NOx2. It consists of 7 units. They're localized in the cell membrane, and it also has a couple of subunits in cytoplasm. And in response to the activating signals, those units are aggregated in one big molecule, and they start to produce the active forms of oxygen, and they transmit the electrons from NADF to the oxygen. And the trials have shown that during a pathology, NOx2 actually stresses the cells a lot. And this molecule can be a pharmacological target for direct and efficient therapy. So, can NOx be a pharmacological target for direct and effective therapy? For this, we conducted some research based on the epilepsy models and Alzheimer's models. Our experimental methodology included electrophysiology in slices of the brain and electrophysiology in vivo in animals while they were under anesthesia and while they were just behaving freely. And we observed the changes in metabolites, such as changes in glucose. You can see it over here, represented by the red line, lactate, green, glutamate, and oxygen. And in slices, in our physiological matter solution, we have 5 mm's of glucose. In the stimulation of nerve collaterals, you can see it over here, it's indicated in the green column, results in a massive activation of neurons with intensive consumption of oxygen and release of a lactate. And that's why on the graph in here, we can see the decrease of out-cell concentration of glucose and oxygen, and we see the increase in the level of lactate. In vivo, the situation is more complex, since the activation of neurons provokes the release of substrates, submatters from arteries, and they are higher than the demand from the cells. Over here, you can see that after the synaptic stimulation, despite the high consumption by the cells, the out-cell level is rising due to the fact that it's coming from the blood. And afterwards, I'll represent you the results on the epilepsy model and then on the Alzheimer's model. In this slide, we can see epileptiform activity in slices of the brain. It was induced by epileptic gene 4AP. The electrical activity is represented by the green color, and in parallel, we registered the concentration of the peroxide in the intercell space, and it is also represented in the green here. So, an epileptic gene provoked very intensive interactile activity, and each this interactile strike was accompanied by an emission of a peroxide. Over here, you can see the induced seizure that has been provoked by an electrical stimulation. The beginning of the seizure is accompanied by an emission and release of a peroxide, and it's 10 times more than during the interactile activity. And so this fast release of the peroxide during the interactile activities was fully prevented by non-selective antagonist, NOx antagonist, celestrol. It was also controlling the release of the peroxide during a seizure, induced seizure. And what's more interesting, this inhibition of NOx resulted in full prevention of any seizures. So we can see none in here. So the activation of NOx is the trigger of the seizure activity. We also studied separately some delayed effects of this stress. And it turned out that after the full removal of 4-AP and after the stop of all seizures, still the consumption of glucose is still reduced. So after the seizure, you can see the consumption of glucose indicated in red. So we have a full cycle. Not only the hypermetabolism of glucose induces the oxidative stress, but it also works. It also works vice versa. We checked our results against the in vivo method. We have anesthetized mouses. Epileptic gene provoked these powerful seizures, and they fully were blocked by selective inhibitors NOx-GSK. And in addition to that, we also tested against other NOx inhibitors, cholesterol and others, and we got the same results. They reduced the number of seizures significantly. You can see it over here in this graph, as well as the duration of a seizure. That's how we managed to demonstrate that NOx activation is the trigger mechanism of seizure and the glucose hypermetabolism. And the NOx blockade could be an efficient method in target therapy treating epilepsy. Now I'd like to pass on to the Alzheimer's model. As I said, the early stages of the Alzheimer's disease are connected to the glucose metabolism and oxidative stress. And in a slice of hippocampus, we've shown that amyloid beta reduces brain glucose utilization via activation of NOx2. And it's quite known that amyloid beta is the direct activator of NOx. So we checked whether this selective inhibitor of NOx could prevent hypermetabolism of glucose. And it turned out that NOx inhibitor, you can see it over here in this graph, it's in blue. NOx inhibitor fully prevents the toxic effect of amyloid beta. Our results clearly demonstrate that NOx activation induced by amyloid beta is the main trigger of glucose hypermetabolism. To check our results in vivo, we injected the beta amyloids in mice in their brain ventricles. And here you can see the glucose level in black in response to the synaptic stimulation. Those vertical lines are the synaptic electrical stimulation. And as was expected, the outside level of glucose increased after an injection of amyloid beta. And it indicated the reduced consumption by the cells. However, while amyloid beta was injected against the backdrop of a NOx blocker, the glucose response and rates were at the control level, and so they indicated the full prevention of the toxic effect. That's how our data show that amyloid beta and NOx activation could be behind the glucose hypermetabolism. And it's known also that the hyperactivity could be registered at the very first and initial stages of the Alzheimer's disease. And when we inject the beta amyloid into brain verticals of mice, we can actually see what's happening. It's demonstrated in the graph. And over here, you can see the graph of the integral activity, and it demonstrates the overall level of the neural net activity in dynamics. The next question is whether the oxidative stress is responsible for neuron activity, hyperactivity, during the Alzheimer's disease. So we injected amyloid beta at the backdrop of blocking NOx. And it turned out that blocking NOx prevents the development of hyperactivity in neuron tissues that were provoked by amyloid beta. And here you can see the average graphs of the activity, 1 hour after and 48 hours after. Control is 100%. And one can see that increased electrical activity, it's over here in red, because of the amyloid beta, persists even after 48 hours. That's how we conclude that NOx activation by amyloid beta apparently also lays as the basis of hyperactivity of the network. So oxidative stress could be a general trigger for glucose hypermetabolism and for the hyperactivity. It's known that the Alzheimer's disease starts 20 years before the people actually are diagnosed with that. And in addition to amyloidosis, there are different biomarkers, and those are neuro symptoms such as apathy, depression, aggression, and anxiety. And we pay attention to the fact that our mice become quite aggressive after introducing these matters. And we wanted to understand whether NOx2 blockade could also affect the aggressive state of these mice. And for that, we introduced cannula in mice, and we separated mice to offset their social roles. We used 2 tests. So we have special obstacles as well. And here you can see the timeline of the tests. 1 week after the injection of amyloid beta and 2 weeks after that. So the mice were put in this compartment, and we recorded the number of fighting and some aggressive behaviors. And in red, you can see the group of the mice with the amyloid beta. In this group, the aggression level increased quite significantly and drastically. However, when beta amyloid was injected against the backdrop of NOx2 blockade, in that group there were no fighting at all. So the mice were quite active but not aggressive. And the second test that we conducted, those are the tests with obstacles. And it resulted in the same conclusions. Here we have 2 compartments, units, and it has a special obstacle with some holes. There is 1 mice in each of them, and the more aggressive the mice, the more contact it has with the obstacle. So it tries to establish contact with its partner across the other compartment. And with just amyloid beta, we've seen that the number of contacts with the obstacle and the duration of this contact was quite high. So it was quite different from the control ones. But when we had NOx2 blockade and amyloid beta, the indicators were very close to the control ones. And that's how we indicated that we could prevent such symptom as aggressiveness with such medication and treatment. And let me introduce the conclusions. So the oxidative stress associated with glucose hypermetabolism are likely the primary triggers of Alzheimer's disease and epilepsy. Then brain glucose hypermetabolism is induced by NOx activation. And third, inhibition of NOx may be the efficient way to prevent Alzheimer's disease and acquired epilepsy. And by this, I thank you for your attention. Thank you very much. It was a very interesting presentation. I'm not sure we have got questions from our audience, but I believe that we have some questions in our chat. So The people were joking that the mice have become aggressive after they were injected with something. It was just a joke. Okay, thank you. It was indeed very interesting. And the more I work with animals, the more I understand that it's a very time and effort consuming to perform injuries on such a great number of animals, and then to monitor them, and then to study and research them. This is just I would like to give a round of applause to all the people that are experimenting with that. And I have such a question. The GSK that you mentioned, judging from the abbreviation, I believe that it was first developed as a treatment, as a medicine, but it hasn't been turned into one. For what reason? Could you comment on that? What is this matter? And is it applied as a medication currently? It was synthesized just 10 years ago as a medication. It is not applied like this. There are some single activities when this medication is used, and we are one of them, one of the first ones into that direction. We had the molecule screening, and they could actually somehow affect the oxidase. And this molecule, that's what we learned a couple of years ago, could be used in such clinical trials. One could inject it directly into the animals. And so those studies are just starting. Should it be injected into a vein, or should it be injected into a brain ventricle? We did it into the ventricles, but the works have shown that this is also quite efficient, while we have injection through the food into the stomach, so it can also reach the brain. And the last rule, this is another kind of inhibitor, right? Yes, indeed, it's another one. It's not selective, and it is not used in animals, only in vitro. So GSK, this is specifically against NOx2, right? Yes, indeed, this is directly against, and it's blocking NOx2. And what is the biological role of NOx2? Why would one want to increase the number of peroxide in a brain? Well, in fact, those studies have just been commissioned. There are a lot of unknown things. Initially, we presumed that NOx is only in the microglia membrane, and it activates this microglia membrane. When it needs to be protected from some pathogen effects, some kind of a bacteria somewhere, or microglia just defends against it. So this is the analog of macrophagus, right? So those are the cells that protect. Right, indeed. Unfortunately, we are pressed for time. We can see the questions over here, and you can answer them afterwards. Thank you very much for your wonderful presentation. And now we move on and give the floor to our next speaker. And this will be Lyudmila Yamukova, the head of Avenero project, the Chamrar group. She'll be talking about new Russian pharmaceuticals for the treatment of prevention of anxiety disorders. So, Lyudmila, the floor is yours.
Well, thank you so much for this wonderful introduction. Let me start my screen share. Can you see the slides in your screen? Yes, it's all perfect. Great. Let me introduce myself. My name is Lyudmila Yermkova. I'm the head of the Avenero project. Avenero is part of Chamrar group. We are involved in developing novelty medications for treating neurology and psychiatry disorders. One of our advanced medications is AVN-101 for treating Alzheimer's disease and anxiety. This drug has very good properties. We are now finalizing the second phase studies. We plan to launch it to the market in 2023. Let me continue with a detailed description of this drug. It's a novel multimodal drug candidate. The molecules with a very high specificities affect adrenaline and serotonin, norepinephrine reuptake inhibitors. Here we show the NT of the drug, and it has an affinity which is much higher than its competitors. In the preclinical studies, during the proof of concept in animals, we showed very good memory recognition enhancing effect. We have completed the preclinical studies, phase 1b. We have proven the safety and pharmacokinetics of the drug, and we have published this drug in the international journals. In 2019, we completed phase 2 across the group of generalized anxiety disorder, which is a very strong disorder observed amongst 6% of the population. It's characterized by very high anxiety and some somatic manifestations. All the existing medications have lots of restrictions due to strong side effects. To assess efficacy of this drug for GAD patients, we carried out phase 2 for 2 cohorts, 40 mg a day and 60 mg a day, and assessed the efficacy based on standard scale scores. All the scores were very positive. The share of positive responders in this group was much higher than in the control group. So here we show the Hamilton Anxiety Scale improvement in control groups. The blue line is the placebo, and the black and red one show the tested AVN-101 drug. So we see that the therapy with this drug gives a very good improvement of the patient's condition after 8 weeks, dramatically reducing the anxiety. And here we show how this drug compares with the competitors. So here the improvement mean change HIS score was very, very good. And the first effects are observed in a matter of 2 first weeks, whereas for other drugs, it takes up to 4 weeks. After the 8th week, the condition of the patients continued improving. So there is no withdrawal syndrome observed for AVN-101. For all other rating scales, we also observed a very strong improvement of the patient state. For various scores like CGI-I, CGI-S, and I would like to draw your attention to the change of the Hamilton Depression Rating Score. This drug, besides not inducing any drowsiness, can reduce drowsiness among the patients. It has very low adverse events, very low number of those. The number of adverse events did not exceed that observed amongst the control group given placebo. In phase 2, the patient groups were given a dose of 40 milligrams a day. Today, we observe quite a high demand for treating Alzheimer-type dementia and the related symptoms. So here we show ADAS-Cog results, efficacy, and this is the main change in the ADAS-Cog scale from baseline to week 25. Here we compare the control group with the placebo group, and we see that the placebo patients of the period of 24 weeks suffered from the deteriorating state, whereas those patients who were given this drug have significantly improved their condition. So here we compare the results using the ADAS-Cog scale for AVN-101 and the key competitors in the market for the period from 1 to 24 weeks. For AVN-101, the difference versus placebo was 3.2, which is a very good result. Plus, we observe very good improvement of anxiety symptoms, which are quite regularly observed amongst patients with AD. So here we also see a very good improvement from the base state, from the baseline. The gray line was showing placebo, and the blue line was showing our drug. We also observed a very good improvement according to MMSE scale, which confirms our ADAS-Cog results. For the NPI scale, we have very good improvement for depression, anxiety, somnic symptoms, subscales, and AVN-101 proved to be very, very effective for treating stress disorders of relatives who are looking after patients with AD. This subscale is very important for properly comparing this drug with the competitors and the interesting fact is that there was no withdrawal syndrome. Well, unfortunately, there was some technical problem with your connection. Just we lost 1 or 2 minutes. So you mentioned that AVN, when you gave AVN 101, the overall stress condition of the carriers would improve. So we plan to start the third phase for in the nearest future, and we do hope that the third phase results would be at par with the results available so far. Thank you. Lyudmila, if you could stay with us for a while. Well, first of all, thank you so much. Thank you so much for a very interesting presentation. So, am I right in assuming that your company is involved in developing only this substance, or do you have any other substances in your portfolio? Well, this is just one of the drugs we are developing now. But what's the background behind that? We understand that there are various inhibitors, but where does the lead compound coming from? How did you come up with this idea at all? The drug was developed by a group of our researchers. After a lengthy preconceptual study, Canberra is involved in pre-screening different substances using various targets, and we saw a very good profile for the, is it an agonist or antagonist type of a drug? Targets adrenergic and serotonergic receptors. Let me say a few words about these depressants. They're called serotonin energetic depressants because they're blocking those receptors, reducing the concentration of those, and they block other receptors, thus helping us to avoid all the negative side effects typical for their competitors in the market. Unfortunately, the sound quality from the speaker is very intermittent. Well, thank you so much. Thank you so much for answering the questions. Well, unfortunately, we can't really continue this really interesting discussion. I wish you all the best with the next phase, but I do hope that you will pass it with the flying colors. Good luck. Thank you. Our next speaker, or rather speakers, are Konstantin Martinyuk and Victoria Freys from the Bechterev Psychoneurological Research Institute, who will tell us about the problematics of translational research in neurosciences. So, who will be speaking first? Konstantin or Victoria? I will be speaking.
Я уже представил вас и сказал название доклада, но вы можете...
So I've already introduced yourself and presented your topic, but you can repeat it anyways. You have 30 minutes for your presentation and for the questions. Okay, thank you. So I'm sharing my screen.
Как видно?
Да, отлично. Да.
Do you see it well? Yes, perfect. I'll make a full screen of that. Good afternoon, dear colleagues. I'd like to thank the organizers for this opportunity to present our view on the innovations in medicine. As speaking from one of the centers that is oriented at translating the science into practice, I'd like to give you a short retrospective, and I'd also like to pay attention to the experience and expertise of our colleagues that could be taken into account jointly by us while we're developing our own methods. So let's start from something positive. You've probably seen this picture from the Nature. That's how our colleagues from the National Institute of Health in the USA saw the innovations in the medicine in 2008. So this was a death valley, according to their description, because of the gap and the verge between the science and the practice. So you see the skeleton somewhere below. This should probably be the innovator. So at that point of time, the substances and molecules were under view, and we tried to take a short look of that from the right corner point of view, so to say, from the point where the doctor and the patients are located, from the clinical practice point of view. And we try to understand how we can promote the integration of innovations and how we can extend the hand to the researchers, of course, to the extent that we can actually offer according to our arm's length. The positive news is that we have some analysis because our colleagues have been in the front line of that, and they've already faced some obstacles, and we did have an opportunity to analyze them. So how did we actually come here to this kind of a life? Let's have a retrospective look. In 1950s and 60s of the previous century, as you see, the fundamental clinical trials have been quite interconnected during those times, and it changed significantly with a breakthrough in molecular biology. And on the left graph, you can see the divergence over time up to 2005, how the fundamental studies and medical studies have diverged. So the line below is the medical studies, and the line up is the scientific studies, fundamental ones. And to illustrate this gap, I'd like to offer you to take a look at the right graph. This is the pharmaceutical industry. The number of the limited studies and the new molecular entity output. What conclusion can we draw from the heritage of this past 20 years? Judging by the overview assessment, over here you can see the link to the source itself. We can see that less than 25% of the discoveries, promising discoveries in the biomech industry, are resulting from the randomized studies. And less than 10% of them are applied to real practice. So speaking very roughly and speaking about the conversion, I'd say that it would amount to 2.5% from the whole volume of the development and research. But after speaking to the accelerators that are leading in the European market in this field, we can actually feel that their interest to the project in this field starts with a level of conversion not less than 5%. What are the challenges for the century are we facing? For the first 20 years? Well, the technologies are changing, and here I'm talking about the frequency of its changes. So we have a shorter cycle now here, from 2 to 4 years. You can also see the number of medical procedures and medications, the drugs that have been registered over this period of time. And speaking globally, each 7 or 8 years, we see some breakthrough in the field of these technologies, and it determines the development of the medical science. But overall speaking, the progress is ahead of the understanding of its real efficiency of all these technologies. And we'll see it further. What are the risks that we are facing? What are the risks when we take medical science as a standard business process? Here you can see the quote by Yaroslav Shichman. He's representing the international medical cluster that is based in Moscow. And that's how he defines the maximum risk. This is about production of not those medications and drugs that are really necessary for the humanity, but of those that would be selling well. And so this will lead to the destruction of the whole model of the pharmaceutical industry. So no less, no more. Quite often we call it lost in translation term. In the pharmaceutical industry, this looks like that. More than 80% of drugs are not introduced into the market because they're too toxic or not efficient, and 50% of them are cut during the third phase. And one of these factors is the reputation, the value of those experts who perform as the chief scientists during this third phase. And they do not want to adjust the protocol to the particular drug. Now let's talk about peculiarities in the fundamental clinical trials. In our field, in the field of neurosciences and psychopathology. And here we can see the quote about real people. So the psychiatry is different from other medical areas because it's focusing not only on separate systems or within a human being, but on the whole diversity of humans in general. And if we try to understand what it actually means right now, how can we test it? We see the very high level of resistance to a therapy, despite the emergence of new medications, of new methods. To overcome this resistance, it's very difficult because there are still some group of patients that are not susceptible to this therapy, that are not responding well. And another figure that we can see here, it's quite demonstrative. This is the effect of a placebo, up to 40%. Why is it important to compare it with the placebo? If a medication or a technology provokes less side effects with a comparative clinical efficiency, and if we compare it to the medications that are currently in the market, this will influence the loyalty of the patients to this therapy. As you know, the side effects of some medications in the field of psychiatry is quite high, and when it comes to the efficiency, well, this is not that high. So the placebo is the kind of a control point for us to calculate all this. Here, let's talk about obstacles that our colleagues from Northern Western cluster and our colleagues identify those obstacles as the most significant. And here I highlighted the issues that we can influence, that we can overcome right here and right now. Those are the insufficient contacts between scientists and doctors. And the next one in blue as well, in correlation between real conditions of the clinic and the design of clinical research. For example, in a medical protocol, somebody added a patient with an arrhythmia with an implanted cardiostimulator to offset such a significant side effect as a heart stop, cardiac stop. And now let's talk about the translational medicine. So here you can see the keywords, the introduction of the most important developments into the clinical practice, etc. And also, Evgeny Vladimirovich Shlachtov advises us to follow the principles that are very important in practice. This is about the quality of research, the management, and then our constructive dialogue. Here we can see the criteria of a translational research in medicine. I believe that the most significant one here, among all of them, is the formulation of the scientific hypothesis before all the stages of the experiment, and that analysis with a check against the proof of the concept. And the next one is the economic feasibility study, together with the financial and medico-social significance. And as a conclusion, what's the difference of the scientific methodology from the translational medicine? We are oriented at result, taking into account the financial and the market factor. And the goals at the top level, I believe that we should also voice them. This is the cut of the introduction of theory into practice by 2 times. So now this period extends from 10 to 15 years, and we are aiming at the period from 5 to 7 years. Of course, we are highly dependent on the technology and the medication itself. But judging by the real data, we still believe that 15 years is a more realistic period of time. As to the regulation, here you can see the regulatory acts that determine the work in the field of translational medicine and personalized medicine. This is one of the segments where the translation aspect will be developing most actively. Now you can see that we are talking about the regulation of innovations. This is just at the top level. And there are detailed regulatory acts only across some kinds of directions, not all of them. Fortunately, I cannot be boasting with significant success in that respect, because our development, the concept on the development of centers of prevention and providing for medical health, we've slowed down a little bit. And also, together with our colleagues, we are reviewing the document on the reasonable expertise. Unfortunately, we had to issue a negative assessment because we didn't see any risk analysis over there, and we didn't see the model of management when it comes to the critical risks. But let's have a look at some kind of positive news. We have national project, healthcare, that also encompasses the federal project. This is about the development of the network of national research centers and integration of medical technologies. And here we can see a separate task, which is to include in the clinical recommendations not less than 60 new methods of prevention, diagnostics, treatment, and rehabilitation by 2025. Speaking about the innovation methods. And there's a subsequent order from the Ministry of Healthcare, the item 1, and it orders us. You can also see the keywords highlighted here. We need to increase the quality, develop innovations, and to create conditions for sustainable demand and integration of these innovations. One needs to say that the order has been executed, the center network has been deployed, and actually you can demand from any of these units within the network, you can demand the realization of your own project. However, this item hasn't been detailed when it comes to the resources and how it should also be done, actually. A little bit later, I'll also show the position of the regulator related to this issue, and just yesterday it was presented at an international conference. Now I'd like to say a couple of words about our center. The National Research Center of Psychiatry and Neurology, named after Bakhterev. So here you can see the areas. So, and we cover 40 subjects, Northern, Western, Southern one, Privolzhsky one, and Severokavkazsky Federal Region. And when it comes to the psychiatry, we actually cover all regions in the Russian Federation from 2021. And also I included our mission here, which is to improve the psychological health of our compatriots, promoting harmonization of interaction between a human being and the external environment by the use of novel scientific achievements in the field of psychological health. And here you can see the opportunities and the criteria when it comes to the translation of medical technologies with the help of our center and other centers. I believe that for you, as for the developers of interfaces, I believe that you'll be mostly interested in the testing of medical equipment and approbation of this equipment. And I'd like to separately say that the level of research can approach such levels as multicentral, randomized, and controlled ones. Also, we could develop an ethical expertise by the local committee, proceeding from the protocols, and we can also develop some clinical and economic recommendations. And on the right in here, you can see the criteria that we are currently using based on the order 433 by the Ministry of Healthcare to assess the efficiency of the technologies. This is not a full list of the criteria, of course, because in addition to the financial costs, we also assess the clinical efficiency, the security, the value of the method itself, and we also assess such aspects as the clinical and economic efficiency, as the reduction of the number of hospitalized people, the enhancement of the remission period, etc. And this could name under the umbrella title of the quality of the services rendered. Let's talk about the levels of the proof. So here we see the pyramid. And you can see the levels that are quite relevant for a scientific project or any new development. And we see that randomized controlled studies are at the highest level of the proof. And it could be principally critical for those projects that hope to go to the external markets. Initially, this export potential should be included in there, and for that, during the design of a study, those conditions should be taken into account. Maybe it's also good to pay attention to the lower level, which is about the opinion of reputable specialists proceeding from the clinical experience and descriptive studies, though this is not provable, so to say. Now let's talk about the regulator's position. This is about the ideology of the process of introduction of innovative technologies in Russia. In accordance to the Federal Law 127, we see the definition of innovation, which is the product, process, the method of sales, or an organizing method that is much better than the previous ones. What's interesting here, the regulator supports the integration, starting from the clinical approbation and ending with the group. It's indeed a very important factor when we come to the calculation of investment attractiveness of the project. But let's take a look at something that's going on before the clinical testing and approbation. So this is the picture that actually demonstrates the current state of affairs in our area. Unfortunately, I couldn't place it in a readable format, but actually we can see different colors and the thickness of these colors, and they demonstrate the reality. This is the map of the demonstrative and investment services, together with the health net. Within the National Technological Initiative, we managed to get this kind of picture accumulated. What's the most interesting for us here? Let's take a look. Above the green line, we can see all the services that were successful. And if you pay attention to the fact that after the second section here, which is called Proceed, over here in this part, there is almost nothing in here. So this gap reflects the precipice that I've shown you in the very beginning, the picture from the Nature journal. What can we see here? We can see that from the third level of technological preparedness, according to TPLL system, which is about the readiness of the project, and right up to the seventh level, we currently do not have any fitting measures and instruments to support the projects. When it comes to the acceleration, funding, investment, which would be quite relevant for medical projects, because there are huge costs that should be borne during the clinical trials. And the very first presentation to the investor is possible only at the level 8. And taking into account all this, the support from funds actually ends at the level 4. So this is approximately the middle of this picture. And here I highlighted the strategies that are available for us, also from the same biotechnological cluster, and they allow to overcome these translational barriers. This is about the validation of therapeutical targets, the comparative analysis of candidate medications, and the comparison with the best practices, identification of biomarkers, and the last one here is the assessment of potential of new developments. Those are the stages within the translational study based on the classification of National Institute of Mental Health in the US. And here I highlighted the stages during which we can be useful for you as the developers. And once again, let's take a retrospective look. Here you can see the systematic view. And this systematic view of psychopathology has been formulated not so long ago. So with what did we come to 2000s? At the conference in Dallas, it was devoted to the validity of translational psychiatric studies. Those are the conclusions that were drawn. There were some contradictory and disputable definitions of psychiatric symptoms. So people are psychosocial systems by themselves. Then there are very complex psychiatric symptoms, as I said. And for this, to overcome this, we could include into our practice the patients and those people that are taking care of them in the team of the researchers. And the last, but the most significant one here is about the significance of the psycho disease. How to overcome this? We could build some research that could be done in combination when it comes to the dependence between the target and the result. And the National Institute of Mental Health initiated a project which is called the Research Criteria in Domains. And it's actually quite similar to an approach that is used in systematic engineering. So it's a reverse engineering based on the principle as function. And here, you can see the central question. What is responsible for the development of dysregulation and dysfunction in these systems in the continuum of dementia from the norm to the pathology? And so far, we haven't come up with any clear response to that question. And within that project, we offered some metrics. In the original, they actually are called the criteria of the research area. And they'll allow to build some characteristic dynamic patterns to diagnose neurodysfunction in this range from the norm to the pathology. Here you can see the main sections of this metric. So a system of positive, valent, etc. And here, I'd like to shortly introduce the areas that, according to our view, are currently the most active ones when it comes to the introduction to the clinical and diagnostical practice. So pharmacogenomics, the vector delivery, connectomics, neuromodeling, and immersive technologies. He'll be very selective.
Вот как один из примеров трансляции.
As one of the examples of the translation, this is a medication, aducanumab. Unfortunately, all the rest of them did not reach the end of this route in marathon. Here you can see the efficiency criteria according to clinical improvements with an Alzheimer's disease. And here we can see the third phase of the trials. And we believe that the best results is the 23% in comparison to the placebo group. Those are the same results, just visualized on the graphs. When it comes to the multi-target medication, I believe that one of the most successful examples here is when we are aiming first and foremost at the security with the comparative efficiency with the medications that are already in the market and that are currently already applied. So together with our colleagues from Nchhl, this is the Center of High Technologies at ChemRAR, we signed a memorandum this year, and within this memorandum we plan to organize the third phase of our trials, because we believe that this medication is a quite interesting one. This is the same medication and its indicators when it comes to the therapy of the Alzheimer's. Nanoparticles. Here, I'd like to underline the developments of Professor Alauddin. We believe them to be promising when it comes to the search for new, efficient methods to treat Parkinson's disease and Alzheimer's disease. Those are our hopes, and we believe that those are promising for the translation. And glycosphingolipids, also for the neurodegenerative diseases. And I believe that one of the most promising areas that is relevant for you, as for the developers of neurointerfaces, this is a connectome. We do hope that with the help of this area and developing this area, we will come closer to the understanding of the connections in our neurosystem that determine our cognitive and neurophysical processes. This is an example of a neuromodeling discern project. We call it a computer schizophrenic. This is a neural network that allows you to imitate the interpretation of some stories, like a retail. Here you can see the results that have been achieved within this project. Out of 8 tested scenarios of neurodysfunctions, the scenario with the memory and hypereducativities actually were provoked among the discern participants, and they were quite similar to those that we come across in real life. And this is an example which is unfortunately proved to be lost in translation once again. This is a method that was developed to simplify the life of the schizophrenics with the hallucinations. So this is avatar therapy. This is an example of an interface. And here you can see that in 2020, an overview appeared that was demonstrating the statistical insufficient efficiency of this method. We believe this method to be quite promising. However, this efficiency didn't prove to be quite good. And quite recently, we also made an overview connected to AR and VR technologies. So we took a look at the scientific publications across different countries. What requires our attention here? This is the fact that when we have some eating disorders, we see some improvements or some remote results. Also, when it comes to phobia and anxiety disorders, there is some positive dynamics of the conditions. And when it comes to the schizophrenia, there were also some improvements in self-estimation. It was done in China and Korea. However, today we see that these technologies prove to be quite difficult when it comes to the implementation. And to conclude, I'd like to offer you a quote by Dmitry Ivanovich Mendeleev. It's quite rough. The science is for service, and this is just the mean to reach some well-being. And by this, I'd like to thank you for your attention. Konstantin, thank you very much. It was a very interesting, comprehensive presentation. It's very difficult to pick out just one element of that. At first glance, I thought that you would criticize our previous speaker, but it turned out that you also work with that, because during the previous presentation, there was a lot of praising in connection to the medication. You, however, identified that most of these medications are cut from the process during the second or the third phases. I believe that we would have a lot to discuss here, but I'd like to ask your opinion on the following. You constantly refer to methods, assessments, and protocols which are international, and it is justified because the international market of any medical treatment, medical drug, is 100 more than the national one. And so Avenira will be quite difficult when it comes to our ROI. So what is the path of a Russian medication?
I mean, Russian psychotherapeutical drugs. Well, it's clear how Novichok works and how it's delivered to the market. But as to treating the psychological disorders, psychiatric disorders, what do you think is the best route to market for them? Well, that's a great question that you have prepared for me. If we draw an analogy with those projects which we have in the pipeline for approval, most of those projects are hardware related rather than drugs, but still, from what I hear from my colleagues, especially those involved in these technologies like gamma flow oxidaser, it turns out that the best way is to go international right from the very beginning, and only after that to go back to Russia if you want to. This is the easiest and the fastest way for that. Of course, the regulator is trying to improve the competitiveness, to raise the competitiveness of our innovation environment. But you know, any legislation takes time until it's properly enforced. Unfortunately, we don't see the similar support measures which would be any close to the ones that our foreign colleagues have. Well, I absolutely agree with you. AstraZeneca has market cap of 100 billion US, which is on par with Gazprom's market cap. So if you want to develop a drug and start selling that in 15 years, which is realistic, and 5 to 7 years, which is very ambitious and optimistic, you would need comparable resources. Well, that's just the way it is. Well, in Russia, we are more about space and weaponry and things like that. As to Big Pharma, well, there's lots of questions, and I want to commend the efforts of camera. We need to develop the value in there, because healthcare is at the forefront of the technological development in the 21st century. So only by going that route we can achieve any meaningful breakthrough, including the translation technologies. But thank you so much for your presentation. Thank you for sharing lots of very interesting insights, especially with the younger audience. Thank you. Thank you so much for giving me the opportunity to speak to your audience. But really, all those questions can only be addressed in close collaboration with the large infrastructural institutions like the National Technology Initiative, which we're trying to approach, and we try to find some leads to them. And I think that your audience is involved in the kind of research we are doing now. And if necessary, if you have anything to share, you can get my details from the conference organizers, and we will try to mobilize all the resources required for developing your project. Okay, thank you so much, Konstantin. Now we're breaking until 6 p.m. Moscow time. Our next session will be delivered in English. So you see that we are reaching out to the international level. Okay, there will be interpretation for those who don't speak any English, so you'll be able to follow that even if you don't speak this wonderful language. Thank you. See you then. Okay, thank you so much for moderating, for wonderful moderation of the third plenary session. And now, during this 90-minute intermission, we would like to show a film to you. It just so happened that I was the director of this film. The film premiered a year ago at the previous DCI conference. Then it was screened in various cinemas.
Вот. Теперь мы ушли в онлайн, и сегодня мы вам покажем немножко сокращенную версию, потому что на самом деле фильм...
Now we decided to screen this video online, to stream it online. There are different versions of this film with the director's comments and without them. So you will see a slightly shortened version of this film. It will take about 64 minutes, and I do hope that this will be a very interesting experience for you. Let's roll.
2 года назад мы выпустили фильм «Мозг. Вторая вселенная». И поехали на кинофестиваль. Два года назад мы выпустили фильм «Мозг. Вторая вселенная» и поехали на кинофестиваль. Фильм был про науку и мозг, и мы решили совместить кинопоказ с небольшим исследованием.
Вот он алфавитом пошел, четко сразу, да? Это затылочный, O1, O2.
Нормально работает мозг, да?
Да. Как нужно причем.
Тут все то, что я чувствую, сразу пишется. С ума сойти.
Так.
Мы сегодня на показе нашего фильма и будем во время показа писать энцефалограммы. Вот. Какие мы из этого сделаем выводы, я пока не знаю. Спросим об этом у людей, которые в этом разбираются.
Ой, у вас что-то задымилось.
Где?
И только что вот, да, вот там, вот, да. Людей интересует вопрос управления своим мозгом, своим здоровьем и вообще своей жизнью.
А человек – это не мозг? С точки зрения нейрофизиологии, воли человека, там то, что условно называют душа, это просто функция мозга.
Конечно, мы никогда не увидим на электроэнцефалограмме, это даже звучит так немножко сухо, когда мы говорим о таких чувствах, как любовь, но чувство заинтересованности или чувство, когда собеседник смотрит сквозь тебя, да, и не воспринимает, уже даже сегодня мы ловить можем. Интересную реакцию вызвал Нчhl, это аспирант Александра Яковлевича Каплана. Он единственный из всех мужчин, на которого была реакция, вызывал значимое увеличение бета-активности. Как раз той, когда человек концентрируется на восприятии информации.
Было очень смешно, когда специалист сейчас анализировал и сказал, что и вот на вот этих словах Катерина очень внимательно слушала, наверняка она запомнит, а я все думала, о чем же он говорил, что же я навсегда запомнила.
Мы поймали, что именно он вызвал четкую реакцию на восприятие этой информации, он запомнится. Представьте, что система может адаптироваться к своему пользователю, изучая его определенное непродолжительное время, для того, чтобы впоследствии давать ему рекомендации по образу жизни, снизить активность свою стрессовую или наоборот увеличить, вовремя сделать перерыв в работе, подобрать ему интересный музыкальный лист в его плеер.
Меня не перестают удивлять технологии, способные считывать эмоции и мысли, которые мы даже не осознаем. А ведь они не просто дают информацию, они меняют нашу жизнь. Мы начали снимать кино о технологиях, с помощью которых человек расширяет границы своих возможностей, и об исследованиях, которые меняют наши представления о себе и о мире. И при этом все время появлялись вопросы: обретем ли мы с помощью них большую свободу? И куда вообще ведет нас наша эволюция?
Извините, можно задать вам пару вопросов? Здравствуйте, извините, пожалуйста, можно задать? Вот идет девушка, давай к ней подойдем с коляской. Сейчас будет странный вопрос, но как вы считаете, кто управляет вашей жизнью?
Управляет?
Да.
Я сама.
Я.
Сама. Но больше, конечно, экономика.
Сам я управляю, плюс стихии и всякие обстоятельства, которые невозможно учесть.
У меня, наверное, моя работа управляет моей жизнью.
Судьба и власть.
Я думаю, Бог. Какое-то высшее, наверное, разум. Но человек не управляет своей жизнью.
Меня зовут Катя, мне 17. Я хочу поступать на психфак.
Катя подошла к нам после одного из показов и попросила взять ее на съемки следующего фильма.
Вот, наверное, нейронауки — это то, что мне интереснее всего.
У нас есть очень интересный метод сейчас современный, он называется транскраниальная магнитная стимуляция. Эта катушка, она создает такой щелчок, сейчас включим, вот он щелчок, это как бы безопасно. В этот момент что происходит? Индуцируется магнитное поле и электрическое. В чем его фишка, почему это неинвазивная такая стимуляция хороша, что магнитное поле, оно проходит сквозь скальп, и происходит уже как раз стимуляция. Звук вот такой будет. Нормально по ощущениям?
Ну, как будто пьезозажигалка бьет.
Ну, не больно, так терпимо?
Не больно.
Хорошо. О, видели, палец дернулся? Видели? Опа,
Да,
вся рука
больше.
дернулась. Наш мозг состоит из нервных клеток, которые общаются электрическим и химическим путем. И мы можем это общение как бы либо улучшить, либо ухудшить. А вот мы исследуем этот метод и мозг.
Самое удивительное не то, что мы можем заставить человека согнуть палец или заблокировать ему речь. Нейробиологи говорят, что стимуляции, они могут повлиять на решение человека. А еще, заглянув в мозг, понять, почему человек сделал тот или иной выбор.
Экономисты, на самом деле, такие особые люди. Да, они довольно долго изучают процесс принятия решения с точки зрения каких-то оптимальных, математически выверенных решений. И с их точки зрения некоторые феномены в нашем поведении непонятны. Один из таких феноменов они же сами и нашли. Они попросили своих испытуемых играть в игру простую очень. Да? Игра называется «Игра в ультиматум».
Привет, я Оксана.
Здравствуйте, меня зовут Максим.
Очень приятно.
Играют два человека. Они не знают друг друга. Они никогда больше не увидятся. И вот первый игрок получает 1000 рублей.
В первой игре будут участвовать вот эти 10 шоколадных монеток.
Игрок номер один может поделить эти деньги в любой пропорции.
Поделить между собой и вторым участником игры.
Например, он может отдать из 1000 рублей 500 второму игроку. А может отдать 1 рубль.
Ты можешь сказать, согласен ли ты с его решением, то есть готов ли ты, что ты получишь столько монеток, или же отказаться.
Но если второй игрок отказывается, то никто не получает никаких денег.
И тогда все теряют эти монетки. Угу. Так. Скажи, пожалуйста, сколько монеток ты отдал Диме и сколько ты оставил себе?
7, мне 3 Диме.
Так, окей. Дима, скажи, пожалуйста, согласен ли ты с тем, сколько монеток ты получил?
С точки зрения экономики, рациональное решение вот в такой ситуации, да, согласиться с любой суммой, потому что иначе ты уйдешь вообще без денег. Но что оказалось? Что люди систематически отказываются от сумм меньше 30%. Да пошло все к черту, пусть никому ничего не достается. И это повергло в некоторые такой мистический ужас экономистов. Люди ведут себя нерационально. В такой ситуации я должен уйти с рублем. Отсюда появились исследования, а что же происходит в мозге.
И что происходит?
В мозге активируется определенное количество областей, да, там эмоциональные области, там, которые воспринимают иногда, например, боль или отвращение, которые активны, когда вы понюхали что-то неприятное. Вот эти же области активны, когда вам предлагают неприятную маленькую сумму денег.
Я поделил.
Ты решил оставить все 10 монеток себе, правильно?
Ну да.
Тут же журналисты раструбили на весь мир о том, что неприятные финансовые предложения пахнут плохо. Но это не совсем так, но те же области эмоционально негативно реагируют на несправедливые финансовые предложения. Также активируются другие области мозга, там, связанные с самоконтролем, лобные области. И оказалось, что мы можем с помощью магнитного стимулятора, например, повлиять на мозг. Что, влияя на мозг, вы можете заставить человека соглашаться с несправедливой суммой денег.
Спасибо.
Большинство детей в нашем эксперименте делили конфеты пополам. Как нам объяснили ученые, к 7-8 годам детям уже свойственно вести себя в соответствии с социальными нормами равенства и справедливости.
Так, ты оставила себе 4 китката, правильно? И отдала Маше 6. Так. Первый мой вопрос к Маше. Согласна ты с таким решением или же отказываешься от него? Если соглашаешься, то и у Нади остается 4 китката, у тебя 6 киткатов. Если отказываешься, то все теряют эти киткаты, они не достаются никому. Если это трудное решение, то скажи почему. То есть, например, почему ты сомневаешься?
Вот это серьезно сложно решить, потому что у меня как бы больше, а у нее меньше. Это несправедливо вообще.
Выбор у тебя, к сожалению, как бы пока только один. То есть либо согласиться, либо отказаться.
Наверное, отказаться все-таки.
Нам одинаково неприятно, когда дисбаланс идет как в нашу сторону, то есть когда мы видим, что у другого больше, чем у нас, так и в сторону другого человека, то когда мы видим, что мы обладаем большим бюджетом, чем другой.
И все наши концепции о том, почему человек реагирует на несправедливость, вдруг превращаются в нейробиологические концепции. Мозг сформировался так в ходе эволюции, что он не принимает несправедливые предложения. Можно, более того, обнаружить реакцию на неравенство и несправедливость у обезьян.
Это то, что меня в свое время потрясло. Да, есть такой фантастический исследователь Франц де Вааль, и в их лаборатории было проведено очень интересное исследование с капуцинами. Эксперимент очень простой. Капуцинов очень легко научить пользоваться деньгами. Но в их случае это маленькие пластиковые жетоны обычно. Они, в принципе, понимают то, что на этот жетон можно обменять что-нибудь. На что было любопытно, если капуцин дает свою монету и получает за нее кусочек огурца. Это здорово, мы там любим огурцы. Капуцин обычно с удовольствием ест этот огурец. Но если рядом в соседней клетке сидит другой капуцин, и наш капуцин видит, как он за свою монету получает виноград, то возникает ситуация несправедливости. Если я еще раз дам свою монету и получу огурец, а рядом этот мерзавец получает виноград, это несправедливо. Капуцин реагирует эмоционально. Да? Он запускает куском огурца в экспериментатор. Да, начинает трясти клетку. И вообще, это мои любимые исследования, где просто по физиономии капуцина все видно, да, что это все несправедливо. Все мерзавцы, подлецы.
Капуцинов мы нашли в московском зоопарке, но оказалось, что извлекать из вольеров их нельзя. После долгих поисков в Москве подходящих обезьян в Росгосцирке мы нашли макак. Мы попросили дрессировщиков с помощью неравного распределения фруктов вызвать у обезьян чувство несправедливости.
Смотри, сколько всякой ерунды есть, да, тебе только вот, да, поцеловаться, полизаться.
Цирковые макаки оказались очень избалованы едой и ворочали нос от мандаринов и бананов.
Вот это будешь?
Нет, Тём, никакой любви, нет.
Держи.
Ну, за ручку подержаться, да.
Давай.
Вот.
Дрессировщикам пришлось выложить последний козырь.
Конфетка всегда заходит хорошо. Смотри, Семен, смотри, я даю конфетку этому Монечке. А тебе даю капусту. Скажи, капуста, да, Семен? А у меня, скажи, я и полифантик лизать буду. Смотри, даем Манюньке конфетку чудесную. А тебе капусту опять. Ну, так нервничает, да, значит, психует все-таки, да, не согласен он. Семен, злится. Держи капусту. Не хочешь капусту, да? Но вот это вот так он выражает, в принципе, то, что ему не нравится. Да, Монечка, а тебе про эксперимент скажи, неплохой скажи, да, Монечка? Держи. Ой, как Монечка. Держи еще капусту. Смотри. Как вкусно. Не злись, это эксперимент научный, Семен.
Трудно сказать, связана реакция Семена на капусту с тем, что он видел, что другая обезьяна по-прежнему получает конфеты, или ему противна сама капуста. Но он явно был возмущен несправедливым предложением. Чем больше ученые изучают человека, тем больше находят биологических механизмов, от которых зависит наше поведение. Удивительно, когда у нас находится что-то общее не только с обезьянами, но и, например, с птицами.
Великий ученый Тинберген изучал поведение птенцов серебристой чайки. Прилетает чайка, птенец открывает рот. Почему он открывает рот при виде чайки? Показываем мертвую чайку, открывает рот. Показываем клюв чайки, открывают рот. Методом разных экспериментов пришли к тому, что красное пятнышко на продолговатом предмете – это и есть стимул. Если взять чайку и закрасить ей, живая вполне чайка, но закрасить ей клюв, и он перестанет быть красным, птенцы рот не открывают. Если оставить только красное пятно на продолговатом предмете, на карандаше, рот открывают. В ходе экспериментов выяснилось, что если на клюве 3 красные полоски, то птенцы открывали рот уж очень сильно. И вот эту вещь назвали сверхстимулом. Сверхстимулы находят у очень многих животных по самым разным поводам. Мы существа сложные, все зависит от культуры, образования, воспитания. Но глобально, да, мужчины обращают внимание, например, на женскую грудь. Это стимул. Но реклама, она вся такая сверхстимульная. Можно сказать, что реклама идеальна.
Смотрите, Александр, смысл эксперимента заключается в том, что вам будут показаны картинки, вы увидите фотографии моделей на пляже. Ваша задача будет описать фотомодель, там нравится, не нравится, какого цвета у нее купальник, ну просто там рассмотреть картинку. Как только закончили описание, нажимайте пробел. Хорошо?
Давайте. Так, ну, вижу девушку-брюнетка с большой грудью. Находится на песке, справа от нее еще змея.
Тут есть модель, у нее сережки, оранжевая майка, черные волосы, море, завален горизонт, змея, снова купальник, только он синий, у нее зеленые тени, море, скала, каракатица, вот там в углу.
Так, девушка, блондинка, значит, находится на каком-то утесе. Ну, вот справа еще какой-то паук или тарантул. Ну, такое впечатление, что он искусственно там как-то изображение добавили.
Так, сейчас мы посмотрим, что там насмотрели у нас. Вот нам присылается сообщение, что появилась картинка. Сразу на лицо. Человек смотрит, да, в первую очередь на лицо. Первая дефиксация у нас лицо. И потом через 2 секунды на змею посмотрел. Змею, затем на вот этот черный камень. Потом снова на лицо, лицо. И вот и только на 5,5 секунд спустя на грудь.
Змея выиграла.
Да, змея выиграла, вот получается. Так вот опять же центральная фиксация, у нас вот появляется картинка, и первая фиксация тоже на лицо. Ну вот здесь через 2,5 секунды прямо фиксация на груди была. Катя у нас в основном смотрела только на лицо, на волосы, на грудь, на каракатицу. Александра привлекала больше модель, а Катя раньше заметила паука, потому что модель для нее не так привлекательна, как для Александры.
Кажется, мы даже не подозреваем, какая борьба идет за наше внимание, и не догадываемся, как легко наше внимание привлечь, отвлечь и даже обмануть.
Что такое иллюзия? Это когда мы какой-то признак объекта видим неправильно. Да? Например, что происходит с квадратиком? Да, он как-то непривычно ерзает. На самом деле это PDF, он ерзать не может, картинка абсолютно статичная. Любая иллюзия, которую бы мы ни взяли, это отражение каких-то механизмов работы нашего восприятия, каких-то механизмов работы нашей психики, которые складывались в эволюции. Да? И если мы обнаружили что-то, что мы воспринимаем не так, значит, нам это зачем-нибудь нужно. Ну, например, более или менее эволюционно понятно, зачем мы неподвижный объект можем воспринять как движущийся, да? Потому что если мы примем, допустим, палку за змею, наши шансы выжить высоки. Да? Мы отскочим, да, она нам и так не угрожала, но мы в безопасности. Вот если мы примем змею за палку, то тут все хуже. Да? Наши шансы выжить и передать гены потомству уже понижаются.
Я хочу показать один интересный феномен, связанный с восприятием лиц. Я буду показывать 2 картинки, и вам просто нужно будет выбирать то лицо, которое кажется вам более привлекательным. Почему ее выбрали?
Ну, у нее больше лицо такое русское.
Хорошо. Почему его выбрали?
Симпатичнее.
Почему ее выбрали?
Ну, как-то милее показалось.
Справа. Почему вы выбрали? Мне показалась она более... Не знаю, просто так. Показалась более привлекательная по сравнению с той, которая была.
Ну, улыбается.
Наверное, симметрия лица.
Почему я выбрал?
Да, слушайте, даже вот тяжело это объяснить, честно говоря. Ну, не знаю, просто приятное лицо.
Хорошо. Последняя пара, между которыми вы выбирали, вот так выглядит. Вот так. Вот. Из них 2 вы выбрали вот эту фотографию. Вот. Когда я попросил вас объяснять, вы объясняли вот эту фотографию. То есть ту, которую вы не выбирали. Не заметили.
Ну, я что-то подумал, что что-то вроде не то, но...
Ну, будем считать, что я обманул.
Ну, да.
Хорошо. В общем, этот феномен называется слепота при выборе. Вот, и он призван разрушить миф о том, что мы все видим, все замечаем, все детали, да, и все хорошо запоминаем, очень легко, даже в такой серьезной ситуации, подловить вас, да, и заставить объяснить тот выбор, который вы не совершали.
Вот это.
Почему ее выбрали?
Даже не знаю, честно говоря. Ну, просто как-то вот по ощущениям.
Не знаю, я сейчас смотрю больше как стилист, и здесь для меня какой-то хотя бы есть образ, там более какой-то неряшливый.
Вы типа постеснялись сказать что-то, или вы действительно не заметили, что это?
Нет, я не заметил, я максимально честен был.
Спасибо, что вы тоже подловились, очень нравится.
Я сам обманываться рад.
На самом деле, вот все эти многочисленные феномены слепоты, да, это издержки, в общем-то, успешной эволюции вида человека. Мы попались в ловушку схематичности нашего собственного восприятия. Ведь именно схематичность восприятия нас спасает, когда у нас мало времени для принятия решения, для быстрого выбора, а что делать. Или там в ситуации, опять же, биологического выживания, куда бежать и как спасаться. Эта информация не нужна. Да, есть ситуации, где именно она может оказаться значимой, где цена ошибки слишком высока. Да? Когда, например, водитель мчится на достаточно большой скорости по дороге, появляется пешеход, водитель не успевает, не ожидая этого пешехода, нажать на тормоз. Но опять же, посмотрим на это в перспективе биологической эволюции, когда человек перемещался вообще в этой эволюции со скоростью 60 или 160 километров в час. Да вот совсем недавно начал. И, естественно, наша когнитивная система к таким ситуациям не приспособлена.
Я помню вот у Ванигута, знаете, Ванигута, конечно, да, Курт Ванигут. У него была такая книжка, так сказать, очень давнишняя, назывался «Завтрак для чемпиона». Не читали? «Завтрак для чемпиона». Про некого сумасшедшего писателя. В одном из рассказов этого писателя сумасшедшего утверждается, что все люди контролируемы, что на самом деле существует какой-то, так сказать, суперразум, и он контролирует поведение людей. Иногда человеку делает возможность проявить свободу воли. Его вырывают из общественности, помещают на какую-то там отдаленную планету, и там он ведет себя как хочет. И вот там описывается, как ведут себя люди. Они совершают исключительно бессмысленные поступки. Кто-то там, например, забирается на гору, на гору, и оттуда кричит рекламу сыра, кто-то там еще что-нибудь. Как только, так сказать, вот снялся контроль сознания или контроль вот этой области, о которой я говорил, вот полностью проросла. Вот свобода воли, так сказать, она приводит либо к бессмысленным, либо к антисоциальным поступкам. То есть кто-то кого-то убивает, сплошные драки, так сказать, там, люди на самом деле это такие довольно агрессивные приматы. И это значит, что на самом деле, так сказать, что бы мы ни сделали, это была не ошибка, это был некоторый, так сказать, единственный выбор наш. Ошибку совершить невозможно, понимаете? То есть, когда ты совершил ошибку, ты не ты в этом виноват, так сказать. Виновата область мозга, которая тебя контролировала, а в этот момент ослабла. Понимаете?
Ну, не знаю. Так о чем Кучерёв ты говорил?
Сегодня, к сожалению, да, мы знаем там какой-то очень крохотный процент о том, как работает мозг. Но то, что мы понимаем, нейробиология вторгается в какие-то общие представления на культурном уровне. да, и запускает иногда неожиданные дискуссии. Например, то, что я люблю обсуждать со своими студентами, это подход к личной ответственности и свободе. Если мы действительно можем экспериментально предсказать поведение человека по активности мозга, манипулируя активностью мозга, помимо его сознания, да, повлиять на его решения, это на самом деле приводит к вопросу, а кто ответственен за те или иные наши поступки? Насколько мы вообще способны контролировать свои поступки?
Philosopher Daniel Raziev. Daniel is the best expert in freedom and free will.
Thank you so much, Vasily, for this invitation. The general question is, do we have free will and why should we care? The scientists were interested in the relationship between electrical activity in the brain and voluntary movements. What they found was that there was a reliable patterns of electrical activity in the motor area of the brain that preceded the electrical activity in the muscles. So technically it is called readiness potential. The time when the brain is getting ready to produce motor behavior. Neuroscientist Benjamin Libet used those results in order to explore the problem of free will.
Собственно говоря, вся суть эксперимента Либета заключается в чем? В том, что человек совершает движение, и он думает, что он совершает его в данный момент времени, вот сейчас. И то, что им удалось показать в 1983 году, что, собственно говоря, если мы одновременно регистрируем электрическую активность мозга, то у нас потенциал начинает активироваться, уходить вниз за 300-500 миллисекунд до того, как испытуемый сам считает, что он принял решение о выполнении движения. Таким образом, это свидетельствует о чем? Это свидетельствует о том, что не ты в каком-то смысле принимаешь решение о том, когда делать, а это решение уже формируется подсознательно, вне зависимости от тебя, а ты его потом уже как бы воспринимаешь. Собственно говоря, в этом весь сыр-бор в парадигме Либета, что решение возникает раньше, чем вы считаете, вы его приняли.
Мой мозг что-то решил, и мое тело это решение, грубо говоря, воплотило в действительность. Зачем же здесь нужна свобода воли?
Значит, Катя, сейчас я вам объясню требования эксперимента. Как вы видите, здесь на этом циферблате бегает точка. Теперь положите, пожалуйста, вашу правую руку на клавиатуру. И теперь примерно один раз в 4 или 7 секунд нажимайте на эту кнопку. И важное условие, смотрите, когда вы почувствуете, что вы хотите нажать на кнопку, то есть вы уже приняли решение о том, что вы сейчас на нее нажмете, запомните положение черной вот этой вот точки на циферблате. Запомните положение этой черной точки и нажмите на кнопку. Только после того, как вы нажали, назовите мне ту цифру, на которой была черная точка.
10, 35, 20.
Мозг – это физический объект. Его конкретные разряды мозга предсказывают то или иное решение. Да, если вы придете в лабораторию, я могу заставить ваш палец двинуться. Да, вот эта активность мозга предсказывает это движение. Да? Это имеет прямое отношение к такому биологическому нейродетерминизму. Да? Вы вряд ли осознаете состояние своего мозга полчаса назад. Но это состояние предсказывало, как вы себя поведете в дальнейшем.
Ну вот смотрите, Юль, мы сейчас провели с вами эксперимент. Нажатие кнопки мы можем зарегистрировать. Это вот момент времени 0. Тот момент, когда она считает, что она точно приняла решение о нажатии на кнопку, обозначен здесь красной линией. Но активность мозга, приводящая к движению, начинается гораздо раньше, чем мы, собственно говоря, приняли решение о нажатии. Хотя Либец в своей статье был очень аккуратен в интерпретациях, но тем не менее большинство нейроученых, психологов и философов, естественно, стали рассуждать о том, что, возможно, это может являться экспериментальным доказательством того, что у людей нет свободы выбора, свободы воли. Что на самом деле мы лишь осознаем постфактум некоторые решения, которые были приняты нашим мозгом до этого.
Я исхожу из определения там философов, да, свобода выбора, что значит означает свобода? Свобода воли или свобода выбора? Возможность поступить иначе. Возможности поступить иначе нет.
Как это нет?
Ну, как Лютер говорил, да, когда он сражался со своими врагами, он сказал, я стою здесь и не могу поступить иначе. Да, он говорит, он стоит, он говорит, верит. Вы, ребята, что хотите со мной делаете? Это не мое решение. Да, это Бог так решил. И это в каком-то смысле транслируется в этот научный детерминизм, который говорит, я стою здесь перед вами, потому что не могу поступить иначе. Мой мозг не может поступить иначе. Встает адвокат и говорит, смотрите, моего подзащитного, обратите внимание, там такая-то область, вот как истончена. Смотрите его мозг, он не может себя контролировать. И вы найдете ситуации, когда сроки уменьшаются. Есть прецеденты, когда адвокат ссылается на структуру мозга своего подзащитного. Теоретически вы можете сказать, но если это его мозг, если он помимо сознания принимает это решение, если все формируется там, тысячу причин, его генами, гормонами, вот такой структурой его мозга, причем здесь он?
Если я не отвечаю за тот выбор, который я делаю в осуществлении того или иного поступка, то мне нельзя приписать ответственность за этот поступок. Об этом идет речь. Понимаете? Если я достал кинжал и вонзил его в бьющееся сердце режиссера кинофильма, то мне ничего не должно быть за это, если мы живем в полностью детерминированном мире. И все было определено во время Большого взрыва и примордиального супа после этого. Понимаете? Ведь все частицы тогда сформировались.
Вот тот факт того, что именно вот эта камера сейчас направлена вот так, этот микрофон вот так находится. Вы сидите напротив меня в этой черной кожаной куртке, а я сижу с этим, к сожалению, сейчас немного остывшим кофе. Это на самом деле все было предопределено.
И это некоторая иллюзия, что могло быть иначе. Ну, то есть для меня это скорее такая физическая метафора, да, вот этот мозг обезьяны, он не мог не развиться, мозг человека.
В каком-то смысле сам человек остановил свою эволюцию. Просто потому, что он стал разумным, и уже он мог менять природу под себя. Чтобы адаптироваться к холоду, ну хорошо, придумаем теплое жилище. И не нужно наращивать шерсть на тело, чтобы спасаться от холода. Надо приспосабливать природу так, чтобы было комфортно себе.
Вот это как раз очень важный момент, да? Человек интересен тем, в отличие от любой зверушки, что он все время меняет свою среду, он все время развивает свою среду, да, и где-то вынужден бежать за ней, прям как за паровозом.
Санкт-Петербургский университет. Мы приехали сюда, чтобы посмотреть созданный 4 года назад Институт трансляционной биомедицины.
Приветствую. Я Данил Разиев, профессор философии. Да.
Очень приятно. Очень приятно. Рауль Генединов, директор Института трансляционной
Очень приятно, да.
У нас трансгенные модели разных заболеваний мозга, и мы на животных воспроизводим какие-то патологические процессы, изучаем.
У нас как раз сейчас грант РНФ по свободе воли, по волевые акты, причем мы смотрим в том числе, да, в том числе и нейробиологические модели.
У меня есть животные, у которых выключен дофаминовый транспортер, у которых много дофамина, скажем так. То есть они гиперактивные, бешеные. Вот как раз у них совершенно точно decision making изменен. Совершенно точно.
Вот
уникальные трансгенные крысы есть. Вон там сидят.
Да, я приду посмотреть на этих крыс.
Да, это там что-то можно такое интересное сотворить на самом деле. Нокаут — это метод вышибания гена, поэтому назвали нокаут. Мы можем вышибить его, сделать нокаут, убрать полностью. Мы можем уменьшить функцию на 95%. Мы можем увеличить функцию гена в 3-4 раза. Наоборот, усилить экспрессию какого-то белка, повысить экспрессию в 3-4, вплоть до 20 раз. Можем выключить ген только, допустим, в нервной ткани, оставив его по всему телу интактным. Можно сделать так, что животное рождается нормальным, а в какой-то период времени все выключается. Вот сейчас появился подход CRISPR-Cas. Это какие-то молекулярные ножницы, которые позволяют отрезать в гене определенный кусочек. Вот мы взяли и убрали дофаминовый транспортер. Много дофамина, гиперактивация у них. И вот, допустим, когда скринингуют и проводится скрининг на новые антипсихотические средства, как делают это на животных? Дают им прежде всего амфетамин, у них повышается дофамин, гиперактивный, и антипсихотик просто их успокаивает, к примеру.
Гиперактивным животным ввели вещество, которое временно заблокировало синтез нового дофамина. В итоге у них часов на 16 развился паркинсонизм. Теперь на них можно испытывать лекарства от болезни Паркинсона.
Мы сначала пытаемся найти патологический механизм на человеке, естественно. Допустим, взяли анализы, нашли там изменение активности какого-то фермента. Потом изменили тот же самый фермент на мышке, посмотрели, что меняется, нашли быстренько новый подход лечения, коррекция этого изменения. И разработали лекарства и вернулись обратно. Сейчас, если я не ошибаюсь, 30 миллионов человек во всем мире страдает от деменции, разных видов деменции. Самая известная форма – это болезнь Альцгеймера. Ожидается, что уже к 35-му будет 50 миллионов, по-моему, к 50-му 70 миллионов. Продолжительность жизни растет. И многие люди стали доживать до нейродегенеративных заболеваний. Паркинсонизм. Огромное количество больных. И, к сожалению, лечения вот такого серьезного как не было, так и нет. Теорий огромное количество, но так и не знают, почему вдруг в какой-то момент нейроны начинают погибать и как это остановить. Кардиологи, они там за последние 30 лет смертность уменьшилась в 2 раза. Онкологов за последние 20 лет 25% снижения смертности. А у нас только все хуже становится в нашей области. И вот эта эволюция, я несколько более, я уж смогу так сказать, от себя. У меня просто и отец, и мама недавно ушли через деменцию. Это, может, персональное такое мнение, но было тяжело это все видеть, тем более я этим занимаюсь. Поэтому тут у нас, я несколько более пессимистично на все это смотрю.
Мы после инсульта очень часто имеем пациентов, которые не могут говорить. Как им получить контакт с внешней реальностью, если они сохранны в когнитивном отношении? То есть они все видят, слышат, они анализируют, но двигательная система не работает. Двигательная система распространяется не только на мышцы рук, но и на голосовые связки. И вот здесь мы действительно можем помочь таким людям, и мы сейчас делаем такую технологию, она называется нейрокоммуникатор.
Нейрокоммуникатор сделан на основе интерфейса мозг-компьютер. В последние десятилетия мы столкнулись с бумом нейроинтерфейсных технологий. Они считывают электрическую активность мозга и передают ее на внешнее устройство. Вот, например, соревнования, кто быстрее долетит до финиша. Космическими кораблями управляют мысленно, через нейроинтерфейс.
Видите, вот сегодня представляем мы на выставке так называемые коммуникационные нейроинтерфейсы. Их идея проста. Видите, на экране подмигивают столбцы и строки букв. Если человек заинтересован в какой-то букве, там в красном квадратике, то реакция на эту букву, на подсветку этого столбца или строки будет несколько иная. Мы сразу догадываемся, какая буква, и печатаем ее на экране, получается такая печать.
С самого начала, после комы, то есть было неизвестно, сохранен интеллект, не сохранен. То есть когда поняли, что сохранен интеллект, нужно было как-то общаться, потому что ребенок не говорил. Условно разбили русский алфавит на две части. До, К и после К. То есть общаемся посредством моргания глаз. Потому что до, если она моргает, значит до. Значит буква от А до Й. Если она не моргает, значит после. Я начинаю называть А, Б, В, Г. То есть она моргает какая буква. Это картина работы маслом, да, Маша? Акварелью? Чем? Акварелью работа? Маслом? Нет, не маслом. Гуашью? Не будешь говорить? Нет, она стесняется. До, А, Б, В, Г, Д, Е, Ё, Ж, З. Раз. Какая разница?
Последний наш проект — обеспечить вход в интернет и даже, так сказать, сделать такую социальную сеть специально под таких пациентов с интерфейсом, который обеспечивает им более легкое вхождение в контакт, не так, как для здоровых людей. И получается, что человек получает фактически вторую жизнь в мире людей, объединенных одной и той же бедой, но теперь они могут друг с другом общаться, но, естественно, в эту сеть могут подключаться все, кто хочет общаться с этими людьми. Для таких людей это выход в новую реальность.
Иногда говорят, ученый, он занимается чистой наукой, кому это нужно? Но уже давно известно, что нет ничего более практического, чем фундаментальные исследования. Я не должен какой-то эксперимент на обезьянах, тут же бежать и добиваться того, чтобы это было реализовано в клинике. Мне достаточно опубликовать эту статью, она будет прочитана другими, они воспримут эти идеи, и дальше пойдет развитие.
Девушке в течение длительного периода при помощи таблетированных препаратов не удается снизить, купировать количество эпизодов судорог. И, соответственно, для того, чтобы существенно изменить жизнь, как раз ей были поставлены электроды для выявления, определения эпилептогенного очага, то есть очага, откуда исходит сигнал. Если удастся быстро и точно определить очаг эпилептогенный, то буквально, может быть, даже на следующие сутки, через 2 суток эти электроды удаляются, потому что они свою функцию выполнили. После того, как это все будет выполнено, то уже будет разработана тактика, в том числе хирургического лечения.
Поскольку сетка она стоит, то мы можем попросить этих же пациентов поучаствовать в наших экспериментах.
Поднимите ручку вот немножко так, чтобы было, да, вот, и пошевелите пальцами. То есть вот мы можем регистрировать непосредственно движение руки, и сопоставляя с этим движением руки активность головного мозга, мы можем строить математический алгоритм, который превращает активность головного мозга в траектории движения пальцев. Мы можем, после того, как мы обучили наш математический алгоритм, мы можем на основе одной только активности головного мозга восстановить движение руки. Те данные, которые мы получили от вас вчера в рамках вот этой задачи картирования, мы используем для разработки технологии построения протезов будущего.
Нейроатлон – это соревнование между людьми с инвалидностью, где они демонстрируют возможности современных технологий. Мне было 18 лет, я играл в ночные игры, ветки «Дозор». Это когда люди лазят по всяким заброшенным объектам, высматривают надписи. Схватился за провод, электрический удар в 10 тысяч вольт, это безумно много. Врачи очень, на самом деле, удивлялись, что, в принципе, остался живой. Вот. Через некоторое время я стал с ними соглашаться. Мне намного проще пользоваться и делать что-то протезом, чем человеку, у которого есть протез, есть здоровая рука. Такой человек в обычной жизни будет большую часть работы делать здоровой рукой. У меня же нет вариантов. Мне нужно работать с компьютером, мне нужно себе есть приготовить, мне нужно документы подписать, в командировку куда-то съездить. И все вещи, как крупные, так и мелкие, я делаю вот этой рукой, вот этим протезом.
Алексей справляется с задачей, и он открывает дверь. Неужели уже есть победитель?
Сложно было приучиться не акцентировать на этом свое внимание. То есть делать это чисто автоматически. Ну вот вы, когда же берете стакан, вы не думаете о том, что рука, возьми стакан, нужно, чтобы вот эта мышца напряглась. Нет. Все происходит автоматически совершенно.
Почему мы чувствуем, что наши руки – это наши руки? Потому что мы получаем от них обратную связь все время. То есть вы закрыли глаза, вы все равно знаете, что вы делаете своей рукой. И вот эта информация, обратная связь от ваших органов чувств, это то, что дает вам ощущение, что это ваши органы, ваши руки, ваши ноги. Ну вот, и поэтому добавление вот такой обратной связи к протезам – это очень важные компоненты. И вот наши исследования как раз направлены на создание таких двунаправленных интерфейсов. То есть, с одной стороны, мы информацию из головного мозга превращаем в кинематику движения этого протеза, а с другой стороны мы информацию о состоянии этого протеза, о том, какую поверхность он трогает, да, и так далее, мы отправляем обратно в мозг.
Вот это мозг обезьяны. Допустим, мы поместили электроды в моторную кору М1 и записываем активность, и затем через мозг-компьютер-интерфейс направляем сигнал на механическую руку, и она послушно следует указаниям мозга и берет объект. Но при этом человек не чувствует этот объект. Поэтому нам необходимо добавить к этой механической руке искусственное чувство осязания. Значит, мы подаем такие вспышки разрядов в саму сенсорную кору. Мы берем сигналы из мозга, этими сигналами обезьяны управляют искусственной рукой, и при этом она еще ощупывает предметы, которые зрительно выглядят совершенно одинаково, но за счет искусственного тактильного ощущения обезьяна может распознавать их текстуру. Обезьяна охотно сидит и управляет по двум причинам. Первое, что мы ей даем за каждую успешную попытку сок. А второе, что, в общем-то, ей это даже интересно. То есть обезьяны, как и мы, их интересуют какие-то достижения.
Когда ты открываешь учебник Ивана Петровича Павлова, волосы дыбом достают. Что он там писал, какие эксперименты он проводил, сейчас это невозможно проводить. Наше этическое представление о сходстве, да, вот, с другими животными, оно влияет на все, да. Может быть, в какой-то момент повлияет и на прогресс науки. Потому что мы сейчас не можем так быстро делать те исследования, которые делали раньше. Сама наука находится под влиянием наших самих своих открытий.
Вас интересует, существует ли душа?
Меня?
Да.
Нет, это не об этом, наверное.
Но вас интересует этот вопрос?
Не, меня интересует. Меня интересует.
Вот. Нет, нас, мы признаемся, в принципе, этот вопрос интересует. Но, как бы, мы не, в этих, так сказать, схоластических рассуждениях, я или мы, не видим решения этого вопроса, потому что сколько бы мы ни изучали мозг, ничего, кроме материалистических эффектов, мы не найдем.
Вот это представление о конечности знания, оно ложное. То есть мы будем дальше погружаться и узнавать. Ведь мозг – это такая сложная штука. Ну, это, представьте, миллиарды нейронов. Сотни нейропередатчиков, все перепутано. Там вы меняете одну часть, вылезает совершенно где-то в другой части мозга. И все это настолько сложно, что я не вижу конца процессу изучения мозга особенно. Это представление о том, что можно будет что-то определенно сказать через 20 лет, там, через 30 лет, как это функционирует, что, допустим, тот же самый вживленный электрод решит какую-то большую проблему, я не верю.
Одни ученые выдвигают гипотезы, проводят эксперименты и делают выводы. Другие эти выводы ставят под сомнение, придумывают новые эксперименты. Так развивается наука. Вот и с экспериментом Либбита. На протяжении всех съемок мы искали аргументы в пользу того, что мы свободны. Сталкивались с критикой эксперимента и совершенно разными точками зрения.
Ну, например, смотрите, что не очевидно, но происходило с Катериной. Она сидела и отслеживала возникновение внутреннего импульса нажать на кнопку. Ожидание чего-либо приводит к потенциалам, очень похожим на потенциал готовности. Таким образом, возможно, это не начало принятия решения, а это лишь мое ожидание того, а когда же я нажму на кнопку.
Есть такая штука, как обратная перспектива. Обратная перспектива сна, например. Вы спите, вам что-то снится, окей? Это что-то не имеет никакого отношения к той реальности, в которой вы сейчас находитесь. Вам в дверь стучат или звенит будильник, и потом, когда вы проснулись, вам кажется, что звонил кто... Ну, вы вписываете это якобы в тот сон, который вам снился, что кто-то пришел и позвонил в дверь, например, во входную, ну, неважно, или там, я не знаю, ну, все что угодно, да, или там на соседнем там столике зазвенел телефон у кого-то, да, это вот этот будильник ваш, да, вот. На самом деле это то, что ваш мозг достроил постфактум. Поэтому вы вообще никогда не можете сказать о каузальности, вы осознанно вообще никогда не можете сделать никакого вывода. Вообще, потому что это все внутри вас. Понимаете? Вы не можете сказать, что А произошло перед Б, потому что оно могло произойти когда угодно, а как вы это восприняли, как сложилось. А когда у вас бывает, когда компаратор глючит, когда есть это дежавю знаменитое, я где-то это видел. Ну, блин, понятно, что ты это нигде не видел. Понятно, что у тебя оно глючит сейчас, и тебе кажется, что ты это видел. И вот это вот кажется, это, мне кажется, является абсолютно ну, не знаю, чуть ли не одних из основных свойств мозга, потому что все, что происходит, это ему кажется так.
Я думаю, что свобода воли начинается с контроля, с самоконтроля. То есть, когда мы научаемся контролировать свои желания, мы научаемся свободе воли. Я бросил курить исключительно по вот рефлексивным основаниям. То есть я однажды шел по Малому проспекту Васильевского острова до своей работы, вдыхал вот эти газы от проезжавших мимо автомобилей, и в какой-то момент я просто подумал, что это же просто идиотизм, что я сам, я понимаю, вот когда есть внешние обстоятельства, и кто-то отравляет мой организм, но зачем я делаю сам это со своим организмом? И это был, собственно, акт какого-то окончательного решения. То есть он все решил, я ничего не планировал. Если я хочу, чтобы другой отвечал за поступок, который он совершил, то я хочу жить в мире, где есть свобода воли. Даже если мы живем в мире, в котором нет возможности поступить иначе, мы должны жить так, как если бы эта возможность у нас существовала. Чтобы быть свободным, надо хотеть быть свободным.
Сейчас же мозг становится очень коммерческим объектом. И, скажем, много компаний, которые, например, вам продают всякую ерунду под предлогом улучшить память, например. И это приносит большие доходы.
Но это тоже история не про мозг.
Ну это да, это история про этот мир.
Алексей Евгеньевич, в кадре.
Да я уже всегда в кадре. Я уже суперстар. Почему и наука? Какая-то была же такая фраза о том, что это возможность удовлетворить свое любопытство за государственный счет.
Бьет вечер крылом в окно, хлопочет веретено, сплетает из мыслей свет, чтоб завтра на все на свете вопросы найти ответ. Кто доходит до края, в тех краях зажигает небо огонь, где крайность не знает и целого мира не хватает.
Вот сегодня к вечеру у вас, у меня примерно на 10-15 тысяч нервных клеток станет меньше.
Нас уничтожат роботы.
Пустой кабинет, рассвет. Казалось, мелькнул ответ, но истина словно блик. И снова он ищет, он словно уже привык. Кто доходит
Еще раз добрый день. Надеюсь, вы посмотрели фильм и вам понравилось. У нас есть еще немного времени, и у меня теперь есть возможность отомстить моему соведущему.
За что, Лёш, за что отомстить?
За все, что было у нас с тобой с фильмом, немножко тебя поинтервьюировать по нему.
А для тех, кто не знает, просто...
можно нашу картинку вывести? А то мы...
Год назад я просила Алексея вести премьеру этого фильма сначала в Самаре, а потом выступать перед залом больше, чем в 1000 человек, которые собрались у нас на премьере в Москве. И у нас там была небольшая техническая неполадка, во время которой я сказала: Лёша, выходи на сцену и занимай зал. И Лёша в диком стрессе вышел перед 1000-ной аудиторией и удерживал эту аудиторию до тех пор, пока техническая неполадка не была устранена кинотеатром.
38 минут.
Это были самые страшные 38 минут в его жизни, наверное.
Окей. Поэтому сейчас я хотел бы с тобой поговорить про фильм. Потому что я в этом фильме был так немножко со стороны. Мы только в самом конце его смотрели, давали некоторые замечания. Как вообще, вот откуда у тебя появилась, не то что идея, первый фильм понятно, с первым фильмом более-менее понятно, как он появился. Как ты решила, про что ты будешь снимать второй?
Второй фильм плавно вытек из первого фильма, потому что, во-первых, были темы, которые мы не осветили, например, тема свободы воли, да, эксперимент Либета. Вот, и мы как-то сели с Василием Кучерёвым, и я говорю, ну, что мы можем? Нам же нужно экранизировать что-то, да, мы же не просто говорящую голову там должны снять. И мы с ним накидали эксперименты, вот, и он мне подсказал, к кому еще обратиться. И, собственно, достаточно быстро был написан сценарий, и мы прям по нему сняли.
У тебя в фильме достаточно много очень сильных, очень хороших ученых. Сложно было получить от них в кадре то, что нужно тебе, а не то, что они хотели бы?
Нет, не сложно, потому что главное найти общий язык, да. Я немножко в таком приятном положении нахожусь, потому что я не журналист, да. То есть я могу снимать кино долго, я могу снимать его, в среднем кино снимается 1,5-2 года. Поэтому у меня есть достаточно много времени, во-первых, для того, чтобы в теме разобраться, а во-вторых, чтобы объяснить людям, чего я от них хочу. Поэтому понятно, что когда мы пришли, например, в Центр нейроэкономики снимать эксперимент Либета, мы сказали, сейчас мы выключим здесь весь свет и поставим свой. Мы понимаем, да, что ученые не проводят так эксперимент, но нам для изображения, например, это нужно было. И все понимали вокруг. Сложно было с эпизодом, с интерфейсом с обезьянами. И я вот тут я 3 раза просила Михаила рассказать, в чем суть его исследований, потому что один раз мы сняли интервью, сделали такой тестовый небольшой фокус-группу, мы тоже устраиваем, когда показываем, особенно когда я работаю в научно-популярной сфере, и не все могут понимать, о чем идет речь. И мне зрители говорят, непонятно. 2-й раз мы попробовали, непонятно. 3-й раз я уже пришла, просто дала ему листок, фломастер, говорю, Михаил, рисуйте. Объясните просто людям, которые вообще не знают, что такое на интерфейсе, чем вы занимаетесь с обезьянами. Вот.
Как реагировали зрители на фильм, я видел. Я был достаточно много опыта. Я смотрел в Самаре, как люди смотрят.
So we want to discuss the film that we have just seen, and I actually have seen the reaction from the viewers, but what was the reaction from the neuroscientists that did not take part in the film? Who, for example? Well, there were a lot of such people. Did you get any feedback? So I remember that we were exchanging our views on the missing facts and events. Yeah, actually, I remember there was a Facebook article. It was quite critical.
честно говоря. Ко мне не обращались по этому поводу.
Well, actually, I don't know. I didn't receive any feedback from anyone. I know that after these 2 movies about the brain, you actually shot 2 movies about robots, and you also now currently shooting a movie on chips. And what's next? We actually don't know what's going to happen next. Yeah, when we talk about robots, we also have neuroscientists featuring there, and psychologists. Mikhail Lebedev and others are taking part. And as for the movie about the chips, we are just getting prepared. Actually, I'm sitting now over here and I'm observing what can I take into my movie. So we're just preparing. And we wanted to go deeper into that topic. Why? Because after the speech by Mikhalkov and after the discussion about chipping everybody started to talk about it. So we wanted to make it a full screen movie, right? Because now we have quite a small group. But when I'm demonstrating different movies, the first one, the second one, and we also have the person in the first movie who chipped their bugs, and people take a look at and just think, wow, what people are doing. The reaction is quite intensive. They're asking, like, what are you doing? Everybody will be carrying some chips in the near future. Not all of them are reacting in the same way. So my task as a person who popularizes that, actually, I need to explain how it all works. I need to explain that it will not happen in such a way that tomorrow you'll be taken to a lab and you'll be getting some chip. No, this is not the way it should be happening. But this is a very long explanation and discussion. That's why we wanted to shoot this movie and make it a full screen version. And they say that after 2 movies about the brain, a lot of your colleagues, directors, they actually signed with some kind of a good sign, and they said that you are just shooting the documentaries, right? And this is it. Well, actually, we don't have any directors who are shooting science fiction and science documentary. So I was just put into another category. This is quite funny because when you invite some cinema critics to come to my movies shooting and demonstration, they say, well, you know, you have a different sphere here. We don't understand anything about it. Still, this is documentary, but the genres and the borders between them are being quite vague now. And actually in Chelyabinsk, each September, there is a festival taking place. And last time we got there together with Michael Lebedev to represent our first movie. And then I went myself. But this year I didn't come to that festival because my next movie is not ready. This is about robots. And one of the organizers of the festival actually asked them, you know, 2 years in a row, you had 2 movies about the brain. So this year you didn't have any. Why? Why is that? So it means that the audience is actually waiting for some movies on that topic. And what's more difficult? To be directing these films, movies, or to lead the Samara Neuro Week? Well, actually, the Samara Neuro Week is a little bit more difficult for me because it has a very intensive schedule. Well, actually, I also see that you are following some presentations when you do not moderate, whether it's very interesting for you. Have you become a specialist in that area already? Yeah, actually, I do take interest in some of the presentations, and some of them which I do understand. Well, actually, I have also like a plot and a story because I watched the TV show, The House, TV show, and I thought that I could also be a medic, a doctor. And don't you think that after shooting this range of movies, you could also be coming to a lab and joining the scientists? Aren't you afraid of that? No, of course I'm not afraid of that, because I have a very clear border between my activity and the scientific activities. You know, I shouldn't be going into very deep details on that. Because if I go into the details, then I'll think that everybody knows that, and it will be bad for my movie, because I need to communicate my message to just a regular person, and I need to know just a little bit more than a regular person. I need to remind my interlocutors constantly that I don't understand something, because if I'll be talking this scientific language with everybody, then I'll not be able to make a movie which would be available for a wide audience, because I need to take all that into account. Currently, my third movie is about neurointerfaces, and I do understand that I need to tell my audience once again what is a neurointerface. I've done that in my first movie, in my second movie, but now I have to start from scratch, and I also need to tell them that this is kind of a technology and we have it. I have to explain it. Okay, I do understand it. Well, I believe that you should really be taking into account the two layers: your layer, your knowledge, and also you should not forget about the audience. So basically, you need to go deep, but also you should not forget about the education level of the audience. The question: the last 4 movies of yours are by and large about a brain. Aren't you afraid that you are stuck in this topic? Don't you want to shoot something about food? It can also be very beautiful, you know, you can travel a lot. Well, I travel anyways. I went to Vorkuta and I shot the movie about miners there. I also shot some movies about agriculture. But now, I mean that the films that you are now producing are about a brain. You are perceived as a director that actually shot movies about scientifically popular topics, and you are constantly shooting your movies about the brain now.
Да, но нам еще нужно занять 7 минут до следующей части, четвертой
We actually have a session that's going on in parallel with us. We still have 7 minutes to go before the official start of our next session. I'm also interested in a lot of different topics. I actually have 3 projects that are going in parallel, but the projects that I'm associated with, for some reason, they are connected to the brain. I actually do a lot of other stuff as well. Okay, thank you very much for your interview. We also have to announce what we're going to have tomorrow. Okay, let's do that. Tomorrow we'll have a wonderful discussion. At 4:30 p.m. we'll be discussing Larry Link latest works with the leading scientists, international scientists. Unfortunately, I don't have a list. I do. We have Mr. Lebedev. Oh, I'm not sure about that. Okay, doesn't matter. So we'll have our leading scientists who will elaborate on Elon Musk activities, what he's done, and whether it correlates with what he promised to do. Can we believe that this is a real breakthrough? Or this is just one of the breakthroughs among other things. And in addition to that, we'll also have a virtual exposition, an exhibition. That's right. And then, starting from 6 p.m. Samara time and up to 8 p.m., we'll have a poster session. The authors of the posters should be virtually at their places. They shall be waiting for you and your questions and your proposals on cooperation. And at the same time, we'll have representatives of the companies at their exhibiting stands. So from 6 p.m. to 8 p.m., we'll organize a virtual business and scientific communication. Either we go to a poster session and communicate there, or you can go to the exhibition and you can talk to the representatives of the companies. And after that, we'll have a virtual reception, so-called, and we call it a Euro bar. It's a virtual party. So somebody will come with a whiskey, somebody with vodka, somebody with coffee, whichever you prefer. And up to 4:30 p.m., we'll have 3 important events. They are more narrow ones, but still, we will be organizing 3 very important areas of interaction. This will be on the cooperation between the therapeutic aspect and other aspects with the brain. From 10 to 11:30, we'll have a workshop on biological feedback, neurofeedback. From 11:30 till 1 p.m., we'll have a workshop on transcranial magnetic stimulation, navigated and not navigated DMS diagnostics. It'll be devoted to the therapeutic and diagnostical capacities of TMS during strokes. And the next half an hour will be devoted to the workshop that will be devoted to the transcranial stimulation by a direct current. And then at 4:30 p.m., we'll have a panel discussion with unquestionably leading experts in this area. Mikhail Lebedev, Karen Nurmilhangen, Jordan Wolpert, and Kin Chang. So this is the composition of our discussion tomorrow. And this is our agenda for tomorrow as well. And on Saturday, we'll have a hackathon. We'll have the Olympics on neurophysiology from 2 p.m. to 4 p.m. We'll have a neuropitch session from 4 p.m. to 6 p.m. We'll have 4 open lectures from 3 leading scientists. And I'll also be among them for some reason. And from 6 p.m. to 8 p.m., we'll have our finals of neuro competition. And after that, first we'll have an awards ceremony for all the winners of all our competitions. And after that, we'll have a neuro bar. How can we do without it on Saturday evening? And in parallel, offline in Samara, we'll have a documentary festival. Offline, you mean? Yulia, will you be there? Yes, in Samara, in one of the department's buildings of our medical university, we'll have a documentary films festival. We selected 6 films that are connected to the neuroscience. So we'll have 2 films on the brain. We'll communicate to the audience as well. And on Saturday, we'll have additional 3 events: soft skills workshop, scientific communication workshop, and new knowledge in neuroscience workshop as well. So that is our agenda for the upcoming couple of days. Yuri, are you here? I think it's time for us to start. It's time to start our 4th session. And it's time for me to present my scientific speech.
У нас опять задерживается.
Once again, our moderator is a little bit late. Our moderator for the fourth and the last session for today.
Хочется понять, ждать ли нам Юрия Котлевцева.
We'd like to understand whether we should be waiting for Yuri or not.
Давайте я тогда пока что расскажу, кто у нас сегодня.
Okay, let me tell you about our speakers that are left for today. First one by Surya Sakadar from Tübingen University. He'll be talking about clinical neurotechnology in psychiatry. Then we have amazing Petr Brzezowski. Then Mel Slater from Barcelona. And in conclusion, Sandy Chapman. I'm very happy that all our guests will be presenting today. Some of them I know in person. For example, I know Surya and Petr. I haven't connected yet.
Да, давайте так.
Давайте мы тогда.
Let me start the final session.
In psychiatry. So you all know that life expectancy has more than doubled in the last 100 years. We have now reached 82 years in the European Union, and many diseases that were not really, diseases that were deadly a few decades ago are not really a big deal anymore. But there is one cluster of health issues that does not show this trend, and this cluster is disorders of the brain. So 25 years ago, approximately 9% of all invalidity pensions were paid due to anxiety or depression. Today, this share has increased to 43%. And what is even more alarming is that the number of teenagers who show symptoms of depression has more than doubled in the last 10 years. So there is an increasing number of disorders of the brain, also because people are becoming older. So we have a big problem, for example, with dementia, but also depression plays a big role, depression and anxiety. So now the question is, how can we solve this issue? And in the next 20 minutes or 25 minutes, I want to talk about how to use neurotechnology to treat these different disorders of the brain. So in the first part, I'm going to talk mainly about brain-computer interfaces and how they were used to restore movements and paralysis, and what we have learned from using brain-computer interfaces in a clinical environment, and how this knowledge can be translated into applications in psychiatry. So we have all now reached the age of neurotechnology, and there were a lot of science fiction movies that were already anticipating what will be possible maybe in the future. And there was also a lot of media attention in the last 5 years, I would say, because the big global companies are now also moving into the field of neurotechnology. So neurotechnology is any form of artificial means to record, analyze, and also modulate or change brain activity. And when we use neurotechnology, we can use this technology to understand, diagnose, and treat different diseases. But now, if you analyze brain activity in real time and translate it into a control signal of a digital device, you can have a new set of applications. So we can use neurotechnology to control external devices, for example, a robot or a drone. And the first, like these brain-computer interfaces, they can use different forms of brain activity. What you all know is probably non-invasive means, for example, MEG or EEG, electroencephalography. Now we have seen in the last couple of years that also quantum sensors are used. These are sensors that can detect neuromagnetic activity at room temperature. So before we used squid MEG, where we had to cool down the sensors with helium so that they were superconducting to be sensitive enough to measure the activity of the brain. Today we can do this with optically pumped magnetometers. And there is also a technique called functional near-infrared spectroscopy, where we use essentially red light to see changes in oxygenization of superficial layers of the cortex. And with this, we can see the consumption of oxygen in the brain. You all know functional fMRI, like functional MRI, magnetic resonance imaging. With this technique, we can look deeper into the brain. And when we record this activity in real time and translate it, we can also do neurofeedback with deep areas of the brain. And then obviously we can remove the skull and place electrodes into the skull, for example, superficially as an ECOG, but we can also implant. And you've probably all seen the Neuralink device that inserts threads into the brain, but the only certified device for human use is the Utah array that you see on the lower right. So here you use 100 microelectrodes to record activity of single cells or multi-unit activity. And of course, you can also use electrocorticography, as I mentioned. Yeah? So the first clinically meaningful BCI was introduced in the late 90s in a patient who suffered from locked-in syndrome, who was unable to speak or move, and who depended on artificial respiration. This patient could select letters on the screen by modulating his electric activity and write a letter. So in parallel, also implantable devices were developed that record brain activity for high-dimensional control of robotic arms. Here you see a number of examples. These are all using the Utah arrays, and on the right you see a person who is using 3 Utah arrays implanted in his brain to control 2 prosthetic devices. The big problem with this is that all implantation involves a risk of infections and bleedings. There is no certification for long-term use. So usually these devices have to be removed after a while. And these systems have never been used outside of the lab in the everyday life of these patients. So there is always an engineer close by having a red button to interrupt any malfunction of the systems. Obviously, there are also a number of other disadvantages when you implant. So, for example, once you have implanted the device, the user cannot remove it at will. And also implanting these devices in hundreds of thousands or even millions of people raises a number of very complex ethical questions. So in my group, we have worked on a non-invasive BCI that we used in patients with quadriplegia. So these patients were unable to grasp these different objects of daily living, for example, the cup, a pen, or a piece of paper. And you can see they can move the shoulder and they can reach the objects, but they cannot grasp. We have equipped these patients with a neural exoskeleton. So these, the system translated their electric brain activity into actual grasping motions when they were when they had the intention to move their fingers. The system could be also used outside of the lab. So this man could go into a restaurant and order some food and eat it with a fork for the first time after many years. So we have also asked the patients what they would like to do with this ability. And here you see a patient who asked for a plate of potato chips. And you can see that the system really improved the quality of life of this man. We have also used the system in patients with chronic stroke. And these patients, they could not move their fingers for years or sometimes even for decades. And what we've seen after 1 month of daily training, when they used it for an hour on a daily basis, we've seen that after 1 month, the patients could move, some of these patients could move the fingers again. And using neuroimaging techniques, we found that their brains have reorganized and also rewired. And as you can see, before the training with the exoskeleton, their brain was equally activated on both hemispheres. After the training, we could see that the activity has shifted to the areas that were connected to the exoskeleton. So using this exoskeleton shifted their brain activity and also led to a rewiring of their brain that allowed them to use their hand even without the exoskeleton. So another example of the neuroplasticity that can be induced by neurotechnology is shown here. So this is a rat in which the spinal cord was actually cut through. So the rat should not be able to move. But using a brain-computer interface that was connecting the cortex, you see here the wire, and the spinal cord, the rat could walk again. The same principle was also implemented in a patient with a lesion you see here, and they implanted an electrode underneath the lesion that was triggered by movements of the body. So whenever the patient was leaning forward, the stimulation went on, and the patient could actually do locomotion movements. When the stimulation was turned off, the patient could not move. So here you see that the patient could move with the system. And as with the patients who used the exoskeleton, the patients used it for several months. And here you see that after these months, the patients could move their legs again. And this patient, after a few months of training, could even walk unassisted. And he was in a wheelchair before. So that is a very good example of how this kind of real-time brain-computer interfacing can induce plasticity, triggering neural recovery after stroke or after quadriplegia because of a spinal cord injury. So, we have now put this to a new level. So we want that the stroke patients can use the system at home, obviously, where they can also use the system for assistance, for example, in the kitchen. So we are working on systems that the patients can use at home. And that's a technical challenge. So we want that the users can use the system independently so that they can actually mount it unassisted. That's a larger project that we are doing now. And I actually wanted to talk about psychiatry. So that was just the preludium to show you what is possible with brain-computer interfaces in the motor domain. And I think it's very important to see these results because you get an idea of the potential of this technology. So in this first part, I wanted to show you that these brain-machine interfaces are effective tools to improve living conditions in paralysis, and that using these systems on a daily basis can lead to neuroplasticity and rewiring of the brain, so functional and structural plasticity. And the same principle may also work in the treatment of other disorders of the brain, for example, depression or anxiety. The question is now, how? And I want to talk about this now for the next 10 minutes. So in the motor BCI, we are translating brain activity into sensory feedback, and we translate usually the intention or the thought of a movement into an actual movement of an exoskeleton, or you can also use electric stimulation, and there are different ways to do that. Now, we have seen that this leads to functional and structural reorganization of the brain. In the future, when we want to use these systems for treatments in psychiatry, we will also translate brain activity in real time and provide some form of sensory feedback. So this sensory feedback can be very diverse. So it can be vibrotactile, vibroacoustic, it can be visual. There is no limit as long as the brain can sense the feedback. However, we want to translate brain activity related to a number of brain functions that are affected by psychiatric disorders. For example, working memory, emotion regulation, or also sensory motor integration. And we want to use adaptive brain stimulation to foster this neuroplasticity and improve brain function. Now, a logical step to identify these neural substrates, the oscillatory correlates of these different brain functions like working memory and so on, is to record brain activity, use brain stimulation, and see how this stimulation changes the brain activity and behavior. With this kind of approach, we can infer the causal links between brain activity and behavior or brain function. There is another dimension to it. So this is a very simplified concept here, and it's based on a waveform of a signal. But we know that the brain, of course, is super complex, and we have a number of neural circuits in the brain that are linked to certain brain functions. So when we want to target these different brain activity patterns, we also need to be spatially very specific. And that is a big challenge right now. So based on the work that has been done in neuroimaging, we know now that there are certain brain areas, for example, related to dysphoria. You see here these different areas that are interacting, the amygdala, the insula, also the orbital frontal cortex, the hippocampus. And you see that there is a hyperconnectivity in this network, for example, in this depression, while there is a hypoactivity between the dorsolateral prefrontal cortex and the amygdala, for example. Yeah? And we know this now already from neuroimaging studies. Now we have to find ways to be spatially specific, record activity from these very areas, and then drive them into different states to change the activity in these neural circuits. Yeah? So we know now, for example, there is a circuit for anhedonia, rumination, dysphoria, or disrupted cognitive control. So disrupted cognitive control is also very important, for example, for OCD, for obsessive compulsive disorder, and also in other disorders. So how can we record brain activity while we stimulate the brain? Because we want to know, if we know these areas, what is really the activity, what is the frequency, and what is the oscillatory waveform responsible for the communication of this area with other areas in the brain. To do this, we need to combine brain stimulation with neuroimaging. And if you do electric stimulation to the brain, it is very difficult to record activity from the brain because you see a lot of artifacts. We have developed a number of techniques to stimulate the brain with different waveforms. This is DC stimulation, while we reconstruct the activity, the physiological activity related to finger tapping, for example. Here you see an example of using a new stimulation technique called amplitude modulated alternating current stimulation to target different frequencies in the brain and reconstruct this physiological activity while the brain is stimulated. Yeah? So that was something that we established 4 years ago. And we have now also a possibility to do, this was in MEG, we have now also the possibility to do this in EEG in real time. That's very important. And it's now in the last round in NeuroImage, so it's already available as a reprint. I can only recommend to have a look if you want to do this kind of research real-time analysis of brain activity during brain stimulation, targeting different oscillations. This work was now published by David Haslacher, who is a PhD student in my lab. So you'll see it soon in NeuroImage. So that's all possible now. We have the tools, and now we have to go and target different brain functions. So just to see whether it's possible to apply this technology, we have established this in a working memory task. So when you do a working memory task, you see an increase of theta oscillations. These are oscillations between 4 and 9 hertz in the frontal lobe. This is called the frontal midline theta. And we have targeted this oscillation, and we could see that with this, you can actually modulate the performance of working memory. And of course, you can also modulate then the power of this frontal midline theta when you stimulate at this frequency. So this is all possible. We can reconstruct that during the stimulation and really look into the brain while we target these oscillations. Now, to come back to the big challenge of spatial specificity. If we use EEG, there are a number of limitations in terms of spatial specificity. So usually for our motor BCI, we use Laplace filter or filters that give you at least an idea of left or right hemispheric sources. But what we need is something that is much, much higher. Yeah, so if you want to record, for example, from the dorsolateral prefrontal cortex, we're speaking about an area that is only a centimeter large, and you don't want to have activity from other areas. And here we can use quantum sensors. These are the sensors that I already mentioned, the OPMs, optically pumped magnetometers. And using these sensors that are much, much closer to the skull compared to the conventional MEG, where you have approximately 7 centimeter distance from the brain. Here you have approximately 3 centimeters distance from the brain. You reach a much higher spatial resolution. And as there's no volume conduction, you can reconstruct the sources really at a much, much higher spatial resolution. And what we also need is brain stimulation techniques that are spatially specific. And that's the next problem. So when we stimulate the brain electrically, the electric fields are finding their way through the tissue that has the lowest impedance, obviously. So the electricity goes through the eyes and through the veins, and it is very difficult to model this. So we can attempt it, but as the brain is an organ, it can change the impedance depending on how much you drink and on the food that you eat. So there are, and your physiological state. So we need a different technique, and we need something that is much more spatially specific. So this could be done with magnetic stimulation. And that is something that, of course, we are also working on, magnetic stimulation of the brain. So now, how can this new system that targets this activity in the brain be embedded in psychiatry? So first of all, we need to identify these individual neurosubstrates of brain functions, and we can then embed this in the established methodologies like psychopharmacology and especially psychosocial interventions. So context is very important, and we can also use digital tools to track the effect of the stimulation and neurofeedback. For example, a smartwatch or certain questionnaires that you use on the smartphone. That is a big gap in knowledge. When I do my treatments here at the Charité, I see the patients probably once a week during the treatment, and they can, of course, tell me how the situation was. But using digital tools, I can get a much better idea of what the impact was of the stimulation. And using these digital tools, we can also record, of course, a mobile EEG. We can objectify what has changed in the brain and create computational models that help us to even improve the whole circuit of BCI neurofeedback and stimulation. So let's come to the final conclusions. I have shown that repeated use of a brain-computer interface can result in functional and structural neuroplasticity. using brain stimulation at the same time can elucidate the causal link between brain activity and brain functions and behavior, and that not only in the motor domain, but beyond that, working memory, emotion control, cognitive control, all these different brain functions. Now, what is key is really phase frequency and spatially specific targeting of this brain activity. Yeah. So for this, we probably need more advanced techniques than we have right now, like EEG or electric stimulation of the brain. We can do something with it, but we need to refine these techniques. So quantum sensors that are introduced and novel brain simulation techniques are very promising tools to advance this tool set of neurotechnology towards applications in psychiatry. And with this, I would like to stop here, and I'm very happy to answer some questions now.
Thank you very much, Surjo. Sorry, I wasn't able to introduce you, but Alexei did a good job. It was a technical problem. I was there, but wasn't connected. So thank you very much for a very stimulating talk. We have questions in the chat. If they come, I don't see them at the moment, but then maybe it's my role to ask some questions now. It's fascinating. It's not the first time I'm listening to the presentation of fantastic things which can be done through the brain-computer interface and utilizing brain plasticity. And you're really advancing towards stimulation and recording from the very tiny regions of the brain.
Yes.
My question is, would you agree with me that this field now represents the level of science when we started to manipulate, but we do not understand much? For instance, people started to use gunpowder when they didn't know what potassium nitrate is. It was saltpeter and charcoal. So how you could define the level of our understanding and the level of our manipulation with these techniques?
So it is exactly as you say. We are doing things with brain, and of course we want to observe the reaction of the brain in the highest spatial and temporal resolution possible. We use non-invasive tools, and what has really changed the field in the last 5 years was the introduction of machine learning. But here is the catch. If we use these machine learning algorithms, sometimes using deep neural networks that really can detect hidden patterns of brain activity, the problem is that it really doesn't explain us how the brain works. It will just detect a pattern and can classify it, but it doesn't really help us to understand. And this is where I think different areas of neuroscience have to work together. So colleagues of mine are doing invasive neurotechnology. And of course, these invasive recordings are very important for us to understand the basics of how the brain integrates information. And from there, we can infer maybe non-invasively what's happening in the brain. But, I am a clinician mainly. So for me, it's very important to apply. I need to understand, and I have also, I have two hearts in my chest. One is a scientist and the other one is a clinician. So I have now also used machine learning a lot in this without really having the intention to understand every step. But once we have the tool, we may understand from applying the tool. It's like you say with the gunpowder. Yeah. So I think it's a dance with these technologies, and we have to see and we have to keep our eyes open and see also the limitations of different approaches. Where can we actually expect some answers and where it's actually not really helping us in answering?
Thank you. There are a couple of specific questions from the audience. Since brain is very plastic, how and to what extent does the brain stimulation affect its structure?
Yeah, that's a very good question. So in my laboratory, we are stimulating patients with different psychiatric disorders. And we do this with ECT, electroconvulsive therapy, for many decades now. And what we see is that, for example, this convulsion therapy has very profound effects that then really lead to rewiring of the brain and keep stable. Some of these patients have to undergo ECT again after a certain time, but it's all about stabilizing a system. So the brain is always in a critical state. We can use brain stimulation to shift it into a different state, and then it's about keeping it in this state. So that's what we're trying to do with brain stimulation.
Great, Sergio. I would love to talk, audience would love to talk with you through connection through me, but we have another speaker already bumping into the screen. Thank you very much.
Thank you very much. It was a pleasure to be here.
Thank you. And now we have a next speaker. Hello.
У меня почему-то спрашивает, не может видео включить.
Ну сейчас Максим, то есть Матвей вас подключит, Петр, сейчас.
Голос уже есть, я был подключен.
There's something wrong with the video.
Примите сейчас запрос на подключение видео, нажмите ОК.
Значит, я тогда компьютер включаю.
Да, все вас видно, Петр? Мы вас видим.
Да, хорошо.
Hi, it's my pleasure to introduce you Peter Brzezinski. It's a guy of Eduard Limonov generation, I guess, a science punk, a legend of Russian, Soviet by that time, biophysics, who moved to France, I believe, in late 80s or 1990, and since then happily working there. Peter is biophysicist, a specialist in neural impulse transduction, ion channels, but today he will be speaking, I believe, about optogenetics. It's all yours, Peter. As you like, you can speak Russian or English. The audience...
Okay, okay, so thank you very much. I will... actually, I will speak Russian because
the audience mostly is Russian.
Most of the audience is Russian speaking, but I prepared my slides. I prepared my slides in English to facilitate the job of speakers and to
very good.
Facilitate the life of Russian speaking people. Значит, я хочу, во-первых, поблагодарить организаторов за замечательную конференцию. Это очень интересно и очень вдохновляюще для меня.
Okay, first of all, I would like to thank the organizers for inviting me to this wonderful conference. I have heard many interesting presentations with lots of insights.
Вот проблема, которую мы обсуждаем, это проблема когнитивных систем, в основе которых лежит взаимодействие, мышление.
In my presentation, I would like to talk about the cognitive systems, and we need to understand, in order to be able to understand how the brain works, how the hardware works, and what's the theory behind that. Experimental scientists, as I often compare them, with a frog fiddling in the dirt, whereas a theorist is an eagle flying there.
Взлетать для того, чтобы строить теории. И это чрезвычайно важно. И строить теории очень важно, но с другой стороны эксперимент является...
Because the theories are important, but the hardware is important too.
никаким количеством экспериментов нельзя доказать теорию, но достаточно одного эксперимента, чтобы ее опровергнуть. И это действительно правда. Потому что есть очень много теоретиков, которые строят теории, а потом они не работают. Но есть очень много экспериментаторов, которые копаются в болоте и оттуда не вылезают и тоже не получают никаких вещей. Но есть некоторые прорывы, которые позволяют нам двигаться вперед в познании, в понимании того, как работает мозг, и не только как работает мозг, но и как работает вообще вся.
So somehow we need to combine the theory and the practice. That's what it's all about. Yeah. So anyways, the brain is a mystery, as you know. It's a mystery, and this mystery is, let's say, 85 million neurons, right? And all these cells and this tremendous dense network that's around them. So this is a very plastic, yet fully organized and a very, very complex structure. Very complicated. So it's like a computer. You can call it a nanocomputer that consumes tremendous amount of energy. It's actually very, very energy efficient, only 20 watts. It's like a fridge or maybe like a light bulb. And it operates slowly, by the way, slowly, but at the same time, it's super quick. It's almost like parallelism. So it's like imagine multiple computers running at the same time. That's the beauty of the brain. It consumes little power. And it's almost like you can call it a transformer between the analogous and the digital. It's an incredible device, this brain. So we need to understand both the hardware and the software, right? And we need to combine the practice and the theory. And that's the trick, essentially, because our brain serves as the frequency transducer, right? So we're trying to transform analogous information into digital. And at the same time, brain has a bad memory, so the memory is very unreliable, and its lifespan is also quite short. There was this study, and they were talking about the development of the neuron development over time. And they say that when a person is 5 years old, there's so many connections, and as these connections start breaking down, but like maybe 13, 15 years of age, that's like the best time, that's the sweet spot. And after 25, after 30 years of age, the number of neurons start breaking down. You get Alzheimer's, you get dementia, you get Parkinson's disease, and all this kind of stuff, right? Everything that we've been discussing. So anyways, if you look at the brain of a human compared to a computer, again, I'm just giving you an example. So just to run an analogy, so computers are actually quite slow. You know, they actually operate at less than 1 kilohertz. Yeah, but we don't see your slides, Professor. Try sharing the screen. Oh my God, you don't see my slides. Oh my God, sweet Jesus, I didn't know that. I thought it's just the intro. Actually, you're flipping through the slides. Oh, I'm sorry. Okay, my bad. Okay, I hope you can see it. Not yet. But, you know, we understand that, you know, your presentation is very good, so we're kind of following it, but slides are better. What about now? Yes, we can see it clear. Thank you so much. Okay, then the brain and the computer. Okay, I'm not coming back to the Albert Einstein. Everybody knows Albert. Yes, we know Einstein. Sure, absolutely. But he's so creative. There's so many different nice pictures of Albert Einstein. Anyways, let's not go back. Let's go on. So the brain is slow, right? But the computer is rapid, right? So, and the brain is unreliable. The computer is reliable. The brain is selfish, right? But it's very good at binary processes and the parallel processing. But the computer has sequential processing. And so the brain is essentially selfish, you can say. I don't know if it's the right term, but brain is selfish, right? It's mostly self-centric because everything is happening inside that. You don't really know what's happening. It's like a black box. We don't really know what's happening inside, but yet it's processing all this tremendous amount of data, right? And because of this dark black box, we laugh and we cry and we experience different emotions and all that. Yeah, the computers are mostly about outside. It's not a black box. And our brain is like a binary and frequency code. Yet the computer is a binary code. And the brain is more of a parallel processing. Yes, it's slow, but because it can run multiple parallel processes, it gives it speed. But the computer is rapid, yes, much quicker, but it's doing mostly sequential processing. And the reason it's so important. And the reason it's so important that there's certain parts of the brain that process process information in a parallel way. So we need to understand how all of that works together. So, like I said, speaking of brain development, it starts from cells that proliferate, that migrate and differentiate, and somewhere around 3 to 5 years old, they get this tremendous amount of synaptic connections, and then over time they start to break down if you don't stimulate it. But an adult brain is a fully developed synaptically connected cells, and the number of them is actually more than a number of stars in a galaxy, even more so, maybe in a galaxy. It's a tremendous, one of the most powerful computers ever built in the universe. How do you study it? How do you even approach to study it? How do you know? Well, powerful, but complicated. So the brain, and let me show you this picture. So the brain, a lot of brain development has to do with genes. It's gene expression. So genes produce structure, structure produce functions, right? Genes and activity. The brain function is a result of information from genes and the influence of the environment. So the human cognitive system is all based on the interaction of thinking, conscious memory, and language. Okay? So,
на функции. И вот эта вот активность, она является чрезвычайно важной, потому что вот эта вот внешняя активность...
And this activity is so very important because this interaction with the environment is very, very important because it defines our thinking, the way we think, the way we act, the way we talk. So that you know that the brain constantly adjusts under the influence of functional activity. There was this ruler, and he thought, like, what would happen to a human being if you keep people numb? And it turns out that these people, they couldn't even talk, and they actually died very quickly. So Rudyard Kipling, the founder, the writer of Mowgli, right? I mean, it was a bit of a fantasy, of course, because unless you speak, you die, essentially. So a baby needs to hear human words. Otherwise, you become unsocial and you eventually die. So human eyes needs to see the light. Otherwise, you will remain blind. So there's a very, very, very powerful interaction. We are hardwired to interact with the environment. Now, if you blow up the brain, take this particular section of the brain, you see that such a diversity of neurons, all these dendrite trees. Look at this, almost like an Amazon forest. Axons, look at this beauty. So many different neurons that transmit information from this part to that part. Some of these neurons, they receive a lot of information, then pass it on to other beats that receive less information. They serve as filters. So it's all this vibrance of activity. It's almost like its own country. They have presidents, they have generals, they have police, they have common folk. It's a very, very complex organization, different types of neurons. And it operates thanks to synaptic connections. But I'm not going to talk about it, but these are incredible structures that are beautiful. I really love watching it. I love these neurons. They're so beautiful, so aesthetic. And every time I do a lecture, I always show it like just a variety of neurons. This is the Purkinje cell. It receives more than 200,000 inputs, and it's processing all these inputs. And it has one axon. It transmits all this. It's a huge integration cell. What about endocrine cell? This one in our retina. This is a microcomputer. This is a powerful microcomputer. This is a pyramidal shape cell that processes light information and visual information, then transmitted to the brain. And it receives and transmits information. And it has this structures called spikes. You see, these are exciting, these are synapses, and there's also the two types of synapses, right? These are types of the neurons in the human brain, and this is how they work in sync. The firing neurons, and we need to know that. We need to study it, and we need to, and all of this information came to us I would say during the past couple of decades, it was unknown until recently. This is very, very important information. And what's even more important is that in the cortex of the human brain, there are microcomputers, the so-called cortical columns. These are tiny, tiny, tiny cells. These are 300 microns, and they contain from 10,000 to 500,000 cells. And these are tiny neuron cells that are very complex. You can actually see it here. So they receive information from other parts of the brain. And when this information comes to us, they fire. And then they transmit this information further along the line. This is absolutely incredible. So this is a general view of the brain. Like a human nervous system disorder, I mean, it's a very amazing yet unreliable and a very sensitive thing. And all these diseases like schizophrenia, depression, anxiety, Alzheimer's disease, sleep disorders, migraine, chronic pain, addictions, obesity, autism, traumatic brain injuries, epileptic, vision loss, etc., etc., etc. Every seventh person living on this planet has some sort of these nervous system disorders. Some say that actually even more so. They say every third person, like a third of all people, or maybe not, who knows? You never know. All these nervous system disorders, they're so tricky. So what do we need to do about it? We need to study this incredible system, and we need to study it at all levels. So the hippocampus, for instance, is a great place to study the neurons. We need to study not just the neurons, but parts of the neurons, like the dendrite trees. And then we need to take it down to single channels, down to specific functions. We need to study all of that. We need to study the crystal structure that gives us so much information and that enables us all this knowledge. And by the way, people that work with drugs, with the pharmacology, that's what they want to study. The receptors, the ion channel functions, different levels of brain analysis. So like I said, we need to do from A to Z. We need to study this whole system A to Z, from angstroms, right, from the lowest, tiniest elements all the way to the biggest. So it's a very, very wide range of research. Yes, very, very wide range of studies, right? And we need to do all of that. So, and like I said, to study the brain, to do all that, there are so many different approaches and so many different ways to interact. The non-invasive control, light, sound, electromagnetic induction, right? The MRI, the so-called MRI, optogenetics. There's also neurotechnological toolboxes, such as photopharmacology, especially non-invasive. How can you then impact the structure without touching it, without impacting it, without physically interacting with it? So using light, using sound, using electromagnetic induction is great. So optical signals, acoustics, and electricity, and things like photopharmacology and optogenetics. It's a very, very powerful and functional MRIs. So very powerful technique. And this is a very short presentation, but you see there's so many techniques for non-invasive control. So let me focus on these two, optogenetics and optopharmacology. So these two are very, very powerful techniques, and I would like to focus your attention. These were developed and became quite prominent. So anyways, let's start with the optogenetics. So what is optogenetics? Optogenetics is essentially is about non-invasive activation of and excitement or suppressing neurons. Okay, so that's what it's all about. And this started back in 2003, right? This first paper was actually published directly, light-gated Catian selective membrane channel. So you see this green bacteria, and you see light, and you see these are bacteria that live in the sea. And when there's light, they actually dive, and during the night, when there's no light, they actually travel to the surface. And it's true. Actually, you can, if you put it in lab, they'll do exactly the same thing. So they will go away from the light, and if you switch off the light, they will go back. So why do they hate the light? So I mean, what's with the light? And it turns out that they have these green algae have the rhodopsin channel. So the rhodopsin channel. So this one, actually, these membranes that are light sensitive, and like the rhodopsin itself, these actually have the channels, and this channel is actually cation selective, as it says, cation selective. So it's a light-gated cation selective membrane channel because it works with calcium and potassium. So like I said, and this they actually added it to flowers, and they received some incredible result. So this Nchhl, as a German scientist that published it in 2003, it was the first work with this green algae that demonstrated this kind of effect. So and then they actually took this DNA and took it to the laboratory. So I mean, he failed first, but his employee Boyden actually did rapid activation of neurons in mice, which is quite interesting. So they tried to stimulate hippocampus. So they didn't have the answer, and it was a laser. They used laser, and the laser was very strong light source. And that actually started the optogenetics as a science. It turns out that actually if you use laser, if you use a powerful source, you can activate it just using this sharp bursts of light, like the likes of laser. You can create this kind of spikes. You see, you can actually stimulate neurons, and you can correlate it with the frequency 5 Hertz, 10 Hertz. This is the light. This is light impulses. You can operate at 5 Hertz, 10 Hertz, 20 Hertz, or 30 Hertz. So, and this is what the human brain operates on. So by bursts of light, you can activate certain parts of the brain. So you can activate and reactivate during neural pathways. You can actually cause them to grow. You can cause them to regrow. And it turns out that using this, you can actually express it in the brain of a mice and then the brain of a human. So there are certain light-sensitive elements, and by adding these algae, you can actually stimulate the brain. And you can actually go further. You can add this, what do you call it? This laser-inducing rod, tiny wire, and it turns out that you can actually control the mice. You can control what it does. Pretty incredible. Pretty incredible. Yeah. So you can control the actions of a mice by stimulating it with light. So that's optogenetic control of the neural excitability. So, like I said, they were thinking about how do you actually, well, yes, you can excite it using rhodopsin channel, but how can you actually suppress it? How can you slow it down? And they moved to a different thing. It turns out that the so-called proton pumps, these proton pumps, that can also cause hyperpolarization of the cell. Then they cloned it, and it turns out back in the 1980, there was this chloride pump. Chloride pump actually exists in a bacteria that operate in Africa in salty lakes. And so that a tremendous amount of this bacteria, so they take the energy of the sun and they process it and produce energy, because in the salty lakes, the concentration of potassium chloride is very, very high. So, I mean, the level of salt, I mean, just there's so much salt that, I mean, I've seen this salty lake. I've never been there myself, but it's incredible. And it's almost like a, because it's covered with salt, it's like a purple colored bacteria. So the whole lake is covered with this bacteria. It's pretty amazing. So they have this chloride pump. This chloride pump is controlled by light, and this is yellow light. So rhodopsin, by the way, is activated by blue light, which is 480 nanometers, but this one is 460 nanometers, which is the yellow light. And like I said, so what you have here, this is basically the story of rhodopsin channel, and the point is that right now, so we know how to excite it, and we know how to suppress it. So, like I said, this Cathian selected light-gated channels that cause the excitement or they cause the suppression. You have these pumps, nitric pumps and chloride pumps that actually cause the neurons to slow down. Or there's also other things like you can, like I said, you can model, you can do control, like a control, and the system using different types of lights, different types of lasers. So, and this is a very exciting area. It is growing very, very quickly, and particularly in Russia. Russia is at the forefront of this innovation. So, the University of Physics, Professor Gardiev, actually cloned this new type of bacteria, this new chloride pumps. Pretty exciting, molecular chloride pumps. So, and it's all controlled by light or controlled by electricity.
Чрезвычайно быстро развивающимся. Вот. И если посмотреть просто на...
So, like I said, let's look at the scope of optogenetics. It covers all levels of brain function. That's the point. You can use it for synapses, and this is very important, right? Because you can activate specific synapses. This is super important, right? You can activate specific neurons. You can activate specific local circuits. So that means that you can selectively stimulate the brain. You cannot do it with electrophysiology simply because when you stimulate it with electricity, so then you like a less specific. But with this, you can easily be very selective. So you can selectively activate specific types of cells. You can do fast activation of neurons in the synaptic level scale, and you can control animal behavior. Yes, think about it. These particular cells, for instance, local circuits, you can stimulate local circuits. Or, for instance, interneurons. You can stimulate these particular connections. You can study what parts are active and which parts have terminated. Or you can study on the level of cortex of the brain, or you can activate the whole brain, right? You can stimulate part of the brain, certain elements of the brain, or the whole brain. And therefore, you can control the behavior. So essentially, you open the cortex and you can stimulate it. You can actually observe what is happening in the brain. And with that, the coolest part about it, you can actually stimulate using light. You can have this light control device. And that means that by exciting or by suppressing, depending on the type of light, you can basically make this mouse do whatever you want. So potentially you can manage pain, right? You can manage pain centers, you can control epilepsy. There's so many different studies and so much research where you can study epilepsy, you can control epilepsy, you can use optogenetics to control it, you can control Parkinson's disease, and there's been a tremendous tremendous research in the Parkinson's disease that specifically indicates what areas you need to stimulate to alleviate the symptoms of Parkinson. Very, very cool. Without taking too much of your time, I mean, one hospital in France, I think they did it long ago. They stimulated using electrodes, using certain frequency, and it turns out the Parkinson patients actually stopped being Parkinsonian. It's pretty incredible. So they no longer shaking, they no longer have pain or anxiety attacks and things like that. So this is a high frequency stimulation, and it's very popular now with the Parkinson disease.
Светоуправляемых структур
So, like I said, you can use it on animals, you can use it on humans, of course, and that's the most important bit. So you can actually apply it to humans, which is the coolest part. So, and you can also treat schizophrenia and drug addiction. Yes. So you can, yes, you can treat drug addiction, exactly, yes, drug addiction, you can treat stress, you can treat depression, you can treat anxiety, all these diseases. Also vision and hearing restoration. That's what you can do. This is where I see there's a tremendous potential for, especially with patients. Loss hearing impairment or vision impairment, they can do so much. So the reason I'm talking about the vision impairment and hearing impairment, simply because it's just one of those areas. So especially when you stimulate the retina, so you can see this restoration of hearing and vision. So phase 1 to 2 trial, safe and tolerant so treating blind people, people with severe degenerative disease of retina, so mostly related to hearing and vision. So you can stimulate retina, and with that you can restore hearing and vision to a significant extent. So without going into too many details, what I'm saying is just it's just one of those areas so that is particularly important and very popular, because so many people in the world have this or that form of hearing impairment or vision impairment. And in Germany, there's a lab that is specializing on this particular area. And we had this conference last year at a university. It's an amazing work that these Germans did to stimulate. And so with that, I think we're done with optogenetics because the time flies. And let me just say that the benefits of optogenetics as a non-invasive therapy is that it can selectively activate and inhibit certain types of cells. So it's so we're talking about millisecond reaction. So the next one is photopharmacology. So I could read you lectures about that, but we don't have time. So photopharmacology is about creating the use of chemical compounds capable of controlling functions of biological molecules by using photosensitive switches. So that's what it's all about. So, and as far as application, again, we're using chemical photo switches. We're using chemical compounds that can control cellular activity and activation specific synapses and receptors. And these are, as we call, enzymatic catalysts. You can do it by controlling ion channels. So there's certain molecules that, as you know, switch upon a radiation between different cis and trans isomers. And these these molecules can be controlled, and they change their function depending on the induction of a chemical compound. You see, they can be open, they can be closed, right? So they go from open to closed. Or the polarity change. So this happens. As a benzene, for instance, you see, it goes from trans to cis. It becomes 2 times shorter. Think about it. Can you imagine that something becomes 2 times shorter? This kind of structure, see? And you also see change these benzoid rings. So they change, they rotate. It's pretty cool. If you take as a benzene and then link it to the effector, so if this effector is a neuromediator, so that means that in a certain conformation, it will either be in the on or off position. So in the trans, maybe it's got to be off, in the cis, it's got to be on. You can also anchor it. You can anchor it to a certain section of the protein. That's also very, very cool. Right? You can have the effector, the linker, the switch, and the anchor. So this structure becomes very sustainable. So you can, play with it on, off, and use it for control. So these are the basic principles. You can use, of course, ligand. It can be glutamate, it can be GABA, it can be glycine, it can be dopamine, it can be serotonin, it can be adrenaline, it can be other neurotransmitters. So again, you use the anchor, the linker, the switch, and the ligand. And with that, you can create this, functional structure. Like this one. This is a glutamate receptor activation. And by the way, let me remind you, the audience, that glutamate receptors are exciters in the brain. By the way, this is a key exciter in the brain. Right. And this is the kind of structure that we receive. So here's the light. You see ultraviolet. You see that these neurons are excited. Voila. These are it's a zebrafish reaction. This is a zebrafish, and you touch it, and it swims away. But using ultraviolet, you see, it's inactivated. So the glutamate receptor is activated, and that suppress neuron activity. So it's like it can't move. So it doesn't swim away. It's pretty amazing. So I used diazepam. The diazepam, I don't know if you know it, but diazepam has been one of the most frequently prescribed medications in the world since 1963. Yes, the highest selling medication, the bestseller in the United States. Because why? Because it causes activation of GABA receptors that are, as you know, arresting receptors. So, and the GABA receptor is based on benzodiazepine site. So, and this benzodiazepine site, they treat it like hyperplexia, epilepsy, things like that. So, like I said, it's a bestseller. So the point is that it's mostly for epilepsy. It's been a very, very popular drug in the United States and just across the globe. Right. Also anxiety and insomnia and things like that. So what we have done is a fulgimide-based photochrome for GABA receptors. So we connected diazepam, so it's a ring open and ring closed. So you can open it and close it. And it turns out that this particular structure, so when you add it to the neural cell, right, or to the cell that is responsible for the GABA receptor, so you see that it's either closed where nothing happens, or when you add it, you activate it, and it produces a reaction. So, and the open and close is done through ultraviolet. So that means that it's a photo-controlled potentiation device, molecular device. Right, so that's, you can control reaction. You can cause an anxiety, or you can stop anxiety at will. This is very, well, unfortunately, we run out of time. I'm super sorry. Yeah, two slides. I'm almost done. 2 slides, and then we're done. Sure. So what we received is an azobenzane-based photochrome for GABA-R. So, and what you see here on the slide, again, induced by ultraviolet, it can be on and off. It can either excite, or it can, again, block the receptor. And that's the whole thing. So without going into too details, but it's a super cool stuff. Again, these are non-invasive therapies, and you can actually modulate synaptic control, and therefore can control activity. This is a very, very powerful blockers, light-controlled, light-induced blockers for cis-loop GABA-Rs. And on this slide, you see, again, a couple of new examples. So you can inhibit receptors that fire and cause epilepsy, schizophrenia, drug addiction, anxiety, stress, depression, etc. So photopharmacology is a really, really cool area of studies, as well as optogenetics. Okay, and what I'm saying is that these are non-invasive and potentially tremendously important for the humankind. Thank you, and sorry for going over time. Yes, 7 minutes over time. Oh my goodness. Yes, it's okay. It's fine. It's party time anyway. So the next lecture is about virtual reality.
Jay Slater, are you with us?
Yes, I'm here.
Hi, Mel. Sorry, Mel Slater, professor from Barcelona, and his talk will be about virtual reality. I think we have to kick on because we're a bit late on time, but you will have your time and plus probably. We are not rushing anywhere.
Okay.
All yours,
Thank
Mel.
you. Thank you. I will start now.
Please share your screen with us.
Yes. So you can see the screen?
Yes, Mel.
Okay, thank you. So first of all, thank you for inviting me. Today, as was said, I'm going to talk about virtual reality, in particular virtual reality in psychotherapy. And I'm going to introduce a particular technique that we developed called Converse Self, Conversations with Yourself in Virtual Reality. So my talk is going to be in key illusions of virtual reality, then virtual reality in mental health, then virtual embodiment, self-counseling, and then some conclusions. So the key illusions, there's 3 key illusions of virtual reality. And the first one I call place illusion. And this is the illusion that I am here in the world depicted by the virtual reality. I'm not in the real world, but I'm in the virtual reality world. And this is caused by sensory motor contingencies, which operate much like in everyday life. So you turn your head, you bend down, you look around things, you use your body to perceive much as you do in physical reality. And this gives the brain the illusion that you're in the virtual world. The second illusion I call plausibility. This is the this based on 3 aspects. One, the virtual world is responsive to you. For example, you smile at a virtual human character and it smiles back to you. The second one is something personal in the world. For example, virtual characters look at you, or virtual people pass you when they're walking and they make way for you. And the last one, which is the most difficult, because the first 2 are just a matter of programming. The last one I call congruent, which is that when the virtual world depicts something, if you're an expert in that area, there are things that have to be right. Otherwise, you reject the experience. And they could be very tiny things. I'll give an example later. The last illusion I call body ownership. In virtual reality, when you look down towards yourself or in a mirror, you can see a virtual body that's life's your own. Back to the detail later, but this is based on multisensory integration, where, for example, you move and the body moves, the virtual body moves the same as you do. So place illusion is a perceptual illusion. If for some reason it breaks, it comes back again, it reforms. The plausibility illusion is more of a cognitive illusion. If it breaks, you lose interest and it doesn't come back again. You don't get this illusion again. And the last one is a perceptual illusion. Again, this is persistent. If it breaks, it comes back again. So my thesis is that these 2 things together, place illusion pi and plausibility psi, lead to realistic responses to situations in events in the virtual world. So, for example, by realistic responses to situation in events, I mean that you respond appropriately at the physiological, behavioral. So, for example, when people go into this virtual world, which depicts a room with a big pit, a big hole in the ground that is 18 meters below, they get anxious. And this is, in a way, it's crazy because there's nothing there. There's just some pixels on a screen. But nevertheless, the place illusion and the plausibility lead to appropriate responses. So I have a strong view of place illusion. This is the illusion that you're in the virtual place, in spite of the fact of course, you know you're not there. You know you're wearing a head-mounted display. You're in an ordinary place, but you know it's not true, but nevertheless, you have this strong illusion. And this shouldn't be confused with many different interpretations of this idea of presence. which are things like attention, interest, flow, task performance. This is a separate illusion, the illusion of being in the place. Now, this definition of place illusion is not applicable to our normal everyday experiences. The fact that it occurs is witnessed by the surprise that people have when they enter virtual reality. And then after this initial surprise, they kind of adjust their perceptual apparatus so that the world makes sense. And when I say surprise, I mean it in two ways. It's a perceptual shock, and it's also a surprise in the technical meaning as entropy. We need to minimize surprise to be able to function in a world, and in particular in the virtual world, we need our perceptual system to stabilize, and so that we can understand what's going on. And here's an example of an experiment we did many years ago. In this experiment, participants experienced a virtual reality that gradually formed. So what happened is polygons were appearing, and triangles were appearing in the world at random. And after a while, the world formed into one of three different things. In one condition, it was a stress-inducing world where participants realized they were standing on top of a column very high. There was a second environment, which I call the non-stress one, where participants were in the same environment, but they were at ground level. They weren't high up. The third one, it just stayed random. The polygons were there, but they were all rotated randomly. The world never made any sense. And we had two measurements. One was the head gaze direction entropy, which is the amount of randomness there were in your gaze direction. And the second one is skin conductance responses, which measure the degree of arousal. And what happened was very interesting. In this graph, the solid line is the scan path, the head scan path entropy. You can see at first it goes very high because people are looking around. The world looks random. They don't know where to look. But after a while, it forms and the entropy drops. And then it kind of stabilizes as they start looking around again. And if you look at the same time that the entropy starts to go down, the skin conductance, the arousal starts to go up. This is in the stress-inducing condition, where suddenly they realize they're standing very high on top of a pillar. So at the same time that the world form became something that they could comprehend, their perceptual system settled down and they understood it, that's when they got the arousal. However, in the no stress condition, we see the same pattern for the scan path entropy. At first, the world is random. They're moving their head around a lot, then it stabilized. But if you look at the skin conductance, the arousal, it more or less correlates with that. There was no special arousal that was caused by like in the first stress-producing one. So this presence, it's a real thing. It really happens. And this is like some nice objective evidence about that. We can look at this further because there's a clear negative correlation between the level of arousal, the skin conductance responses, and the scan path entropy. Plausibility is rather more difficult. As I said, you can get place illusion by simply having appropriate affordances for perception in the virtual world, like in the real world. But plausibility is much more difficult and much less understood. Plausibility is the illusion that the events happening are real. So we did an experiment with medical doctors that illustrated one failure of plausibility. So the doctors interacted with virtual patients who unreasonably demanded antibiotics. The doctors became quite stressed dealing with these virtual patients. The more experienced doctors were less inclined to prescribe antibiotics, and the more junior doctors usually gave in and prescribed the antibiotics. But what was interesting was one failure of plausibility. If you've been to a doctor these days, they usually don't look at you very much. They look at their computers on the screen. And in our virtual world, we couldn't have a virtual computer on the screen because it doesn't have the resolution that we needed. So many of the doctors complained that this brought them out of the experience. So plausibility is an exceedingly complex topic. And it doesn't mean realism. It means, for example, small items that you expect to be there. If they're not there, if they don't work, then you lose plausibility. Here's an example of how complex it is. this is an example from fear of heights, an experiment we did to look at cognitive behavioral therapy for fear of heights. And participants were on top of a tall building, and there's a whale swimming in the middle of the atrium. And nobody said, oh, this is ridiculous, it doesn't work. They just accepted it. So why do they accept this? But they don't accept like a small item missing, like the computer in the doctor's experiment. So it's a very complex subject. So I'm going to talk now about virtual reality, and obviously it relies on this sense of presence, this place illusion and plausibility. Virtual reality is probably the widest used application of virtual reality in the last 30 years. It's typically used as part of conventional treatment. It obviously has economic and logistic advantages. If someone has fear of heights, they can experience fear of heights in the doctor's office. They don't actually have to go to a real building. And it's used most often with cognitive behavioral therapy, where you expose people to the feared situation. They've got to get some degree of anxiety and their beliefs are challenged and reframed. So can virtual reality be used to trigger the anxiety? So the evidence strongly suggests that yes, people will have anxiety in response to a virtual precipice, fear of heights, for example. People with fear of public speaking also have fear of public speaking in front of a virtual audience. People with paranoia will become paranoid even with virtual people. So here's an example of fear of heights. In this experiment done by Meehan, again, it's a long time, nearly 20 years ago, participants had to go into the second room through the door and find their way to the chair on the other side. And most people exhibited a strong anxiety, an increase in heart rate. And if also when they stepped on the ledge, they felt it on their real feet because they were standing on a little platform which they didn't know about, then the heart rate went up even more. For social phobia, exposure therapy using virtual reality is usually been done in the domain of public speaking, and there's many papers. I've sent these slides to the organizers so you can look up some of these. Here's one again we did around 20 years ago. This is people wearing a head-mounted display speaking to a very positive audience. So whatever you do, they're smiling, they're nodding, they're very happy. It's very easy to talk to this audience. Now compare it with this audience. This is really hard to talk to this audience. Even experienced speakers couldn't talk to this audience. In spite of the fact it doesn't look very real, it's very like a cartoon. People have this illusion of presence, the plausibility and place illusion, and they respond appropriately with anxiety. On psychotic disorders, there's been a lot of work over the past 20 years led by Daniel Freeman of Oxford. This also includes realities usually used as an extra. It's not an intrinsic part of the therapy, but is used as the method of exposure in exposure therapy. So it requires the real therapist. All the studies show that it's at least as beneficial in outcome to traditional methods. And there's a recent meta-study that reaches these conclusions. Again, in the slides I've sent to the organizers, this link activates and it takes you to the actual paper. Now I'm going to move on to the third illusion I mentioned, which is the main part of my talk, which is a body ownership illusion. And first of all, I'm going to explain what a body ownership illusion is. It usually occurs when there's multisensory data that involves a contradiction that the brain resolves by producing the illusion. So this one is called the Pinocchio illusion by Lackner, 1988. So in this experiment, the subject is the one sitting behind. He has his eyes closed. And the one sitting in front, only he's needed for his nose. And the experimenter taps the nose of the subject and moves the finger of the subject to tap the nose of the one in front. And this tapping is synchronous, which is very important. So from the point of view of the subject, it's okay. He's feeling his nose being touched and he's touching a nose with his finger. And the brain makes these into one percept. It combines them into one percept. I'm touching my nose. But it doesn't make sense because your arm is outstretched. So how does the brain solve this? It's impossible for me to describe this. You have to experience it. It gives you this illusion that your nose has grown very long. So this is a a very well-known illusion in cognitive neuroscience. And another even more well-known one is called the rubber hand illusion. I'll show you this with a video. So what's happening here is the left hand is a rubber hand and the right hand is the subject's real hand, which is out of sight. The experimenter is tapping both hands synchronously. And what happens is that after a while, the feeling of proprioception passes to the rubber hand. And if you attack the rubber hand, people respond very strongly. So it's a very strong illusion. In virtual reality, we do this a slightly different way. Typically, we use not visual tactile, but visual motor integration. You look down, you see a body substituting your own, which is life size. You move and the body moves with you. You see it move. And also you see it move in a mirror. And typically people get a very strong illusion that the virtual body is their body. Of course, they know it's not their body. It may look quite different, but it's a very strong perceptual illusion, which is you get rid of the illusion by closing your eyes. So there's many papers that have shown that this illusion works in virtual reality. And what's even more interesting is that when you change the body, you change aspects of the mind. So actually, if you embody white people in a black body, their racial bias decreases. You put adults in a child body, they become more childlike. I'll just mention one more. If you put people in the body of Albert Einstein, they do better on a cognitive test than if you put them in another more ordinary body. So when you change the body in virtual reality, it has big effects. Even it can result in pain reduction depending on the aspects of your body. So now I'll come on to the idea of self-counseling, which uses this idea of body ownership. So the basic idea of this self-counseling is that we're typically much better at giving advice to a friend rather than to ourselves. So even though we talk to ourselves a lot continuously on the inside, probably all of us are doing it right now, saying things to ourselves on the inside. And typically when you talk to yourself on the inside, you can't get out of your own way of thinking. If you have a problem, you can't get out of it because you have a particular way of thinking. But if you're talking to a friend, usually you can see another side to their story and help them. Now, suppose you could objectify the you that you talk to when you talk with yourself. Maybe talking with yourself as if you were another person would be helpful for solving your personal problems. So that the starting point of this idea is that we can make a scan of your real body and then put that body in virtual reality with you inside it. And also in virtual reality, we can embody you as anybody. Like I was saying before, a white person in a black body or an adult in a child body, we can embody you as anybody. So for example, we could embody you as Sigmund Freud. When you look in the mirror, you don't see yourself, but you see Sigmund Freud staring back. So in the first experiment we did, first of all, we embodied the subject who's on the left here in their real body, in a likeness of their own body. And they explained the problem to Sigmund Freud. And then they became Sigmund Freud. They were in Freud's body and they saw and heard themselves describe that problem. Then as Freud, they could give back an answer. Remember, the type of body you have affects how you are. It affects your attitudes, behaviors, and so on. So then they could keep switching back and forward, having this conversation with themselves. So in our first experiment, the participants discussed personal problems with the counselor, who was Freud, and in general, all participants improved. But if they're embodied as Freud as the counselor, they improve more than when embodied as another copy of themselves. And if the counselor body moves synchronously with their own movements, in other words, they get strong body ownership, then they improve even more. Embodied Freud with the body moves like you move led to the best results. So we did a more recent study where we asked, is it the body swapping here that's important, or do people improve simply because they talk about their problem? So we had an experiment with two conditions. In the experimental condition, they swapped bodies with Freud, just like I said. And in another condition, they spoke to a pre-programmed animated Freud who asked the participant questions, but there was no body swapping. So the sequence of events was, first of all, they met a psychologist for a screening. Then they met the psychologist before the virtual reality to frame the problem. Then after the virtual reality, we took some measurements. Then we took some more measurements after 1 week. And in all the conditions, the body ownership was high. Whether they were embodied with their own body or with Freud, it made no difference. First of all, we scan the person. To get a likeness of themselves, and what you end up with is a virtual copy.
Okay, so what is the problem you'd like to talk about today?
My problem is that I like to take better care of my health. That usually I'm sitting for 8 hours in my job at work, and I don't get any exercise, and I feel like I should maybe do something about that.
Okay.
Raise your right hand. Now look in the mirror to your left. When the light next to you turns green, explain the problem to the person in front of you.
So when I notice that I'm delaying going to the gym after I come back from work, I think that I should go because I want to take care of my health.
Now listen to the person in front of you, and when the light next to you turns green, reply and try to help them find a solution.
So when I notice that I am delaying going to the gym after I come back from work, what seems to be the problem.
Why do you think that you delay? Why do you think that you're not going? What seems to be the problem? What seems to be stopping you?
So that's the idea. The video just carries on. They keep swapping bodies all the time, from time to time, having a conversation with themselves. And here's part of the results. The results are actually quite long. It's published in a paper. But for example, through this technique, people in the experimental condition where they swapped bodies with Freud, they got better knowledge about their problem, better understanding, they got new ideas, better control, and it helped them. And what was interesting is we also measured prior to the VR, after the VR, after one. Of course, prior to the VR, there's no difference between the control and the experimental group. But after the VR, there's a big difference. Those in the experimental group, more than 80% of them reported a positive change. And that lasted at least for 1 week. We don't know if it lasted longer. We couldn't continue with the experiment, but these were encouraging results. This was a journalist from The Guardian tried this, The Guardian newspaper in England. He tried this, and he had a very interesting experience where he said, now I switch roles and I'm Freud advising me. The first time I do it, I'm too self-conscious. Slater gently suggests that I was not fully immersed. I ask if I can do it again. This time I go for it. It might not be the way Freud would have responded, but I listen to my problems and I tear into myself rightly or wrongly. And the rubbish. I verbalize everything and dismiss it as solipsistic nonsense. I then return to my own avatar. Good points, well made, I say to Freud, and I meant it. This is somebody, again, a journalist from the New Yorker magazine, who spoke about some guilt he had in his mother was far away from him, and he said, soon I fell into a rhythm. Freud and I talked for about 20 minutes. He was in insightful. He said, remember, it's himself talking. He was insightful. He said things I'd never said to my very life. When I took off the headset, I was moved. I wanted to tell myself, good talk. From his perspective, I'd seemed different, sadder, more ordinary, incomprehensible. I told myself to remember that version of me. So you'll see yourself as another person from the outside. Similarly, and in the end, she said, after a half an hour of swapping bodies, I finally ran out of questions. I thanked Freud for his help and took off my headset. That evening, I write my friend an upbeat, supportive note. He responds soon after with a phone call, and we have a fun, drama-free chat. And she got more empathy for his situation. Again, she saw herself from the outside and could see solutions that she couldn't see as herself. So my overall conclusions: presence, place illusion, and plausibility are unique illusions that can be generated in immersive systems. And due to those, people respond realistically. So that's why there's been a huge application of virtual reality in psychotherapy in the last 3 decades. My own interest, the virtual early as a therapy is all the same, but they use virtual reality for the exposure part of it. But my interest in virtual reality has always been to go beyond using it simply as a simulation of reality, because in virtual reality, we can have impossible but real beneficial experiences. And I'm putting forward the idea that this conversation with yourself in virtual reality is an example. Those of you who know, it's a bit similar to the empty chair technique from Gestalt therapy. In the empty chair technique, you have to imagine somebody on the other chair, but here you don't have to imagine, you actually experience it. So I'd like to thank all the various people in my lab who've contributed towards this work. And all the work has been funded by the European Union in that complete talk.
Thank you very much, Mel. You've done it on time.
You're welcome.
We have 7 minutes behind, but you've done it on time.
Thank you.
Fascinating talk. Our audience is a Russian audience mainly, but there are English speaking people as well. But for the Russian audience, I would remind they may have not been born at that time, but in 80s and 90s, we had famous psychotherapists who were using television, like virtual reality, pacifying people, appealing to them. And my wife, who graduated biological department, and myself, and being complete materialist, she recalls the moment when the speaker was saying, be prepared to start crying. And she indeed started crying. I don't know whether I grasp really the essence of your talk. I'm not a psychiatrist myself, but it's pretty sure that what you're talking about can have pretty materialistic leverage to treat people, maybe, or to make them happier. So,
yes.
Are you connected with medical profession people in your research?
Yes. Well, clinical psychologists, yes.
Yeah. Are those practices being held in European Union at the moment?
Yes, well, we're trying to disseminate this idea, and so far we've only done scientific studies.
Thank you very much, Mel. The
You're
connection
welcome.
is getting
Yes.
a bit difficult, so we move to the next speaker.
Okay,
And
thank you very much
again.
Bye-bye.
There are some questions on the. Yeah. Hello. Hi.
Hello,
Hi,
how
Sandra.
are you?
Hello. I believe you are our last speaker, and I'm glad to announce your talk, which is Cognitive Health, I'm translating from Russian. Oh, no, I have it in English. The most important scientific frontier of the time. In Russian, it says like more challenge of the time, whatever. We're here, all attention to your talk, Sandra.
All right, terrific. Let me share my screen. I am honored to be here. Thank you for the invitation to be part of this. And I call it brain health instead of cognitive health. And I've been doing research as a professor and the head of the Center for Brain Health for the last 3 decades, and really studying the brain at all levels of health, from neural systems to cognitive to psychological well-being to social adeptness, as well as the real-life complexity of what people tackle. And so now we are really transitioning. How can we take the science of what we're doing to help people wherever they are, and can telehealth transform it? And I love that I'm following Dr. Slater, Mel, because we also do a lot of virtual reality and have worked with Skip Rizzo in a number of different studies. So, oops, okay, just a minute. Can you still see my screen?
Yes, we can see your screen.
Okay, okay, cool. So I have nothing to disclose. This is what I'm going to talk about today, is how we're approaching brain health. And you can see that I put it as one word because we actually have a trademark on it, because people typically only study the brain after something goes wrong. And I'm going to tell you how from the scientists, 150 scientists that are working with us at the University of Texas at Dallas, are approaching it in a whole different way. I'm going to share with you the longest, most comprehensive project that we're just beginning to launch, the pilot results that we're calling the Brain Health Project. Talk to you a little bit about the collaborators, but also the reason I was interested in this, and I think it would be really amazing for us to find ways to partner with other countries as we move forward, which we are already doing. So that's why I wanted to accept this invitation from Misha Lebedev. And then I'm going to give you some preliminary results. So as all of you know, and you've been hearing, I love the thing on optogenetics. This is from Ed Boyden, who is one of the leaders in optogenetics. But we know that the brain is the most complex design in the known universe. As we study the different cortical, the connectivity, all of the different brain blood flow, down to the cellular level of neurosynapses, the neurotransmitters. Much of what we've done as we study the brain has looked more from molecular to mind. And what we're taking is to meet people in the middle. So people that have gone from, if we understand it at the molecular level, and then try to understand what's happening at a higher order cognitive level and social agility, what can we do if we understand mind to molecule? So as we change the mind, how does it impact the brain at all levels of connectivity, brain blood flow, as well as neurotransmitters? So these are my key messages that we're going to talk about today. How are we defining and measuring brain health? Really holistically, because to date, mostly when people are trying to understand the brain, they study it in various silos of either psychological health or social problems that people have, or the neural systems, or diagnosing disease. And we're looking at it from a holistic perspective, and we're looking at it from health. Although we all know, and everyone on this call knows, that our brain is the most valuable asset and resource, it's the only organ that we only look at and tend to till something goes wrong, unless we are studying just how the brain works. The second thing that we're doing is we're challenging the status quo. Right now, most people think your IQ is fixed, that your brain is pretty much set by the time you're through your teenage years, maybe through 20. We now know the science is unassailable, that individuals can change their brain throughout life. How they use it is very dramatic in terms of how it impacts it. And our brain grows stronger by how we use it moment to moment. It doesn't take years to change it, but we can see brain changes in real time, or it diminishes by how we fail to use it and can actually degrade the different neural systems that we have. And we're going to talk about future-proofing our brain. People are now saying, and we have an article coming out in molecular psychiatry about how we're moving into a brain economy. So it's really important now to focus on what is it that we can do to keep our greatest asset moving forward as we move to this. I wanted just to share a little bit. I'm a professor at the University of Texas at Dallas. The Center for Brain Health has a campus of 3 major entities. The center itself, which is all focused on research with 125 scientists, research clinicians. This building is our Brain Performance Institute, where we're training teachers and educators and business and government leaders. What is it that you can do to make your brain years, the best brain years ahead of you? And we also have a brain imaging center where we've got 2 state-of-the-art Siemens scanners where we're looking uniquely at markers of the brain getting better. And now we're launching the Brain Health Project. So how are we defining brain health in a whole new way as a category breaker? And the reason I say category breaker is because that's really what we're doing. We're bringing a whole new field of discovery, a field of where students can learn for really healthcare as we look at this. Right now, when people want to know about their brain, if something's wrong, they go to their doctor, and it tends to be general practitioner. It could be a neurologist to see, I think something's going wrong with my brain, and you see, what is it? Do you have ADHD? Do you have some type of psychiatric disease? Do you have Alzheimer's disease? What we want people to do is to think ahead of time, what are things that you can do right now, regardless of what age you are, to build resilience and build reserve, to build cognitive capacity. So we actually we take the lifespan, and we have over 50 funded research studies that we've looked. Can people expand their brain at all levels of health before anything happens? And then, of course, if something happens, then we're interested in, can you rebound? Can you restore cognitive function? And we're looking at neural systems, psychological health, and cognitive systems. So we are category breakers because we're trying to move the brain into health, just like we've done for heart health, our teeth health. I often say we focus more on our teeth than we do our brain, even though it's our greatest asset. So if you were to ask me, what's my manifesto of our scientists and different collaborators, it's how can we unlock human potential through improved brain health and performance across the lifespan. So I want to share a video with you. We'll see if it plays. Can you hear this?
What is the first thing that pops into your mind when you hear the term brain health? Do you think of your IQ? Do you worry about Alzheimer's? So, from this moment on, when you hear the term brain health, let's define it as making the most of the brain's capacity to thrive in life. This means that we have multiple paths to strengthen our brain health. Let's start with your brain systems and how they work together to support your thinking, learning, decision-making, and emotions, really all the mental activities you tackle. Next, we have sleep and stress. The level of each is foundational to your brain's health and ability to perform. Now we get to cognition. This is how you think, learn, and set goals. It includes both complex thinking and specific thinking capacities that are required to take in information, process it, come back to it later, and combine it in different ways to create something completely new. Daily life looks at the complexity of your daily responsibilities and key lifestyle factors that impact your health. Well-being taps into your quality of life and emotional sense of yourself. And lastly, interaction refers to your social support, level of engagement, and compassion toward others. All these components are connected. Together, they provide a snapshot of your brain's health and performance. This snapshot, which you get with the Brain Health Index, empowers you to take greater charge of your brain, increasing and extending its health and peak performance. From one time point to the next, the Brain Health Index can help you gauge how much improvement you achieve. Start your brain health journey today and see how far you can go.
All right.
So that's how we're challenging that we're category breakers to define it in health and holistically looking at it from all these components. So now we're challenging the status quo to see how far, how fit people can take their brain and to see if we can achieve for brain health what's been done for heart health. Well, people around the globe every single day know the things they need to do to keep their heart healthy. I wanted to share with you, I've talked to you about the Center for Brain Health, the Brain Performance Institute, the Brain Health Imaging Center. Now we're launching the Brain Health Project. And I wanted to share with you, most of you probably know many of these scientists that are part of our collaboration. We have gotten the world's leaders to say, yes, we want to be part of this and lead in this. If you know Ian Robertson at Dublin, he started neuroscience there. Mark Desposito at Berkeley has said, this is what we as neurologists were meant to do, is to keep the brain healthy. Vince Calhoun was head of the whole human brain mapping internationally. And of course, people know Mike Merzenich, who's sort of the godfather of brain plasticity. All these people are part of what we're doing. They're giving us their IP to see how far, how fast we can build the human brain. What I'm going to share with you is a pilot that we're doing. When COVID hit, we were just getting ready to start with this platform we've been developing for 2 years, where I talked to you about that comprehensive brain health index. We weren't able to do the brain imaging, but we wanted to test out the platform. So a 3-month period where people do the brain health index, they get a coach session to say, these are your goals. What does this number mean? And then we give them some training modules of different cognitive training, stress modules, sleep, that are based on some of the work that our scientists have shown change the brain at all levels of health as well as psychological health. They also get another coaching session, and then they do their post-assessment. So these are the questions that we're asking, and we had 175 people. We had literally 10 days because it was a very quick shutdown. And so we opened it up and people enrolled. We wanted to get 100. We had to stop at 175 because that was the capacity because of the coaching that we had. But we wanted to say, in this time period that we've shown work, do people show a gain in their online brain health index? And can they understand what this holistic measure could mean that we could explain? And what did we find in terms of group results? And then how is it going to guide us into precision brain health? Because it's really more about you as an individual, not your group results against someone else. We were also interested, number 2, in the effects of age, gender, education, and whether the amount of training that someone utilized was what impacted the gains. And then the relationship of changes, improvement in one area, how did we see generalization to other areas? So this, again, is what the Brain Health Index is. People get this number, and it's like, what does that mean? It's not like 73%. It is you against you. It's not you against the rest of the world or against people that are doing the same profession. We want people to get out of competing and just be with themselves. These are the different components that makes it up, as we talked about: cognition, daily life, psychological well-being, the mindset, responsibilities, as well as social agility and adaptness. So these are the preliminary results of our work. So first of all, what we wanted to ask is, the Brain Health Index, is there an age difference when we look at it? Because as you know, almost every measure when we're looking at brain, we have to adjust for age because we really accept aging as almost this acceptable decline. But what we're looking at are measures that don't have a ceiling effect or upward potential. And what you can see here is this is the Brain Health Index. We found that there was not age effects, and we had people enroll from ages 18 to 87. We wanted to test, does the platform, can people of all ages work to understand how they can gain information from it? When we looked at gender differences, again, we did not find a difference between male and female in terms of what they were doing. And then we did have a highly educated group. Most people had a bachelor's, although some people did not because we started at college age, but we did not find the education of that. Now, this is looking at, did we see a change when we measured their brain health index after they engaged in the training? And this is the same period of time in our 20 randomized trials of training in person that we've shown brain change at all levels, increased brain connectivity, brain blood flow, as well as higher order reasoning, improvement in psychological well-being, as well as social adaptness. We wanted to see, does this platform help individuals at the same level? And what this is showing is the change score in the Brain Health Index. And what you can see from here is 75% or more of our group increased very significantly, and on average 10 points. Well, that's pretty dramatic. As I mentioned to you at the outset, this was a time when COVID hit. So think about the stress that many of these individuals that were just starting to engage in. We also wanted to know, did the change, because a lot of people think, excuse me, that maybe young people can improve more, or maybe older people have more to gain because they've lost more, and we really didn't find any age. So this is across the age span that we got, and it looks, there's a lot of scatter. Obviously, we had more people that were in the 40s and 50s, but we had a really good distribution of age, and these are gender. We did not see either a gender effect in terms of how much change, so men or women didn't get better, nor did we see a difference in age. So that was probably one of the most surprising things, because I thought maybe older people like myself wouldn't take to this technology platform or to show gains, or that younger people wouldn't see the benefit, but we saw the change. The third big question that we asked is, does it matter how much training you do to see how much gains? And what you see along the x-axis down here is the different training modules that they had. And about right here is where they got a coaching session after their Brain Health Index. They had another real live Zoom coaching session, and then another one at the end. And what you can see, this is the strategy training that we did with cognitive strategies. How do you become a innovative thinker, big idea, algorithmic thinker, as well as manage stress through teaching strategies. And then we gave them information, just straightforward information about sleep. And you can see that there was a pretty good rise in terms of the more utilization individuals did, the better they got up to a certain point. And the difference between this to this point was really just that it was giving them information about sleep hygiene. Dr. Russell Foster is one of our collaborators from Oxford. This tells us that practice effects, it didn't matter, just taking the Brain Health Index. So people always say, well, maybe it's just that they took it 2 times, but we didn't see practice effects. And we didn't see necessarily that those more motivated were the ones that gained. Just to remind you, when we look at this index, it is a holistic area. It's not just looking at single measures like we typically think about brain, but we saw changes in terms of how they all aggregate together. And if you were to ask me, what was the aspect of the research, this first pilot? We enrolled almost to 200 people, but our goal is to enroll 120,000 people and follow them for a minimum of 10 years. So this is just for us to learn how the platform works. This here is what I'm most excited about, and that is, are we able to look at changes in one domain and see how it generalizes over to other domains? Because as we know, it's one thing to not be depressed, but if you still aren't social or socially isolated or lonely, you're not going to make it in life. Or if you really are a very smart person, but you're depressed and in bed all day, you're not going to improve. So we're interested in how the different areas. So we looked at the change in the cognitive domain and how they mapped onto changes in these other domains. What you can see here is that we saw a generalized impact, that when we see individuals improve in one, we typically see a generalized impact in the others. So this is, if you were to think about, here's cognition improving in innovative thinking, big idea, how many possibility interpretations can you come up with? We're very interested in flexibility of thinking, as well as people that have much more strategic thinking and they know what to focus on or not. So it's very different from the traditional neurocognitive testing that we tend to do. And what you can see here is that as a profile, people got better in their overall daily life, their fitness, their activities, their outlook. Sleep going down, that actually is good. That means they had less sleep complaints. Social agility and social compassion, happiness improved, as well as the other areas. So this is really what I'm most interested in as we look at brain health. What is it that makes you holistically more functional, regardless of where you start? And I just want to share with you some real quick individual cases, because people always like, yeah, that sounds good, but what about me? So I'm just going to highlight a couple of cases in the last few minutes of this presentation so you can get an idea of what we were finding. This gentleman was 61. He had retired and moved out to a new location. And he said, I'm really happy with my brain. I don't need any help. So we're interested again in building reserve and resilience and people to embrace how far, how fast, how fit can you make your brain? And his brain health index was 57. And he says, well, I don't know what that means, but I feel like I'm pretty good. This is how it breaks down. And we do a lot of educating in terms of what the different parameters are. He set goals after he got his brain health index. And he said, when he got his post 3 months later, after 12 weeks, you can see a very significant gain. One of the biggest areas was in cognition, and it really was this innovative thinking. He saw different ways that he could think more adept, that he'd gotten into rote thinking. Even at 61, he was not really kind of pushing new frontiers. This was the thing that surprised him the most. He said, I've always defined myself as an introvert, someone that I don't need to social relationships. But with COVID, I realized I really did want meaningful relationships. And the training helped me to realize that I need to reach out to people more. So we saw a big jump in his social engagement and what he was doing. And so then, of course, when you have more meaningful relationships, his well-being improved as well. This is a college student. We're now enrolling 100 college students. I'm really particularly worried about college students during this time of COVID because the whole college experience is different. The social, engagement that they're used to. And we know that stress, depression, suicide is at an all-time high. This was a very bright student. UT Dallas has one of the largest number of national merit scholars in the state. She's smart. She said, I always pride myself. She got a 48. She said, that's good. She had to move home, which was out of state. It wasn't here. And her post-testing was a 69, and she improved. What she said that really stunned her again is this social interaction. While we worked on her cognition and helped her with stress management, she said, my mom has always told me I never was sensitive to others. And she said she noticed a change and she didn't know where it came from. And she said, if I were to say what impacted me the most, it's realizing how I can be more tuned into empathy and how my cognition drives that empathy as well as well-being, because she was feeling a lot of stress, overwhelmed, and really not able to start her day. So we're now, over the next, within this, we've started enrolling 100 right now to see how we can impact them at this pivotal time. Now, of course, you're asking, and I know I just have a few more minutes, did everyone improve? And they didn't. This was an individual who was in her young 70s. and she lost ground. She actually developed COVID during the course at the time and was just coming out of COVID at the time that she took this. And she's like, I feel like I shouldn't take it. I can tell I'm not as good as I used to be. And we're like, no, you need to take it because we want people to see if they can regain capacity. Remember, after, they're through with the medical, then we want them to go back and say, I want to be as good as I was before or better. So she was able, while she did lose ground, she said, how soon can I take it again? She's doing the next round of training. So she's all gung-ho to try to rebound. She actually had done 2 brain health indexes prior to this time in person over the last 3 years. And what we were excited about was her index was pretty much the same with this online platform as it had been before. I just wanted to close with this slide because I think worldwide never has something brought us so close together that we're all dealing with the stress. And it's not just if you have it, it's affecting our capacity to move forward, the jobs that we have. And if you'll look at our website, you will see some different seminars that we're talking about why this is a brain economy and how we need to really build as much resilience across the lifespan, across our countries, work together to solve the complexities of what we're here about. This is really our vision, is to empower people everywhere to futurize their fullest potential. And, just hearing some of the talks and the science that's going on through Russia and some of the other countries, we would love to be thinking about ways to partner and be stretched in ways that we haven't even imagined, because we are really strong about collaboration. If you want more information to follow the Brain Health Project, you can just sign up here to get regular updates at www.thebrainhealthproject.org. Or you can learn information about the center's programs here. So thank you so much for your attention, and I really appreciate the opportunity to share our message with you.
Sandra, thank you very much for your talk. And I do believe that our brain health index was increased during it. Because you had mostly Russian-speaking audience. But I would like to thank you for your crisp, clear English, which was very understandable to Russian ear.
Oh, good. Thank you.
You touched very important things about COVID. And again, it's anecdotal evidence, but all comes from small anecdotal evidences. My wife survived after 2 weeks in intensive care in COVID ward. And she actually is a keen solver of Sudoku, these Japanese sums. And she clearly tested it, and she tells me that her abilities dropped. She was like a high-level Sudoku player. Now she is below medium. And what is very encouraging from your talk, that it will come back. She just needs a little bit brain health index training.
Thank you.
Thank you very much. How you, with all this knowledge, how you move it closer to the medical practice or maybe social activities, or do you have a network of the coaches or brain health index gyms or whatever in Texas? How you envisage this culture, which we have during last years, we have this culture looking after our muscles. Do you envisage the culture looking about our brains? I spent some time in Britain. Old people come together there to bridge clubs, and I think it's great. So what are your thoughts about our gyms of the brains of the future?
Yes, I love it. The gyms of the brain. I think that, I hadn't really expected the technology platform to be so widely embraced and people to learn from it that can make these accessible around the world. So I think the good thing about the brain is you don't have to carve out 30 minutes like you do your exercise gym. if you learn strategies of how to use your brain, whatever it is that you're doing to do it better, and that's really what we train people to do, then you can go on with being the best you possible. So the coaches, you're right, that's our secret sauce that people said, it helped me so much. First of all, most people don't realize that their brain can be stronger because even though neuroplasticity has been around for more than 2 decades, the average person doesn't realize that they can be a stronger, improve their intellect over the years. They think, oh, well, your IQ's fixed and you're either fine until you're not. So our messaging is just as important as activities. And yes, coaching, figuring out how we get coaches. Our next site that we're opening up is a major medical center in the Washington, D.C. area. They've been begging us for the last few months is how soon can we open there, some of our collaborators. So right now, people don't go to medicine unless they're worried. And so it's almost like we've got to get the doctors on board that, no, you can do something to make your brain stronger. So it's a little bit of a education.
That's great. Thank you very much.
Thank you.
Thank you. It was our concluding talk. And now probably it's to Alexei or to Natalia to conclude this fantastic day.
Добрый день еще раз. Спасибо.
Russian, Sandra. Yeah.
Yes, absolutely. We've exhausted the panel today. This was the last talk, the last presentation. It was very, very concentrated because we had several tracks at the same time. There are so many presentations. So it's a great conference, and so much was said about the cognitive health. And if I'm not mistaken, we had like 4 different tracks at the same time, and for different parts, and great presentations, real professionals from different angles, and we had a plenary discussion at the same time. So lots of information. So a very, very busy day. So a very high level of research, very high level of presentation, and at the same time, we had a symposium. As a matter of fact, we had a symposium. And we had like something like 40 different presentations during the symposium. So which is like, I'm blown away. You know, how popular this symposium turned out to be. So this is all part of the Samara Brain Week. Pretty incredible. We see engagements from people all across Russia. So thank you, everyone. Thank you for that kind of attention. And thank you for being with us today. We really, really appreciate it. And with that is just the beginning. Don't forget that this is just day 2. Let's not forget it's a Neuro Week. Okay, we have 3 more days to go. And tomorrow is day 3. Yes, we got to do more. And don't forget that we're going to have workshops. We have like 3 different workshops, all dedicated to different brain functions and whatnot. Lots of different stuff. So brain stimulation workshop, then another one. The invasive brain stimulation therapy, then the magnetic field brain stimulation workshop, then another one. So multiple workshops, and also at 4 p.m. Don't forget that tomorrow, 4:30. Yes, 4:30. We're gonna have an amazing panel discussion. So yes, there's gonna be some crazy, tremendous scientists. We have the best of the best. So lots of great speakers tomorrow. Okay. We're going to be talking about Neuralink, Elon Musk, neural implants, and lots of other great stuff. Okay, so stay with us for this week. And and the Neurobar. Let's not forget about the Neurobar. So for the after party. So anyways, you can go to bcisamar.com. So go there and enjoy. So
Вот, и все, до завтра. Всем приятного вечера.
So I'll see you tomorrow. Thank you.
Всем спасибо большое. Конференция была замечательная.
So thank you, everyone. Thank you to all the listeners. Thank you to everyone who's watching. Thank you for everyone who's presenting. Thank you. It's been a great conference. Thank you. Yes. Bye-bye.
Bye, everybody.
Yeah, all speakers
Bye-bye.
can join
Всем до
Speakers
свидания.
Lounge if you would
Спасибо.
like to
Удачи.
continue.
Спасибо за замечательную организацию.